Welcome to the first part of sixth module, which is Docker Containerization, and the sixth module we call it as containerizing applications using Docker and Kubernetes. So this is the most important and widely sought application by the recruiter presently in the job market. It could be a DevOps engineer or MLOps engineer or a data scientist. If he goes with this tool, he will be selected as quick as possible because this is the widely used tool and it has a lot of demand at this moment presently in this market. So I would urge you to stay focused and put more effort and keep your attention level high so that you can follow up and you can clearly get everything what I'm talking about here in this Docker containerization. So I'm gonna take you through the theory first. At the same time, parallelly, I'm gonna take you through different exercises. So let's jump into the topics what we're gonna discuss in Docker containerization. So here we're gonna look into discovering Docker, how the Docker come up and so from where the Docker came, what is the history of Docker. Then after that we will look into the exploring the engine room of the Docker because we call it as a Docker engine. So that's the reason. So we will explore the Docker engine room. Then we will compare the Docker with the virtual machines. Then we will look into a lot of examples and the lot of commands that we use daily when you work on Docker. Then we will look into the configuration management and getting your house in order. It's nothing but stopping the container, removing the container, stopping the image, removing the image. So all this. So it's cleaning up. It's called a cleanup. It's house cleaning. And finally, we will look into the Docker Compose and Kubernetes in this first part. So then we will just have a glimpse of Kubernetes. Then we will look into the second part of the sixth module in depth about Kubernetes. And we will see a lot of examples meanwhile. So the question will begin with a question in discovering a Docker. So what is Docker? Why it is required? So what would it be if there was no Docker, if there is no Docker at all? How would it be? How this world would move? So there are a lot of questions, but there are no answers. If you know the answer, ping it on, ping it in comment section. I will look into that. Meanwhile, I will answer these questions one by one in this. If you want to know these answers, just follow me along this course. Okay. Now let us jump into the discovering the Docker and we will begin with what is a Docker. Docker is a platform that allows you to first build, then ship and run. So what I was saying, first build, then ship and run any app and anywhere. So this is the definition of Docker. I will repeat it again. Docker is a platform that allows you to first build, then ship and run any app anywhere. So it has come a long way in an incredibly short time and is now considered a standard way of solving one of the costliest aspects of software, that is deployment. So before we look into the hypothetical scenario that what would it be if there is no Docker, so let's understand what brings the what all the parameters that brings this differentiation between life before Docker and life after Docker. Okay, so the three parameters that we have considered here are inputs to the system requiring and the maintenance that is required for the inputs, and then how many tools we require to configure the system, and basically to configure the systems and create an environments, and stages of software development, how many stages itself is required, and inside that stages how many inputs that you have to provide. So these are the three parameters we have taken to compare the life before Docker and life with Docker and hypothetical situation. So before Docker came along, the development pipeline typically consisted of combinations of various technologies for managing the movement of software such as virtual machines, configuration management tools such as Chef, Ansible, Puppet, SaltStack, and different package management systems, and complex webs of library dependencies. All these tools needed to be managed and maintained by specialist engineers, and most had their own unique ways of being configured. So what has changed after the Docker? So after the Docker, Docker has changed all of this, allowing different engineers involved in this process effectively speak only one language, that is a Docker language, making working together a breeze. Everything goes through a common pipeline to a single output that can be used on any target. There is no need to continue maintaining a bewildering array of tool configurations as you see on the screen at this moment. At the same time, there is no need to throw away your existing software stack. If it works for you, you can package it, and you can package it up in a Docker image, and then as you can consume it, or others also can consume the same thing as a bonus. It can be used anytime, anywhere, by anybody. That's what the Docker is. So if it is clear, it's fine, or else I will explain it one more time. I will with one example, the simplest example. So just to compare the life before Docker and life with Docker, so I'm going to take one a simplest example. Let's take an example of web application, a simple static web application. Okay, so now we have to deploy this static web application. What are the processes that we follow? So we bring this, we develop the static web application. So web application source code is ready. So let me go back. Yeah. So now this is the condition. Web application source code is ready with us. Okay, now I will talk about a life before Docker, then I will move to life after Docker. So it should be this, the differentiation between life before Docker and life after Docker should be very clear before we jump into the actual Docker. So source code has been ready. Now what will we do? Once the source code is ready, then the configuration tools and provisioner tools like Terraform comes into the picture, Vagrant comes into the picture, and so once the tools has comes into the picture, so here we have three tools, that's Vagrant and Jenkins and Chef. We will use Vagrant to create a development virtual machine. This is a development server, and we'll use Jenkins or Ansible or some other tool for uh, conf for setting up a test server. Then and we require a chef for a production server. So for one application we cannot directly put that application into the production server. We have to, that application should pass through various servers, various stages, various environments. Begin with the development environment, then test environment, then a live or production environment. For that, to set up each environment at this moment, different configuration tools has been used. That is Vagrant for one, Jenkins for one, Chef for one. So each tool will have a different settings, different language, different templates, uh, different codes to be written. For Vagrant, it is different. For Jenkins, it's different. For Chef, it is different. So that means you're literally dealing with a lot of tools, and as the inputs increases, the maintenance of this inputs also increases. That means it would be costlier, and as number of tools increases, the complexity increases, and then as the number of more environments and more configuration needs to be done, that means the source code, the code that you write to configure these servers will also be complex. So there are a lot of complexity is involved in this. So how to deal this situation? So now then came a Docker. Let's see how this Docker deals with the same situation. Again, we take the source code, then we will need a configuration tool. At least one configuration tool is more than enough to set up a Docker server. So Docker server has been set up, and then either we can use a Jenkins as an automation server. So I am using Jenkins here. So now Jenkins, a configuration server, has configured and created and configured this Jenkins server. Inside the Jenkins server, we have also installed the Docker. Now this Jenkins server is gonna fetch. We have seen this example in our Jenkins module. So this Jenkins server is gonna fetch the source code, and once the source code has been fetched, Docker comes into the picture, and Docker will build the image using that source code with the source code. Then once your image is ready, then that same image can be deployed in development server, test server, live server. See the magic, man. See the magic. Here, every time you have to fetch the source code, and then you have to deploy it in different environment. Once, twice, thrice, every time, and the configuration with the each environment will vary a lot based on the tools. But here, in this case, logic is pretty simple. Jenkins comes into the action. It builds the using the Docker. It will build a Docker image. Once the Docker image is ready, now you just simply push that Docker image into every environment. That's it. See the differentiation. How much workforce, how much effort is reduced, and how much cost is reduced, how much time is reduced. Because of that, we have reducing the number of resources. Here, source code will be fetched to the Jenkins, and after that, as the thing is automated, the Jenkins will use Vagrant, Chef, Ansible, different tools to provision and configure the development environment, test environment, and live environment. Once it all developed, once the servers are ready, now it's time to push this code into each environment using package. Use the in package in .var format. So, but to push into each environment, it should be again configured specific to that environment. Whereas in Docker, it's simple. You build an image and you push it. That's it. That's it. I hope you got the difference. Now let's see what is Docker. To understand what is what Docker is, it's easier to start with a metaphor than a technical explanation. And the Docker metaphor is a powerful one. A Docker was a laborer. A Docker means a laborer. A Docker was a laborer who moved commercial goods into and out of the ship when they are at ports. So these are those laborers. You can see that laborers. These are the laborers. A docker means a laborer. A docker means a laborer who moved commercial goods into and out of ships when they docked at ports. So now there were boxes and items of differing sizes and shapes. An experienced dockerer, docker means a laborer, okay? An experienced dockers were prized for the ability to fit goods into the ships by hand in cost effective ways. Here also the same thing is happening. The docker, what it is doing is, the docker is fitting our applications in a cost effective way into a container. So that is the reason we are calling it as a docker. So what was there? What was done before? An experienced docker were prized for the ability to fit goods into ships by hand in most cost effective way. So here also the same thing. You have to fit your applications into your ships or into into your virtual machines containers in a cost effective way. So that's why we call it as a docker. So hiring people to move stuff around wasn't cheap, but there was no alternative at that time. From there this docker word has come. So this should sound familiar to anyone working in software. So much time and intellectual energy spent getting metaphorically odd shaped software into different sized metaphorical ships full of other odd shaped software. So they can be sold to users or business elsewhere. See, this is what the history of Docker, and this is what a Docker is. So let's see the software delivery before and after Docker. This slide shows how time and money can be saved with the Docker concept. So life before Docker, deploying software to different environments required significant effort. Even if you weren't hand running scripts to provision software on different machines, you would still have to wrestle with configuration management tools that manage state on what are increasingly fast moving environments starved of resources. Even when these efforts were encapsulated in VMs, virtual machines, a lot of time was spent managing deployment of these VMs, waiting for them to boot and managing the overhead of resource use they created. So, whereas life with Docker, the configuration effort is separated from the resource management and the deployment effort is trivial. So let's say run Docker. We have run Docker run and the environment's image is pulled down and ready to run. So consuming fewer resources and contained so that it does not interfere with other environments. You don't need to worry about whether your container is going to be shipped to a Red Hat machine, an Ubuntu machine, or a CentOS machine, or or uh, or as long as it has Docker on it, it will be good to go. So let me make it much simpler. Let's take one example. Same thing, we need to deploy an static web application. in production. But before we put into production, as we knew that we have to gone through development server, testing server, staging server, and finally we'll go for the production server or live server. Okay, that's the example here. So let's begin. So without Docker, what we are going to do is we will first create a dev environment. In dev environment, we have to install, configure, and maintain complex applications, basically, to develop this static code, develop this source code, and also to cross check whether our application is running or not. That's the development environment. Okay, in development environment, our application is successful, and now we want to move it to the test environment. Now what's going to happen in test environment? Again, we have to provision a new instance or new server or new virtual machine. So you have been instantiated new virtual machine or new instance. Now again you have to install, configure, and maintain complex application. You have to follow the same procedure, provisioning. Then after provisioning, you have to configure it. After configuring it, you have to do whatever operations that you have to do inside. That's similar to the dev laptop. So now again, after the test server, we got the package absolutely working fine, no issues, no bugs, no vulnerabilities. Now it's time to move to the production server or live server. Again, you have to provision the server, or else you have to instantiate an instance. Then after that, you have to configure that. After the configuration, you have to deploy the application, and you have to run the servers. You have to run the services inside that. For this application, let's take HTTPD is an example, or HTTPD is one example that we have considered for this service. So that service should start. Okay, for all those things, again you have to repeat the acts. So the same thing you are repeating. Dev laptop, you have done it same. Test server, you will do it same. Live server, you have to do it same. So that means 3 times the effort to manage the deployment. To finally deploy the one, you are doing the same task 3 times with a little variations or slight modifications. So now let's jump into live with Docker. So initial we will instantiate one server. We will call it as a Docker server, and whatever application we want to deploy, so that application source code has been taken, as well as whatever instructions, whatever the activities should be done to do this deployment, all the activities will be placed in a Docker file as instructions. Once you give all the instructions in your Docker file, that's it. Your Docker image will be ready. And after that, once your Docker image is built, the Docker image is nothing but it consists of all the instructions of deploying an application. For this example, let's take for this example, what's the manual procedure of deploying an application? First thing, you have write a source code. It is in your local machine, so you have that source code, complete source code repository. Now you have to enter inside your production server, and inside the production server you have to install. Let's consider this is a static web page, so I would say HTTPD service I have to install. I have installed the HTTPD service. Then I will fetch all the source code, and then I will place it into a where www html directory. Once all the application that you want to deploy is placed inside the specific directory, that where lib www html directory, then you start your HTTPD service. Once HTTPD service is started and source code is placed inside the specific directory, then that's all, your deployment is done. So it consists of different activities. We have around 8 activities, 8 actions to be done for that. So what will we do is, in Docker image, we will write all these actions as instructions in a Docker file. Once it is written, we will build that file, so we will get a Docker image. Once you got a Docker image, now it is cakewalk. So now you want to do it, you want to test it in dev environment, you just pull the image and run the container. That's it, game over. If you want to do it in test server, Pull the image, run the container, game over. If you want to do it in production server, pull the image, run the container. You have to give simple docker run command, docker run command, docker run command, and specify the image name. That's it. So what's happening here? A single effort to manage deployment. I think it's pretty clear for you. If you take a Docker, how much benefit you can get, how many resources you can save. So what are the advantages of Docker? So some crucial practical questions arise. Why would you use Docker and for what? The short answer to the why is that it gives a modicum of effort. Docker can save your business a lot of money quickly. Some of these ways, and by no means all are discussed in this slide. So we will see some of the most important advantages that gonna save a lot of money to your business. So the first one is it replaces virtual machines, VMs. Docker can be used to replace VMs in many situations. If you only care about the application, not the operating system, Docker can replace the VM, a virtual machine, and you can leave worrying about the OS to someone else. Not only is a Docker quicker than VM to spin up, it's more lightweight to move around, and due to its layered file system, it's much easier and quicker to share changes with others. It's also firmly rooted in the command line and is eminently scriptable. And the second advantage is prototyping software. If you want to quickly experiment with software without either disrupting your existing setup or going through the hassle of provisioning a VM, a virtual machine, Docker can give you a sandbox environment in milliseconds. The liberating effect of this is too difficult to grasp until you experience it for yourself. And the third benefit is packaging software. Because a Docker image has effectively no dependencies for a Linux user, it's a great way to package software. You can build your image and be sure that it can run on any modern Linux machine. Think as if Java without the need for a Java virtual machine, a JVM. Then the fourth benefit is enabling a microservices architecture. Docker facilitates the decomposition of complex system to a series of composable parts, which will allow you to reason about your services in a more discrete way. So this this can allow you to restructure your software to make it parts more manageable and pluggable without affecting the whole application. Then fifth, modeling networks. So because you can spin up hundreds, even thousands or lakhs of isolated containers on one machine, modeling a network is a breeze. This can be a great for testing real world scenarios without breaking the bank. And enabling full stack productivity when offline, because you can bundle all the parts of your system into Docker containers. You can orchestrate these to run on your laptop and work on the move even when offline. And seven, reducing debugging overhead. So complex negotiations between different teams about software delivered is commonplace within the industry. I have personally experienced countless discussions about broken libraries, problematic dependencies, updates applied wrongly. It's like, or in the wrong order, or even not performed at all. So, unproducible bugs, and so on, so forth, so on, so forth. It goes on. It's likely you also have done that. You also have experienced this in your career. So, Docker allows you to state clearly the steps for debugging a problem on a system with known properties, making bug and environment reproduction a much simpler affair and one normally separated from the host environment provided. And the eighth benefit that we have here is documents, software dependencies, and touch points. By building your images in a structured way, ready to be moved to different environments, Docker forces you to document your software dependencies explicitly from a base starting point. Even if you decide not to use, even if you decide not to use Docker everywhere, this need to document can help you install your software in other places as quick as possible. Then the ninth, the last but not least advantage of Docker, enabling continuous delivery. Prestigious uh, advantage of Docker. That's continuous delivery is a paradigm of software delivery based on a pipeline that rebuilds the system on every change and then delivers to production or live server through an automated or partly automated process. Because you can control the build environment state more exactly, Docker builds are more reproducible and replicable than traditional software building methods. So this makes implementing CD much easier, damn easier if you want to say. So I will show you in our mega project module. We are gonna do continuous integration and continuous delivery and continuous deployment pipeline with Docker concept. Basically containers. Based on the containers will be built with the every change of state, and it will be after the integration it will be delivered to the ECR, a container registry. We will do that in a mega project. So that's why brace yourself for the more action, guys. Because so Docker builds a more reproducible and replicable uh, than traditional software building methods. So this makes implementing CD much easier. So standard continuous delivery techniques such as blue green deployment, uh, where blue green deployment is nothing but where live and last deployments are maintained on live. Okay. And phoenix deployment is nothing but where whole systems are built on each release. That's called phoenix deployment, are made trivial by implementing a reproducible Docker centric build process. Now let's look into the installation of Docker desktop before we jump into installation of Docker engine in Linux. First we see how to install Docker desktop in Windows machine, then we'll go for the other one. For that we will get two things are required. One is Docker desktop, other one is WSL. So let us get into the documentation of Docker desktop. So I click Docker desktop for Windows. Install on Windows. So this is our documentation of Docker desktop. You see Docker desktop documentation on Windows. Let's go through it first and then we will begin installation of the same. So it says welcome to Docker Desktop for Windows. This page contains information about Docker Desktop for Windows system requirements. That's fine. And this is where we have to download the Docker file. Sorry, Docker Desktop .exe file, the binary file. So let me download this first. Click on this link. So it's getting downloaded. It's 594 MB. It's gonna take more time. So by the time we will go through the documentation of installation process of Docker Desktop. So system requirements, as I told you, you must have either WSL2 backend or Hyper-V backend and Windows container, whichever it may be. So we will go with the first option, that is WSL2. So in addition to that, Windows 11 64-bit for this Home Pro version, Windows 10 64-bit, and all it compatible with all those things. Then the common requirements: 64-bit processor with the second level address translation, that's a SLAT, and 4 GB system RAM minimum, and BIOS level hardware virtualization support must be enabled in the BIOS. This is very important. This is very important. BIOS level hardware virtualization, when you restart, you can find this. Uh, Virtualization support must be enabled in the BIOS settings. Okay. Then we have about Windows containers and install Docker Desktop on Windows. This is the process. Let's go through the procedure once. Just double click on Docker Desktop installer.exe .exe file. Then once we double click on it, runs the installer. So the installation process starts. So then basically you can install your application. Once that is done, when prompted, ensure the use WSL2 instead of Hyper-V option in the configuration page is selected or not, depending on your choice backend. So we'll go for the WSL2 only. And then from the instructions on the installation wizard, to authorize the installer and proceed with the install. So when the installation is successful, click OK to complete the installation process, and the rest all remains same. This step we are going to look into this. So our .exe file of Docker Desktop has been downloaded. Let's get into the downloads and we will install. But before that, you can see installation from command line. In spite of downloading the .exe file and installing it manually, you can do it through command line and PowerShell also. So for the command line, this is the um, commands that we have to use. Okay, so we will see this step once the installation is done. For now, let's get into the .exe file of that folder. So do you want to allow this app to make changes to your device? Yes, of course. So it's getting installed. This is our Docker desktop installer. So configuration, I say okay. The shortcut, it's about shortcut. So now it's getting installed. Now it's unpacking the files, because normally a .exe file, .exe or whatever the package it could be. So the source code will be built and then it will be made into package. So now when you install an application into your local machine, means you'll unpack it, and after the unpacking, so you will basically place all the files which are there inside the package in your directory, so that you can use that application. That's what an installation means. Okay, installation succeeded. So let me click close, and let's get into the Docker desktop. Here it is. So let me open run as administrator. So I'll click here. Yeah, I'm just waiting for it to respond. So Docker subscription service agreement. Okay, fully accept. You just go through the full agreement before you accept, because I have gone through it. So that's the reason. Yeah. So Docker subscription service agreement, I'll accept it. Okay. So it's up. Docker desktop requires a new year WSL kernel version. So for that, update the WSL kernel by running this. So let's use this, copy this. Let's keep this one same, and let's look into the WS first, whether we have it or not. So Windows PowerShell, run as administrator, and I'll keep this up, and clear the screen. No, I don't need. Let me paste it. So installing, do you want to allow this app to make? Yes. So installing Windows subsystem for Linux. Let's wait. So Windows subsystem for Linux has been installed. And one more thing is, if you do not have a Windows subsystem Linux, so either you can use these commands, or you can just simply go to your Microsoft Store. Let me quit here and type WSL2 or WSL, and then click on apps, and just scroll down. You will see Ubuntu here. That's Windows subsystem for Linux. Of course, you can see that it's installed. So it's been installed. So I have installed it. So you can install it either using command line interface CLI, or you can use a user interface of Microsoft Store, whichever is easy for you, just follow that. But installation of WSL2 is pretty much important. So Windows subsystem for Linux has been updated and we have that. So now let's get into the Docker and we'll see what's the condition there. So Docker desktop is getting started. Docker desktop is starting. Let's wait. So here there is no red. So now, yeah, it's green. It's asking to get started with Docker in few steps. Let's do it. So first clone a repository and then Docker run. So clone, build, cd getting started, Docker build, and then after build, run or spin the container, run your first container and share it. Pretty nice documentation and nice way to getting started, because you are covering all. So you'll begin with the cloning the repository where you have your Docker image, and after that we have to getting you have to build your image, then you have to run the container and you have to share it with the Docker Hub. Okay, we'll go there, but before that okay, let's do that. Let's clone it. Okay, yeah. You see that image is being pulled here. So cloning that, getting started. So done. So let me do ls. Mhm. List. That's okay. So then after that we're gonna build Docker build option T Docker 101. So the image has been built. Oh, there are a lot of steps, huh? Nice. Okay, let's wait for that. Then just click here and you can run your container. But finally, if you want to share, you can see that all the tick marks are done till we have run it. Now if you want to share this container, so what we have to do is we have to sign into our GitHub account before you want to share. So let me get into that place now. We will sign into our GitHub account. Yes, it's done. So it's verifying credential. You just click success. You are now signed in. You can see that this is my account. That's a Cube Charan account. So let me click on done and see your repo alpine git container is in exited state, that's a different issue. But you just run the, you can see that your image is here and your container is here. So let me delete this container, let me clean up, and images also not required, let me clean up, and volumes, no volumes. So that's how you install your Docker desktop using WSL2 as a support, as a backend, and after that you will configure to your Docker Hub account to push your images or to store your images, to share your images that you have built uh, to everyone. So we use a Docker Hub. So we'll configure the Docker Hub with our Docker desktop. Let's jump into our first exercise. Don't worry that why this guy is saying without looking into the concepts and theory of Docker, why this guy is saying exercise. Don't worry, I'm gonna take this Docker part of sixth module uh, in in coordination with a practical demonstration as well as concept and practical demonstration will go hand in hand, so we will do it parallelly. So each concept I will explain with a practical demonstration. So that's how it works. So let's look into the installation of Docker in various systems. So let me get into the in documentation of Docker. You see that docs.docker.com engine install Ubuntu. So this is the URL. So you once you go there, you will find documentation of Docker desktop, Docker engine, Docker build, Docker compose, Docker hub, and some other concepts. Also you will find documentation about some other topics also you will find here. So but at this moment we are interested in Docker desktop. So let me click on Docker desktop and click on overview. So now what is a Docker desktop? So Docker desktop is a one click install application for your Windows environment, Mac, Linux. So that enables you to build and share containerized applications and microservices. So it provides a straightforward graphical user interface that lets you manage your containers, applications, and images directly from your machine. So Docker Desktop can be used either on its own or as a complementary tool to the CLI. So Docker Desktop reduces the time spent on complex setups so you can focus on writing code. It takes care of port mappings, file system concerns, and other default settings and is regularly updated with bug fixes and security updates. So what's included in Docker Desktop? So Docker Desktop comes up with Docker Engine, Docker CLI client, that where we can actually give commands, and Docker BuildX extensions, Docker Compose, and all their stuff. Even Kubernetes also. I will show you this. I will show all of these things in Docker Desktop. So now how to install Docker Desktop? So and one more thing is a Docker desktop works with your choice of development tools and languages and gives you access to a vast library of certified images and templates in Docker Hub. So the installation of Docker desktop in Mac or Windows or Linux. So yours might also be Windows. If it is Windows, you click here. Linux or also you click here. and Mac also you can click here. So let me click on install Docker desktop. Close this. On Mac or Windows or Linux, I would go for the Windows. So this is installation of Docker desktop in Windows. So what you have to do is, as usual, download Docker desktop for Windows. You click on download option and you download this. Your download begins here. It is 594 MB of a GB. So now to for the proper working of Docker desktop, you need to fulfill some requirements. So those prerequisites are WSL2 backend. You should have WSL Windows subsystem for Linux. You should install this before you start installing Docker desktop. If you do not have WSL2, you can install the Docker desktop, but it won't work. So that's the reason you have to install WSL2 before you install Docker desktop. Hyper-V backend and Windows containers. This is specifically for Windows containers if you want to make it, and this is for Linux containers inside the Windows machine. Okay, so I don't prefer to use Windows containers. I would like to use WSL2 and make a Linux containers. Okay, so now the prerequisite 64-bit processor with second level address translation slate, 4 GB system RAM, and BIOS level hardware virtualization support must be enabled in the BIOS settings. This is also very important. If if you face any issues while installing WSL2, this one, if it is not working, that means you have to check your BIOS level hardware virtualization. You have to check this. You have to get into the BIOS settings. You have to stop the system. You have to shut down the system. Then when you restart the system, you have to click on F9 or F11 or F12. The function key is specific to your system. The reboot function key. So that should be clicked and it takes you to the BIOS settings. Then inside the BIOS settings, you have to enable this option, BIOS level hardware virtualization support. So then it works. Normally it will be enabled. In that case, you can easily install it and you can use it. If it is not, then you have to do this. So let's see. This is about Windows containers. We are not interested about Windows container. Now let's see the process of Docker desktop installation on Windows. Double click on Docker desktop installer.exe. So then it will run the installer. It is normal as usual, the similar way how we install some softwares. Then use WSL2. You install WSL2, then close it, and once Docker desktop has been installed, then you have to go to this. If your admin account is different from your user account, then you add your user account to Docker users, or else you don't need to do this also. Okay, with this, the very simple setup: install Docker desktop, then install WSL2. That's it, nothing much. Okay, so now I have installed WSL2 also. WSL, you see that this is my WSL. Yes, okay, you're seeing that's my WSL, and I'll stop this. It's not no more, it's required. I have installed it. Okay, and you have seen the WSL, my WSL. So then I'll show you Docker desktop. So Docker desktop also I have installed it. Yeah, so once you install a Docker desktop, you can make a connection with your Docker hub. So once you click on sign in, so it will take you to the account of your Docker Hub, and then it will get signed in. Okay. Okay. It's been signed in. So this is how your Docker desktop looks like. So what's the benefit of Docker desktop? You don't need to worry about a lot of commands and a lot of sub commands, options, and all those things. You can simply run your containers from here using just buttons. You can click example. So if you want to run a container, so you don't need to do anything else. Just click on a run option. An open source web server will take an nginx. Nginx could be a web server or reverse proxy or load balancer and HTTP cache, whichever way we can use it. So let me click on run. So path to directory, it's asking. Random one, anything is fine. Hands on. Yeah. So I gave the directory to publish and I clicked on run. Let's wait for the action to be happen. Now it is pulling nginx latest. nginx image with a latest tag. So the image is being pulled. So if you are an absolute beginner, I say I would request you to start with Docker Desktop. It's very simple, pretty simple installation. Install WSL and WSL2 and install Docker Desktop. And then configure your GitHub Docker Hub account if you have, or else you create a Docker Hub account first. So Docker Hub, creation of Docker Hub account is not that difficult. It's similar to creation of GitHub account or any other Facebook account or any other type of social media account. It's not much difference. It's not much different. So it's taking a lot of time for pulling that nginx latest image. Let's wait for that. Meanwhile, if you see, let's go through the user interface of Docker Desktop. Here you have a Docker Desktop, and here you can have upgrade plan. And here you have a search button. Here, from here, you can search about any of your image by giving the name. And here debug and settings option. If you click on settings, you can find Kubernetes extensions. You can find the Kubernetes. You can find the Docker engine. You can find the resources, proxies, network, WSL integration. If it is normally by default, it will integrate with WSL. If it is not, you can integrate using WSL. You see, WSL integration, enable integration with my default WSL distro. Whatever WSL distro has been installed in your system, we are telling to integrate with that. If it is okay. On other side, the downloaded newer image for nginx latest, it's done. Okay, meanwhile let's complete this one. So user interface UI. So after installation of WSL2 and Docker Desktop, by default it should connect with each other, because if it is enabled, if this symbol is checked and enabled, enable integration with my default WSL distro, then automatically it will be done. If it is not, you have to come to this settings section and go to the resources and click on WSL integration and check this enable integration with my default WSL disk route. Then this is your Docker engine, and here you can set your Kubernetes cluster, a simple Kubernetes cluster, not complex one. A simple Kubernetes cluster can be built here, and software updates and features in development. So this is what our Docker consists of. So now the image has been pulled from Docker Hub. Now it's time for Docker engine to run that image and make a container, or simply run the, now it's time to run a container. So that's what this settings consists of. Here this button, this soft button, allows you to configure or attach your account with Docker desktop. And then on left side you have a containers, all the containers that you have run or you have spun. So the containers that you have spun will be displayed here, and the images that you have downloaded will be displayed here, and the volumes which are attached with your containers and images will be displayed here. And this is dev environments. Okay, we are not going to touch this, so let's get into the images once. You see, this is nginx, which you have pulled from Docker Hub to the local. Now it is in your local machine. This nginx image is in a local machine. Okay. So now on the other side here, yes, the container has been started. The container is running now. You can see that. Nginx is the name of the container, and tag is latest. Nginx latest. This is the image it is using. This container is using nginx latest image. Let me take to the images and I'll show you. You see that nginx latest tag. So this image has been used to spin this container. So now our container is spinning, and ports are mapped. 32768 is mapped to the port 80 of the container. So I have to give HTTP local host to access this application, and 3 minutes ago it's been started. Let's access this application and we will do what all operations we can do with this container. So it's a local host, correct? So let me get into the browser. So here let me take a new tab and HTTP local host, and say what's the port number? 32768. 32768. Okay, that's okay. Here HTTP, okay, not secure one. Let me change the, and I put it in a wrong place. I have to put this in here, not in Google. HTTP / and yeah, now it's proper. Forbidden, okay, but you could see that nginx 1.23.3, it's forbidden, but your app is running there, your nginx is running there. Let me get into the Docker desktop again. So let me click on localhost. You see that you got the same response, of course, because of image, but whatever it may be, your app is running. The connection for this site is not secure, so that's the reason it is not allowing. That's okay, whatever it may be, but you could see your app is up and running. It's 403 forbidden, but you could see nginx 1.23.3. okay, this is how when you spin a container you can deploy your application. So now what we can do, so normally what we do, for a container. You spin a container, or you can say you run a container. How can I run a container? So before I start run a container, I will stop the existing container. I will stop this container by just pressing that stop button. Now if I want to restart, I can click. Now you see the status, it is exited status, and I can click on start button and it will be restarted. That's it. Now let me execute and see that. Yes, you can see your page. And next. So let me stop this time and let me delete this. Simple. Just clicking on delete icon. The bin icon. Just clicking on bin icon. It will delete your container. So nginx container is selected for deletion. Any anonymous volumes associated with this container are also deleted. Of course, you should delete that. I don't want it now. So the container has been deleted. Now let me get into the images. You have still nginx image. So now I want to run or spin this one. So I want to run a container using this. So optional settings, not okay. Let me check. Do you want to add any optional settings? Okay. So container name, I'm gonna give first nginx, or we'll just say first container. Host port, container port is 80. So I need to map this port 8080 port. I want to map 8080 port with this one. And volumes, do you want to attach a volumes? I don't need an environment variable is also not required. So let me run it now. So you can see the container log. It start worker process and inspect path nginx version package place, and this is the port mapping 8080 local host IP, and then port number is 8080 and terminal, and you can see that first container is running up and running now. So this is the terminal of our container, and this is the status. Memory usage is 12.4 MB. So let me get into the containers all together engine and click on this is our image. Let me get back to here, and this is image. Back to container 8080 port, and here it is. Here is your application. This is our first application that we have hosted using Docker container. Congrats if you are also able to run it. It's that simple using Docker desktop. So let me minimize this, and now what I'm going to do is I will stop this container and we will see whether we are able to fetch it or not. So let me refresh it and we'll see what's going to happen. I stopped the container there. Welcome to nginx is gone because the application is closed. So now let me restart it. Okay, yeah, it's running now. It's up and running. So let me refresh it again. Yes, it is. Welcome to nginx. If you see this page, the nginx web server is successfully installed and working. Further configuration is required. And if you want to go for the online documentation, you can go for that. But with this, we are able to successfully deploy our application using container in local host machine. So this is how we build it, and this is how we name it. And let me go through it one more time. So let me stop this running container. Yeah, it stopped. Delete this container forever. Get into images, and here we have nginx. So I will build, I will run, I'll spin this time I'll put optional settings, container name second container, host port again I will give you the same 8080 should be mapped with the 80 port of the container. Host port is 8080. This is a local host, so in local host 8080 port my container should be running. And so at this 8080 host port is mapped with 80 of the container port. So now let me attach the volumes. You can attach your volumes here and you can attach your variables here. So what is volumes? It's a binding volumes, bind mounts. So these things, all these things we will do it using Linux machine using commands. This I'm showing, I want to give you a complete understanding. Like if you use a Docker desktop, it is pretty easy, damn easy. But all the operations won't happen in your Windows machine. All the operations will be done inside a server, a Linux server. So it's not that useful. Working with commands is the useful activity. So we're gonna work with commands excessively. Okay, but here we'll see one more example. This time I will give host path in same. I'll create a new folder. So I would say volume mount for nginx and select this folder. So container path name. Okay, container path. Variables is not required. Let me click OK. So Docker run invoking remote method, Docker run container, invalid volume specification, containerized application. Okay, volume specification, there is an issue with the volume specification, so we are not going to give volume specification, we will keep it same. Okay, here because it's a Windows machine, second container, and map 8080 of host machine with the 80 of the container port. Keep it same, run it. And now this part I want to explain. Okay, so that we are going to do. So this is logs. To get this we have to give logger docker log, then we will get the logs of the container. Okay, so logs of the container, we look into the logs of the container to troubleshoot the problems that we face in containers. Then we use docker inspect or docker exec, and docker inspect command and docker exec commands basically to inspect the docker container, to jump into the docker container and to see what is there inside the docker container, because docker container, docker image itself is another Linux machine. It's not exactly a Linux machine, but it is a miniature Linux OS. It will have all the directories of what Linux has. And terminal, this opens the pwd. See, this is a root. This is terminal of container, not ours. It's a terminal of container. ls, you see that what I told you, it's exactly a miniature, it's exactly a miniature model of a Linux OS. You see, you have serve, srv, sys, tmp, user, var, run, has been, root, proc, opt, mount, media, lib, home, etc. Everything you have. This is exactly a miniature version of uh, our Linux machine. So this is the terminal of Docker container, not ours, not Windows machine or not anything else. It's a terminal of Docker container. And this is stats. It's a 12.54 MB memory uses and 1016 bytes. And so let's open this browser. Let's open this application inside the browser. You see that? It's again opened. Okay. So let me get into the Docker desktop, and this is the container which is running. Let me stop it and kill it. This is what we call it as a kill it. and once it is killed, I will delete this container. I'll delete this container. Then I will come to the images and I will delete this also. This is called the housekeeping of Docker, housekeeping of Docker engine room. So now our Docker desktop is cleaned. Okay, so now we can get out of the Docker desktop, and this is how we install the Docker desktop. We build our first application. First we build our first image and we run our first container and we deploy our first application using Docker desktop. It's pretty easy without any Docker commands, sub commands. Nothing is required. Just simply you can run your containers. You can spin your containers. This is how we install Docker and uh, Docker desktop. This is how we install Docker desktop, and we run, we build images, we run container, we inspect, and we inspect the image, and we check the logs of the container, and we can expose it to the uh, external world by using a port number and an IP, and we can access that application which is running inside the container. And all we have done using Docker desktop. It's pretty easy then compared to the actual Docker. Okay, so this is how we do for Windows, and if you want to do it for Linux, you can do it in the same way. Click on install on Linux and follow the same procedure: Ubuntu, Debian, Fedora, and here you have to give some commands, and either you can use with commands or you can just download and see. This is how it looks. Your Ubuntu user interface, Ubuntu desktop, and inside that you can install your Docker desktop and you can run the same. It's not a big deal. Okay, even for the Mac OS you can do the same thing, but the problem here is when you work on your servers, all servers will not have this graphical user interface option. They will not have application level. They will not have graphics application to view all those things. It's a simple console type servers. Those are all console type instances. You can just use a command line interface, CLI. You can use a shell, not more than that. So what you can do in that case, you have a second option for to install. That is your Docker engine. You see, just scroll down a bit, you will find Docker engine. Yeah, I think now it's clear. Docker engine. So now let me click on Docker engine and click on overview. So what is Docker engine? A Docker engine is an open source containerization technology for building and containerizing your applications. A Docker engine acts as a client server application with, so what it consists of, it consists of a server with a long running daemon process. We call this as a dockered. It consists of a server with a long running daemon process. Okay, anyway, it's a client server based application, so it consists of a server which is a dockered, or we can say it as a Docker engine, and it will have a client. A command line interface is our client, that is Docker. We say it as a Docker, and in between, to connect this client and a server, we require something. What is that? That is API, application programming interface. So APIs which specify the interfaces that program can use to talk to and instruct the Docker daemon. So this is the Docker daemon. The Docker daemon name is dockered, and our command line interface, the client is Docker, and API is the one which makes the connection possible between our Docker and Dockered. Our client is our Docker, and then Docker engine is our server. Basically, who is the client here? I will be the client, you will be the client, because you are the one who is giving the commands to the server. Okay, so we will give that commands through this Docker client, the command line interface, and that will be passed through API to server. That's how this Docker works. Anyway, we are going to see the Docker architecture in our slides also, but I just want to give you a glimpse of it, how exactly it works. A client and a server type architecture. Now, let me click on install Docker engine. Here you have various sections. First section is installation Docker engine. Then use persistent data with Docker container. Here you can find how to use persistent data with Docker container. That's attaching the volumes to your Docker container. It could be bind mount or it could be volume binding, whatever it could be. So that's what. And here you will find networking, how to manage network connection between containers. Between each container, how can you manage? And here learn how to view and read container logs. And then tidy up and unused resources. Tidy up, that's what I'm saying, it's a cleaning up or housekeeping. And here if you want to do some changes, 12 into the configuration options of the Docker daemon. And here these are deprecated features. So anyway, so the first five are important for us. We will look into one by one whenever we need to do our examples. I will show you, and what commands I'm using from here, that also I will explain in that. So now let's begin with installation of Docker engine. So click on installation of Docker engine. So it has taken us to Docker engine installation overview. So you have three types of OSs, three types of platforms. One is, okay, that's Docker desktop. Yeah, here you could find server. Docker provides .deb and .rpm packages from the following Linux distributions and architectures. So CentOS, Debian, Fedora, Raspbian, RHEL, SLS, Ubuntu, and binaries. Okay, so I'm gonna go with, you have different tabs. If you use CentOS machine, then you have to use a different commands. Debian different, Fedora different, Red Hat Enterprise Linux is different, SLES is different. So I will go with the Ubuntu, or else simply you can download the binaries. You can simply install Docker engine from binaries. You download the binary file and place it in a proper directory and you can execute it. But this is not the safest method to use. So yeah, see, you see here tar, you will get a package, a tar package. Then you have to follow this sudo docker. You have to create a docker. So I don't think it's a good idea. So let's not do this. Let's do with a proper installation method. I'll go with Ubuntu. So this is install Docker engine on Ubuntu. So prerequisites. So at least you require a 64-bit version of this Ubuntu versions. Ubuntu Bionic or Ubuntu Focal. We'll go with the Ubuntu Focal 20.04 LTS. I'll just copy this. Just a minute. Let me open a sticky note. I'd say Docker installation in Linux. Sorry, I would say Docker engine, because you differentiate between Docker engine and Docker desktop. So Docker engine only. We are installing Docker engine only in Linux, or I specifically mentioned Ubuntu. So for that, requirements, Ubuntu Focal 20.04 LTS. Not this. We have to go with the long term support only. Then once it is done, the next thing is to create an EC2 instance with Ubuntu OS or Ubuntu AMI. So I'm gonna go with the Amazon Web Services EC2 instance. Okay, so once it is done, the next step, this is a first step. Then second step is to install the Docker inside the server. Then third one, validate the installation of Docker. So this is what we are going to do. So let's get into EC2 instances. So now I'm in Mumbai region. So let me click on launch instances and let's begin. So I will name it as a Docker server. Ubuntu, click on Ubuntu. So Ubuntu 22.4, no, I don't want. Ubuntu 20.04 is fine. So I'll click on Ubuntu 20.44 LTS. Then instance type T2 micro. No, I'll go with the T2 small. No, I'll go with T2 medium. It will work a bit faster. Then let me create a key pair. If you want, you can use T2 micro also, no issue at all. I just want a EC2 instance which works way faster than micro, so that's the reason I have gone for T2 medium. You can go with T2 micro also, it is not at all an issue. So Docker and key, Docker key is the one which we have created. So it's been created. Then scroll down. So let us edit network settings. So the name I'm gonna give for Docker SG small, and here also Docker SG, and remain same as usual. For the Docker security group, the first security group rule remains same. SSH type protocol TCP port range default 122, but source type I want to access through SSH from my IP, so I will select my IP. Okay, so that is done. Okay, here I would write SSH for admin login, or to do SSH into Docker server. Okay, so then let me add one more security group here. The custom TCP will remain same and TCP protocol remains same. Port range, so it remains same, and source type I would select my IP, and here I'm going to select all traffic. Here it is, all traffic. So when we say all traffic means whatever traffic that comes, so all can be used. Okay, so that I can use this Docker for other purposes also, that we will look into that. So we have selected all traffic. So all traffic, so and we will scroll down. So let's keep it same, and storage volume by default you will get 8 GB block. So click on launch instance. So meanwhile let's fetch the, okay, it will take a few seconds. Meanwhile we'll fetch so the first activity has been done. So EC2 creation of EC2 instance with Ubuntu AMI is done. So it's done. So then the next step is to log in into the logging into the Ubuntu that Docker server and install the Docker inside the server. That's our next activity. To do that, I need to do SSH. For that, I require key pair. I'm just waiting for the key pair. Let it come up. Okay, so let me click on downloads and take me to that folder and cut it and get into introducing containers and create new directory Docker in action. Open it and paste it here. So here I'm gonna open our git bash, maximize it. Okay, that's enough. Let me get into EC2 instance might be up and running. Yes, it's up and running. So let me click on instance ID and click on connect. Come down to the SSH client command and go to your git bash and paste it and run it. Yes, it's asking. I would say S. So now it's done. Let me give sudo hi and clear the screen. Now it's time for installation of Docker. So let's get into the Docker installation again, or else I will do one more thing. I'll keep it on left side. I'll keep install Docker engine on right side. Fine. So both are going side by side. Yeah. So let's scroll down. More. Yeah. It's begun. So first thing to be done is set up the repository. So this is the first step. Copy this. So we are in setup the repository. We are going to do 3 steps, so that we will do it one by one. So the first activity is to set up the repository. In that, the first activity is to update the package. So update the apt package and index, update the apt package index and install packages to allow apt to use a repository over HTTPS. Okay, that's what we are going to do. So let's do sudo apt update this apt get update and then install CA certificates curl GNUPG LSB release. GNUPG is for the GPG key. That's okay. We will install one by one. So in setting up the repository, our first step is to update the package index and install packages to allow apt to use a repository over HTTPS. To allow apt to use to make okay, let me enter this. To make apt to use HTTPS to bring different utilities, you need to install CS certificates. That's what we have done it. And LSB release. Okay, that's enough. So this has been installed, and then the second step in setting up the repository is adding. It's very important step. Add Docker's GPG key, which is official. Which is official. It's not created by you or me. So they will create the GPG key. They will take up the private key will be with them, and public key will be given to us. So what it will do? It will first create a directory inside the etc, and inside the etc apt they will create keyrings directory. Inside that they will do the curl. So curl is the utilities we have just installed. You see that on top, and then we have used fssl option, and then it will fetch the gpg key and copy it into etc apt keyrings docker.gpg. So let me copy this and paste it. So you can see that Ubuntu GPG is the one, and it is piped with sudo GPG. GPG is the tool that you have inside your system. Basically, it's to create a GPG key, nothing else, in connection with the docker.com. Okay, I will explain it clearly. For that, I need to make it bigger. Now you can see that. I will show you. This part, first one is clear, right? It's gonna create a directory keyrings. Okay, after that curl and go to this curl, go to this directory, sorry, go to this URL https download.docker.com, in that Linux Ubuntu GPG. So you will get the GPG from there. It will fetch it, and then you are piping it. Once it is done, then do GPG dear more option O, and here. So what is this is, this is creating a docker.gpg key. Basically this command we use, even I have used this command in creating a docker gpg, in creating a gpg key in while we are doing exercise or example in git. If you remember the GitHub example, we have done it, attaching SSH key as well as GPG key. So that's what it's happening. So here it's fetching that, and then it's connecting with that, and it is creating a GPG key in connection with the Docker. Okay, so let's execute this. I think it's done. So then let me minimize it again. So, and the third step in setting up the repository is use this command to set up the repository. This is the final step. If we do this, we are going to set up the repository. So what is that repository and where we are setting up? So let me make it bigger and we'll see. So lsb release sudo t etc apt sources.list docker.list. You can find apt sources.list. That's where we are setting up. The symbols that you see is for the redirection. That's output redirection. Sorry, that's input redirection, or you can say other output redirection from one to other. Input redirection is a less than symbol. So setting up the repository is done. So now it's time to install Docker engine. For that, again, you have to update the apt package index. So let me update the apt package index, and then give the permissions basically to use Docker GPG. So I need to give the permission to use Docker GPG. So I'm giving that permissions, and I'm updating it again after giving the permissions so that it can use docker.gpg key. Then I will go with the latest version. So of Docker CE CLI container.io Docker Compose plugin. So all I'm gonna install now. This is the third step. Second step, install Docker. First step is to set up and verify. So I'll give y set up the repository, and second one is install Docker engine, container, and Docker Compose. So now all are being installed. So ManDB database and systemd has been installed successfully. That means our uh, Docker has also successfully been installed. So let me give history. You see that from update the app package, set up the repository. It consists of these steps, and finally we have installed it. This is how we install Docker. So now, so this part, installing the Docker inside the server, is also done. Now it's time to validate the installation of Docker. So this one we have to cross check. So let me go here and say docker version. Yes, congrats. Docker version 20.10.23 and build 7155243. And I would say docker help. Clearly see that you have a docker here, and it has given all the commands that are related to docker and all the options that are related to docker and a docker specific usage. This is the syntax of docker commands. It begins with docker, and after that you will have options, and after that you will have a command, and you have various commands in this. Let me go up. Okay, this is what the syntax of docker. So with this we have finished validating the installation of docker. Also we have docker has been successfully installed in our Ubuntu server. Before we start working on our first exercise in docker, before we run our first container in docker engine, let's look into the installation process of other distributions of Linux also. So let me click on CentOS. It by and large remains same. If you click on CentOS 7 or CentOS 8, whatever it may be, it remains same, but you have to install additional uh, utilities depends based on that particular distribution. So but if you see the CentOS, it's much easier than Ubuntu. It will have only two main commands for setting up the repository. Then after that, you can use one command to install. It's pretty quicker and faster. And GPG key prompts are also mentioned. And Debian for CentOS, it is we have used yum package, yum package. For Debian, the package is apt-get again. Debian is apt-get. Fedora DNF. Fedora it's DNF. Okay. And Red Hat Enterprise Limited, it is yum. Then SLES, for SLES slash, it is OpenSUSE. SUSE Linux repository. For that we used uh, sudo jper. Okay, jipper. This is what we are using, and for Ubuntu anyway we have used it. Okay, so that's how other distributions install docker. So let me get into the so this first activity is done, and docker engine installation of Ubuntu. So now let us look into the second exercise, that is running or spinning our first container in Linux machine. For that, here we will take a simple example, that is hello world container. We will spin this. It will spin and print a message, and it will die. That's it. It will die. That's it. That's the work of this container. It just posts or prints the message, and it will automatically die. So that's how the container was made. So we are going to run a first container here. So let me get into Ubuntu and scroll down completely, down, and yeah. Yes, here you look here. So the Docker daemon, you have to make sure before we run our container, let us cross check. Clear? Okay. Before we run our container, we should cross check whether our Docker service is up and running or not. So let me check that. System ctl status Docker. So but before that we have some other activities to be done before we check the status. Let me directly say systemctl start Docker, and I'm starting the Docker service, and systemctl enable Docker. So what it's saying, when I say enable Docker, synchronizing state of docker.service with sysv service script with libsystemd system sysv install. So executing, and the Docker, it's been enabled. So now let me check the status of the Docker service. Yes, it's up and running. You can see that active and fine, absolutely fine. It started 8 minutes ago. You can see that the triggered by docker.socket, and you can see that dockered, we have discussed earlier. Dockered is our engine, that's our main engine, that is our server, this is what serves us. And CLI, the commands which we are going to give, is our client. Okay, so you have seen the dockered. Now Docker is running, our server is running. Now it's time to use API and client to do the activities. So let me click on Control C. So anyway, so our Docker is up and running. So now before we run our first ever Docker container, let's look into some of the commands, some of the most important commands, and then we will run it. Because if you do not know what command is used for what, and how can I show that, how can I demonstrate the running of any container. So that's the reason Docker and help, long option. So scroll up and up and up and up and until it comes. Yeah, we have reached. Okay, so if you look here, so the Docker uses Docker command starts with Docker, and then here you can give any options, and after that you can give command, and here again arguments. That's the complete syntax of Docker commands. A self-sufficient runtime for containers. Now let's look into some of the widely used containers or widely used options. So C option, context string, we don't use much. Top level TLS. So V, we can use it widely. So V option V, in spite of saying version, we can just give V and we'll get it. Okay, that's enough. Now let's get into the actual commands, the important commands that we can use. So the asterisks are basically deprecated. So container context, these are the main commands that we generally do not, we don't use this specifically. So let's come down more. Yeah, here we have the main commands. These are what we widely used. Let's begin with here. You see that commands: attach, build is to build an image from a Docker file. So you have written a Docker file. What is Docker file? A Docker file consists of a set of instructions to do certain activity, to do certain task. So all those tasks, all those instructions will be put in Docker file. So then if you want to create a Docker image, you have to use a build. Then we have commit, and exec is very important command. exec runs a command in a running container. When you use exec, it's execute, it runs a command in a running container. That means a running container itself is a miniature Linux OS. I have told you so many times by so far. So that's why we can run our commands in that container also. We can enter inside the container and we can see what is there inside the container. So then images, when you give Docker images, it lists images. When you say Docker inspect, it returns a low level information on Docker objects. And when you say kill, it will kill one or more running containers. And login, to log into a Docker registry, log out to log out from a Docker registry. And more down, Docker pull an image repository or Docker image, to pull an image from a Docker Hub repository, push your customized image to the Docker repository. We are going to do these things, don't worry. So and restart one or more containers. This is to restart the container. Okay, rm, if you use just an rm, remove one or more containers. If you use rmi, to remove one or more images. And when you say run, this is very important. Run a command in a new container. So run is going to spin a new container. So we are going to we are going to use this run command to stop, to run or spin our first container, our first ever container in Docker. Then start one or more stopped containers, and stats display a live stream of containers, and stop one or more running containers, and tag. If you remember, in the desktop, in the Docker desktop, we have seen similar kind of activities. So here let me click on Postgres. By the time it will get fetched, and let me Postgres SQL, let it be running. So tag, if you give a tag command, it creates a tag, the target image that refers to the source image. Basically to tag a target, to tag an image, to tag a Docker image. And stop, top is the one more thing. Top, the top command display the running processes of a container. And unpause update version shows the Docker version information. And wait block until one or more containers stop, then print their exit codes. So this is all about the containers, out of which the widely used commands are docker start to start the container, docker stop, docker rm, docker rmi, and docker top, docker build, docker run, docker exec, docker inspect. These are widely used. And docker restart also to restart. And docker pull and push are also very important. Pull to pull the image, and push the image. And docker ps to see the containers or list of containers, and docker images to see the list of images that we have. Okay, so now let's build our so now it's time to build our first ever container. Sorry, when we say build, it's for image, building an image. So for container, we have to say run or spin. So now let's spin or run our first ever container in Docker. So Docker run, you see, after the Docker, I have used a run command. So run command, and I will mention the image name. So I want to spin a container from this image. Okay, I want to spin a container from this image. What is that image? Hello world. That's the image. In fact, I do not have any image in my local machine. Neither I have a Docker file. So let me check that. ls, see, I do not have any Docker file. And I'll give Docker images. I do not have any images. So from where it's gonna fetch? It's gonna fetch it from Docker Hub. So how it can fetch? That's what is happened initially. It had established it has established a secure connection using GPG key between Docker Hub and then our Dockered. through API. So now whatever command that I give, it will fetch that. I'm going to show this architecture in another slide, but now you just understand when I say docker run and hello world in my local machine, in my Ubuntu server, I do not have hello world image or neither docker file. So it's gonna fetch from docker hub registry, and then it's gonna pull from there, and then it will spin and container from this image. Okay, so let me execute it. So unable to find image, you can see that. So unable to find image. Okay, let me go up. Yeah, unable to find image hello world latest tag locally. So because there is no image in our local machine. So now after that, it has gone to the docker hub and it's pulling from that library hello world. And this is the image id. Then it's been downloaded. So once it's been downloaded, it has run that image. So the image has been run or spun. So once it is spun, so now the container has come up and it has printed this hello from docker. It has printed this message hello from docker, and this message shows that your installation appears to be working correctly. Okay, so that means we have built our first ever container. We have run our first ever container and we have successfully run it, and the message has been printed. So now let me check docker images. You should see an image. Here it is. Here it is. Hello world with latest tag image id. That's okay. It was created 16 months ago. That's fine. And I will give docker, sorry, docker ps. There are no containers because the container which was running before was dead now. So I would give docker psa show all containers. You see that your hello world container is also there, and command is hello print this. And about a minute ago the container has been created and now the status is exited, so it's dead now. About a minute ago it's exited. Okay, so I hope now it's clear. So now we have done all these things using commands. Now let's get into the Docker desktop and compare the working. So postgres is our image that was pulled with one command, and then it is in use. So 378.59 MB, it's too big. So then let me get into the containers. Now you see your container is running postgres j2gk and latest tag. This is your container which is running presently. Now to stop the container, what command we have to use? Docker stop. Here simply you press this, that's it, it will be stopped. To delete the container, what command you have to use? Docker rm. Docker rm, and you have to give the container name, then it will be deleted. To start the container you have to say docker start, but here just press button and just press it and click it, that's it, all the things will be finished. So let me stop this one and I will delete this one. Yeah, I'll come there. I'll delete this one. Clear terminal. Let me go back to the container. So delete this container first. Yeah, go to the images. Now this is your image. So when you have an image, how do you run a container? Using commands. Using commands, what we did, docker run world. So you have used a docker run command to run a container, to spin a container. But here what you can do is to spin a container from this postgres image, just click on a run. That's it. I'll click on a run and it will ask, do you want to attach any settings? Yes, of course. Host port, I would go with the 8080 and click run. Nothing much, nothing much. So you can see the logs. To see the logs, you have to give command, and database is uninitialized and super user password is not specified. Okay, when you're creating that, you have to create a super user password and it's exited. Okay, terminal. So to inspect the container, you have to use docker inspect. To enter into the terminal, you have to use docker exec here. Okay, we will kill this container first. It's of no use. We have to give super user. Here we will find all our images and I will click on run, and here I will go and host port a container name post database and host port 8080, volumes I don't touch, variables. Okay, whatever it may be. To enter into the terminal, you just come and click here terminal, but there you have to give docker exec, and then stats, you have to give docker stats. But here just a simple command, and just a simple click on a soft button that will lead. Okay, that's how the comparison between a docker desktop and a simple docker engine uh, makes a huge difference between. But whatever it may be, the docker engine, docker desktop is for learning purpose. I would urge you to use docker desktop so that you can, initially you will not have that fear, the commands and these kind of things, that fear won't be there. You just see, okay, you think it's pretty simple. Okay, then once you feel it's pretty simple, then you get into our docker desktop. You set up your docker, you set up your docker server, and you create your own docker image, and you run your own docker containers. So with this we are able to run our first ever docker container in docker engine in Ubuntu machine, as well as docker desktop in Windows machine. So let us mark this. So running or spinning our first container in Linux machine is done. Hello world container, and we will, it will spin and print a message and it will die. So all are done. Let me mark it. Done. A sweet alert for everybody. So I'm gonna keep and explain a lot of we're gonna do a lot of examples, and at the same time we will be working on Docker desktop as well as Linux both at a time, so that you will get a clear idea of what does that command mean. I will explain the usage of command, and I will use the command in Linux machine and Linux machine using Docker engine, and I will show that a similar command working in Docker desktop, so that you can have a parallel running. We will do the parallel run so that you can have a clarity until until you get the more exposure on that. Once you get the enough exposure, enough understanding, then we will use only Linux. Okay, so now let's sneak peek into Docker. Now you know a bit about how Docker can help you. Before we dive into a real life examples, a real case examples, let's go over a couple of core concepts. So, so in this slide, we're gonna cover some key Docker concepts which are illustrated in the in in the in the infographic that you will be seeing. So the first one, On left part you see the Docker host machine, and on right part a portion you can see running processes. Okay, so it's most useful to get the concepts of images, containers, and layers clear in your mind before you start running Docker commands. In short, containers are running systems defined by images. So these images are made up of one or more layers or set of diffs plus some metadata for Docker. You see that example we have taken one. This is our Docker host machine. Inside that Docker host machine we have an image. So this is our image. It's a complete image. Image is nothing but, what is image? A simple definition. An image is made up of one or more layers plus some metadata for Docker. That's it. So layer 1, layer 2, layer 3. So layer 1 is basically a base image. We have taken Ubuntu distribution, a miniature Ubuntu distribution. Then after that, application code layer, because we want to deploy some source code, some application. So that application is in second layer. And then the third layer is application version 2. We have attached a few more features and that. So total, this is our image. Image is consists of a layers. That's it. Now what is a container? Containers are running systems defined by images. So whatever instructions that you defined inside an image, all those will be running. All those commands and all those services are will be run. So will be run. If they are run, that's called a containers. So the containers are running the systems, services, commands that are defined by images. That's it. These are the simple definitions of a container and an image. An image is a collection of file systems, layers, and some metadata taken together, so they can be spun up as a Docker container. So Docker container is nothing but running the services, systems, commands that are defined inside the Docker image, inside the image. That's it. So let's look at so if you take this example here, another layer we have added. That's a layer is a collection of what is a layer? A layer is a collection of changes to files. So you can see that the differences between v1, that's version 1, and version 2 of application code layer are also stored in this layer. So now once you run this container, when you say docker run, let me give that. Once you say a docker run, so the systems and the services which are mentioned inside the Docker image will be running. So then we call them as a running processes, because the process, ultimately the processes which are defined by the image will be run. So then that's what are containers. So then once it is running, we call that as a container. So but inherently what is running? The processes that we have mentioned inside the image are running inside a Docker container. Okay, so that's our version 1. If you run it again, slight modification, we will get a container version 2, and if you run it again, we'll get container version 3. So like that, you can run any number of containers with the same image with the slight modifications. So these are all version 1 of 3 containers, and after that you have done some changes, you have added new services into your Docker image, and then you have run it. Then you got the my application container version 2.1. So these are all. So one side you see the image and their layers and instructions which are mentioned inside the layer. On other side, when you say docker run and image name, so it's gonna run the services which are mentioned inside the image and inside the image. So that's what you are seeing on right side, running processes. So let's see. So a container is a running instance of an image, so you can have multiple containers running from the same image. So the principal docker subcommands you will use on your host are docker build, this is to build a docker image, docker run, to run a docker image as a container, or the better way is to say to run the services or processes or commands which are defined by the image. That's what the correct way of putting docker run. Then docker commit a docker container as an image, and finally docker tag, to tag a docker image, to give a name to the docker image. So now let's do our first practical real case example. So that is run nginx container. This is example one, nginx container in Ubuntu based server using Docker engine for inspecting. Okay, let's get into that. So we will do our first exercise using Jenkins. Sorry, nginx. Okay. So what will we do is, let us get into the Docker engine which is installed in Docker server which is Ubuntu based. So here it is. I think it's gone. Yeah. Clear the screen. Now let me check Docker ps. So sudo I Docker ps. So no container is running presently. So let me say Docker images. So only one image is presented, that is hello world, that we have used in our last example. Okay, clear the screen. So now what will we do is, we are gonna pull the image from Docker Hub repository. So now let me show you the Docker Hub repository first before we pulling the images. So this is Docker Hub. So this is my account. So these are the images which I have created. So but if you click on explore, you can find the images, official Docker Hub images. So here, okay. So now which image we want to go? So it's pretty easy. It's similar to any other social media account. So you can click on Docker Hub login and give your name, username and password, and that's it. You can log into the system. Or if you have a GitHub account, you can use your GitHub account to log into your Docker Hub. That is also fine. So now nginx is the one I want to use. So let me click on nginx image, nginx Docker official image. Click on nginx. Now you can see that Docker nginx, you have two options, overview and tags. So if you come here, you will get the complete information of the about the overview. As these are official images, you can get documentation of that also, what is nginx and how to run that example also you will find. This is how to attach a volumes to that volume, that's bind mounts, and this is to write your custom made basically to custom made your own Docker file, and here exposing it to the external world. Okay, let's get back to this, but before that, what we are going to do is, let's scroll up and go to tags, and here you can find out various versions of the nginx image. So which one I would go with? This is latest tag. I would go with the stable one. For that, I would click on here, so it will copy the docker pull nginx table and nginx table. So copied that command. So now let me get into my, so docker help, uh, where is that? Just a minute, I'll show. Docker pull, yeah. Docker pull means it pulls an image or a repository from a registry. Okay, it pulls an image or a repository from a registry. So now let me paste it and let us pull nginx. Okay, let's pull nginx stable, that's tag nginx stable image, docker image from docker hub, and click enter. So now the nginx with stable tag has been being pulled. So you can see the layers, different layers. It consists of layer 1, layer 2, layer 3, layer 4, layer 5. Each layer has been identified with the specific ID. What is that we are going to see? And finally, let me do docker images. Clear the screen. Docker images. Now you see nginx stable tag, and it's 142 MB. It's huge. Okay, so now we have our image. Let me check. There are no containers. Now it's time to build our container. It's time to run our container. Okay, so before we spin or run our container, I just want to inspect the nginx image. Let's check. Let us inspect what is there inside the nginx image. So for that, how to inspect? Just say docker, then inspect and image name. So it is nginx. It's nginx stable. So let me take this so that we can have more clarity. So now here what we'll be doing is this is so first pulling an image, then inspecting the image, then running running the processes or systems defined by the image. Okay, so that's why before we run the processes which are defined by the image, let's inspect the image first. Pulling an image is done. So now let's inspect the image. This I will name it as example 1. So inspecting the image. So now you could see that clearly. When we click on inspect the image, it opens up a lot of information. The image has been completely exposed. Each and everything of that image, most of the things of the image has been exposed to us. So let us go into that one by one. So it has begun with the ID. Here you can see the ID of the Docker image, and then a report tags. You see that tag, it's stable tag, and a report digests. Then scroll down, the most important, and when it is created, that's okay. And container config, exposed ports. So this is important. This is container port 80 TCP. Then environment variables which are related to this is path. This is the path. And nginx version is this. And when you say nginx version, you'll get it, this 1.22.21. Okay, let me copy this environment variables in, and when you use exec, that time we can use it. So in the second step here, you have to copy that. Okay, yeah. So then environment variables of nginx, then commands. So this is what is the command will be executed mainly when you say docker run nginx and g, option G, daemon off, and image volume null. So working directory is nothing is mentioned, and entry point is this docker entry point dot sh. Labels, they have maintainer, they have mentioned the maintainer, that is nginx docker maintainers. Then docker version, it's given other. So there are a lot of other stuff. Okay, and again environment variable. Okay, and virtual size, overlay, and type layers. See, these are the different layers. You see how many layers it has? 3 plus 3, 6 layers, and finally you got the metadata. This is our last step. So this is how we inspect the docker image. Okay, so inspection is done. So now let's get into inspection is done. So now let's get into running the processors, running the systems defined by the image. Okay, for that let me show you the method. So let me take to the overview, and here what is nginx, and first option hosting some simple static content. Okay, this is the way. So docker run is our command, name of the container that you want to mention, and then here image. So name is the option, and after that you have to give the image container name that you want, and then this is mountings, this is bind mounts. So anyway, now we are not using this, and after that it is detached mode, and finally the name of the image. This is one way of giving, and the another way, so place this file, or you can give docker run name and detached mode and image. Okay, and this is one way. If you want to expose this to external port, and this is what we have to use. Anyway, we want to expose this to external port so that we can access this application. So then we have to use docker run name option, that's a long option, then name of the container, then detached mode. D option is detached mode, and P option is the port mapping, then image name. So let me copy this. This is without any port binding. It's just, and get into our machine. So I'd say and paste it. Okay, so let's say docker and run name. I'll give nginx or load balancer, and detached mode. Run this in detached mode. I don't want to print on the screen. I don't want to print the output or logs of this container on the screen. So that's why I said detached mode. Whereas a hello world example, we have run interactive mode. In that the message has been printed on the screen. Okay, so then I'll go for the port mapping 8080 with 80 of the container, 80 of this server, this EC2 instance, or this Docker server. The name of this EC2 instance is Docker server. So 80 of the Docker server with the 80 of the this container that we are going to run. Then nginx image name and stable. So let me run it. It's done. It's been built very quick, very fast, because it takes a lot of time to build an image, but to run a container it takes seconds. Why? Because the image consists of everything. As we have seen in our previous slide, you see, this is our image consists of all the information, everything. It consists of everything. So that's why it is too heavy to build an image. It's heavy. Whereas a container, what container does nothing other than running some commands or running some systems or running some processes. That's it. So image will do a lot of activities. It's like carrying an OS or carrying some information. So let me get into that, and I'll say Docker PS. Now you see nginx stable, and name of the container is a load balancer, and Docker, and it is running at this IP at this port, and that been mapped with this. So 58 seconds ago it's been created. Now status is up and it's running. So now let me go to the AWS and let me take the public IP of this. So click on Docker server, public IP, copy this, and click on new tab and paste it, and 8080 and enter. That's it. Congratulations. You have run your load balancer or nginx service using a Docker container. This is your first Docker container service that has been run from Ubuntu service, and you have used the public IP and with the port, and you are able to access it from remotely through internet. It's not a local host. It did not happen in your local host machine. You have accessed it through internet with public IP and with port. Congratulations. A big congratulations. You are moving ahead. Okay. So now, but this is not our agenda. So our agenda is to cross check. Our agenda is to check these things, whether if you open that, will you find this information, will you get this bin boot tmp where root home, will you find this application code layer, will you see that? Let's look into that. That's what the main agenda. So the main agenda in this exercise is to, so running is also successful. So now the main agenda is to look into the layers of the image by using the container terminal. Okay, that's what the main agenda. Let's get into our terminal, get into our Docker server again. So everything is fine, but let's check the Docker logs and then let's look into the other one. So Docker logs, and container name is a load balancer. You see that this Docker log, yes, we have said detached mode, we gave D option, so that's the reason these Docker logs has not been printed on the screen, or else it would have been printed on the screen. And Docker log, what is happening at every second is all been printed on this. Okay, which is executing at what time, you see, using the epoll event method, start worker processes, and then now 157.42.47, this is a IP, and when I call this, it's the get method has comes into the picture, the get method, and then it has fetched this, and we were able to look into that using a browser. So that's what is happening here. So now let us enter into the terminal of the container. Okay, so now you just observe this. Okay, let me clear the screen first. Before that, docker ps, let me give, okay, let me keep this. Then docker, first observe this. Now at this moment, root, who am I? A root user. These are Ubuntu user, other processes which are running. Okay, so root is the user and this is the host name at this moment. Okay, just remember this, or I would copy this there also. This is our total prompt, out of which this at this moment, these are the root. Okay, root user, root is user, and this one is our host name. So now let me say docker exec and option I interactive mode T terminal. Terminal, it will take bin bash. So container name load balancer, and which terminal I want to use, TTY bin bash. So now let me copy this again and I'll paste it here. Copy and paste it here. So what's the difference between this and this? User, root user, this is the host name. IP 172.31.41.36, that is private IP of our EC2 instance. Here username is root, whereas host name has been changed. Host name, what is this? This is the container ID. Okay, you see that 74E9B494496E is the container ID. Okay, so now where are we? Where are we? See, host name is this container ID and this. So that means we are inside the container now. Now we are inside the container. So now let me clear the screen as we are inside the container. Okay. Now we are inside the container. So now what I'm gonna do is, so I will give ls first to find out. See, this symbol means where are we now? We are root home directory, ls. We are in root home directory. So I will go into the root virtual directory. Yes. So this is the root virtual directory. You see that? You see exactly the directories that we have mentioned here in our slide. Bin, boot, tmp, var, root, home. Here also you will see same thing. You see? Bin, boot, dev, etc, home, media, proc, as bin, tmp, lib, mnt, root, srv, user, opt, run, sys, var, everything, almost the copy of an OS, a copy of an Ubuntu. Okay, why? Because it's a Ubuntu OS. It is Ubuntu distribution, but it is miniature. You might not find all the you might not find all the utilities that are there in our EC2 instance machine. May not be. You might not find all of them. Okay, you can find very few because this is a miniature level and it is lightweight container. So that's the reason. But the point I want to prove here is Docker image is nothing but layers, that is first. And second, the Docker container is nothing but it consists of a miniature distribution. Inside it could be Ubuntu or anything, and inside, as a normal virtual machine, a normal EC2 instance consists of these directories. Similarly, a container will also consist of same directory. How the EC2 instance works or virtual machine works, similar way the container directories and their functionality, everything works in the same way. There is not much of difference. So let's explore more inside the container. So I will give ps. So you see that ps command itself is not there. That's what I am saying. ps is to fetch the processes which are running now, but ps command itself is not there. So apt update, I will up. I'm doing this operations inside the container, inside the container terminal. Okay. So now I'll install apt install ps. I'm installing the ps. Unable to locate package ps. That's okay. Whatever it may be. So ls run sys var. Now let us get into var directory, var ls backups liblock run and cd to srv ls. Nothing is there inside the srv. And cd user inside that you will find bin lib. It's exactly similar to our EC2 instance or a virtual machine, Ubuntu machine, because it consists of similar things. Nothing, there is not much of difference between this and that. So hence, this has been proved. The layers inside it will consist of the similar directories, and we can log into that using this. So this is proved. So now I have to exit from here to come out of that. So now exit it. Now you see, now the host name is IP 172.31.41.36. So this is the host name of the EC2 instance Docker server. This is the host name of the Docker container. So now, so this has been proved. Okay. Main agenda, this has been proved. And let me enter into the one more time, Docker exec it and load balancer, and it is bin bash. Now echo nginx yes, that's it. You see that nginx is there and it has printed nginx version. So that's 1.2.2 and more we'll check. Nginx version is done. So path, we'll just say echo path. You see that these are the paths normally: user local as bin, or user local bin, or user as bin, or user as bin, or as bin as bin. So these are the different paths. Each path is separated by colon. These are all colon separated. And one more, we have package release. We'll go package release also will get one bullseye. Okay, now let's get out of from the container. So now this part has been proved. So now we are going to run more containers from the same image with different versions. Okay. So the initial container is just a load balancer. Then after that we'll create load balancer version 1, load balancer version 2, load balancer version 3, and we'll see what's going to happen. So now we'll run more containers from the same nginx image and see what's going to happen. So get back to our and clear the screen, and it is docker run the command docker run. Immediately after that we will give name option, and the name is load balancer and version 1, and after that we will put it in detached mode. Then we will give port mapping, so 80. Instead of 80 I will give 80, but this time 40, 8040. No, I will give 8010 for this, and for other one I will give other one. So 8010 port mapping with 80. Then name of the image remains same, nginx latest stable. Sorry. So let's build. Okay, invalid container name. Okay, that's fine. I gave it in a wrong way. Done. That colon should not be used. That's my mistake. Sorry. So now I will check ps. Okay, sorry, docker ps. You see that you have two images. One is load balancer. Sorry, two containers. One is load balancer. Other one is load balancer version 1. So just now it's been created, and 8010 is where it's running. So let me copy the same URL and paste it here, but 8010, correct? 8010 here. One is 8010, other one is 8080. So let me get there. So let me execute it. That's it. That's it. It's not magic. That's how it works. So and here, so now two containers are running inside my server. One is 8080. I have refreshed it. You see that? Refreshed it. Still it's working. If you have a doubt, I will copy it and close it and paste it in a new browser and see. See? It's working. It's hosted. It is live. It is not a local host. It is running through internet. And here again 8010. So two containers are hosted. Two are running now. Two are running. Okay. You see that? Two containers. You see this? Container 1, container 2 from the same application, and they are hosted in different ports, and both are running and both are visible. So that's the power of containerization. That's the power of containerization. So let me get here. So we will run one more container. Same. Everything remains same. Port mapping would be 8020 this time. And this is version 2. And here rest all same. Okay, let me execute. Docker container has been spun. You see that Docker container has been spun. Let me check the Docker ps. Now you see, let me make it a little smaller. Yeah, this is fine. So three containers, version 2, load balancer version 2, load balancer version 1, load balancer. So three containers are spinning now. Okay. So now this is spinning at 8020 port. So now let me click it. Let me check that also. Copy this and take a new tab, paste it, but this is 8020 port, and execute and see the magic. Ting, 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 ting. That's working. So one server, one instance, three containers. One instance, three containers still running. All are running. Let me refresh each and everything. Refresh, running, refresh, running, refresh, running. Okay, you see that? Single image, three containers. Container 1, container 2, container 3. So let me run a final one. And this time 8040. It is version 3 and execute. Rest all remains same. It's also created so fast. Now give docker ps. Now you see 4 containers now. Load balancer version 3, load balancer version 2, load balancer version 1, load balancer. So load balancer version 3 is at 8040 port. So let me copy this and go to the browser and okay, copy this and paste it in new tab and change it into 40 and execute. You see your page. That's it. So one server, 4 containers at 4 ports, still up and running, no problem at all. Hence proved. With one image you can principally run any number of containers with the same image. That's the power of Docker. Hence we have successfully proven two things. One is the Docker image consists of a miniature level of OS inside that. Second one is it runs processes with a single image. You can run any number of containers. So it's done. So the exercise, Ubuntu based server using nginx container in Ubuntu based server is successful now. Let's do similar kind of example in Docker desktop, so that if you do not use commands, and how does it look like, how does it work. Okay, so let's do the similar kind of example, but this time we will take a postgres container. So postgres, we will take a postgres image, and from that we will run a postgres container, and we will do the inspection, and we will do the log check, and we will enter into the terminal of that, and similar, and we'll see how does it look. How does it feel like if you use a Docker desktop, and how does this differentiate the feel between a Docker desktop and a Docker engine in a Ubuntu server. So that's the main agenda here. The main agenda in example 2 is, so let me close this completely. So example 2 is running Postgres container in Docker desktop in Windows OS. Okay, so agenda, point to be proven here is to same thing, but inspection and all those things, inspection, logs, and terminal, using the container terminal of the container, and see the differences between Docker engine and desktop. So let's get into the action. Why to wait? This is the example 2. So now I'm getting into the Docker desktop. So no image, and no container at this moment. Okay, so I will click on run postgres sql directly. So when I click run postgres sql, it will pull the postgres container image. It will pull postgres image with latest tag from docker hub. I'll show you that also. Yeah, we are here and they're still up and running because our server is up and running. So this is our docker hub. So let me come to the official images and click on and type. Okay, let me scroll down. No, it hung. So let me take few minutes, maybe few seconds. Let's wait until it responds back. Yeah, it's done. So let me scroll down. You can see here postgres sql and click on tags. Yeah, this is the latest tag. Yeah, docker pull postgres latest. And let me get back to the docker hub. Yeah, it's done, it started, but let me take to that. So image postgres and latest tag, this is the image, it's been pulled, and here you can see all the information. View details, once you click on view details, it will take to that other place. That's okay. Before that, let me come to the containers. The container is up and running, no problem at all. So it's a postgres latest image is used, and name of the container is postgres s8h4. So rest all is fine. Anyway, we have seen how to start stop container and delete the container. That's okay. So now let me come to the images and let me check volumes. So one volume also has been created. This is the volume. It's been created. The volume ID. Okay, because it's a SQL database. Obviously, database requires a volume. So bind mount volume, that too. Mount, so is required. So that's why it's been attached. So now let me click on, if you want to check, inspect or check the logs or enter into the terminal, what you have to do is you have to come to this three dot icon. So you click on that icon, it opens view details, and click on view details. So then it opens a new window. So here you can find complete information. I told you it's a layers. An image, a docker image is a layer, yes or no? So now you can see that. I just want to prove the same from here. So let me click on images. I don't want to show the vulnerabilities and all. Yeah, so keep it like this. You see, this is the image postgres latest, and this is from here it brought. This is the base image. This postgres has taken a base image of Debian. You see, Debian is kind of Ubuntu. So the directory structure will be directory structure remains same. So let's look into the directory structure after a while. So postgres, and after that you see the each image now, each layer now. Layer 1, add file, this is one instruction. Then command bash, this is another instruction. Then set command, then set, then environmental variable, then environmental lang. So these are 25 layers it has. How many? 25 layers. It's not 125, because each command is a layer. So each instruction that you mention is a layer. And finally, so at which port, expose it to the 5432. And then finally the last command, this cmd is used when you run, when you say docker run, that time whatever you mention inside the cmd, that will be executed. So now whatever I have shown here, just I'll get back to your nginx container. You see, I have shown an image consists of a layers. layers of different things. So this is our base image. There also the base image is Debian, and after that you will have an application layer. There also we have a lot of application layers. Lot of application layer is nothing but instructions. You will have different instructions that we have there. So now let me get back to the Docker desktop and to show everything there. So we have taken from Ubuntu the base image, Debian, sorry, not Ubuntu, Debian. You see that the Debian Slim has been taken, and after that you see that Debian Slim, Docker official, and after that these are all different instructions that are mentioned. Total 25, and each instruction is a layer. When you say a Docker build, so each instruction will be built as a layer. So total it consists of a 25 layers. Okay, so 25 layers it consists of. I think hence it's proved that image is nothing but a layers. A layer is nothing but a instruction that you write inside a Docker file. That's it. It's that simple. So then here these are vulnerabilities, and these are not that important for us. Okay, so this is what you can inspect inside the image. So now let me get back to the image again. So there is nothing much to check here. So now let me go to the container. So now we are going to do more here. So click on show container action. You have a lot of things. Copy Docker run, open this in terminal, or pause, restart, and open this in browser. So I will click on view details. You see that? Now you got a lot of. So first one is logs. Let us go through the logs one by one. So logs, server started, and entry point, and requests, complete information, and finally postgres SQL init process completely ready for startup. So this is the logs. But if you want to see the logs, there you have to give command. To check the logs, you have to give command. But here you don't need to type a command. You just go to that three dot icon and click on that icon, view the details. You will get into the logs directly. Okay, you can copy this logs and you can delete the logs also. Okay, so this is what. But now inspect. How did we do inspect in Docker? Using Docker inspect command. But here just click on the inspect option. You will see the Docker inspect. So what all we got there for inspect, Docker inspect? When you say Docker inspect, we got information about the Docker, different variables, environment variables, and then port ID, and then port number that's mapped and everything. So here also you see environment variable. The password of this Postgres is this one, Postgres PW, and path. You got the path, environment variable, lang, and many more. Just a minute. And mounts, you see that this is the mount. Let me take to the volumes. I'll just copy this. This is where it is, var lib docker volumes, and this has been mounted, this has been connected, this is inside the, let me, okay, copy this. This is inside the Docker container and paste it inside here. Yeah, this is inside the Docker container, and this has been mapped with the var lib PostgreSQL data. Okay, with our machine, with our Windows local machine, it's been mapped with this var lib. So now you see 8776 and volumes 87761. Okay, that's what the volume is, that's what the bind mount is. So let me get back to the containers again and get into the view details. So that's what the terminal is. Now it's time to enter into terminal. That's what the inspect is. Now it's time to enter into terminal. Now you can see that pound. So let me say who am I? Yes, it's a root user. Who am I is a root user. And then host name is this. Let me copy this D080 and let me go to the container D08009. Hence it's root. So it's the terminal of the container. It's not some other thing. It's the terminal of the container. So now let me click on view details again, and again click on the terminal. Okay, so now let's see the pwd. Where are we? So we are in root virtual directory. So now let me say ls. You see that you can find bin dev etc lib media opt root sbin user boot home lib64 mnt proc run srv temp var everything. Damn same. Damn same. Because the base image, this is the first layer of our image, Debian layer. This is our first layer of our image, and this layer consists of a miniature Debian OS. So the directory system is always same as our EC2 instance. So again, let me get back to our Docker desktop. So now you can check more. So one more thing I want to check is this correct. Where is that? Var lib. Okay, cd var that doesn't work. Var and lib ls. So inside that we have apt dpkg. I want, see, you see that your postgres SQL. So cd postgres. Okay, it's not working. Postgres sql and cls data. So cd data cls. Here you have base pg commit and postgre.pid ops autoconf pg version pg stat, and exactly where it is. It is in volumes. It is in var lib docker volumes. It's not in postgres. Yeah. So here cd var. So postgres SQL. Okay. Hence it's the first part has been proved. The layers is clear and the miniature OS is also clear, and you can see that visually on Docker desktop too. And we have entered inside the terminal and we have checked the directory system also there. Okay, so then finally we'll check stats, and this is what 31.2 MB. So now let me come to the image and we will build another container. So settings, container name, database version 1, and host port, this is 8080, no problem, and run. Okay, postgres host auth method trust. Postgres password is empty, and I will give password also this time. Yeah, that was not built. So now I will run a container. Options, database v1 8050, and this is paste it here, and password, and click run. Now okay, error invoking docker run container conflict. The container, okay, the database name is already given. Okay, sorry, that's my mistake. I have to add one more database v2 and 8060 and paste it, pass wd and run it. That's it. Now it's running. Your PostgreSQL is running because we need to give a super admin password. That's it. Then it will run. So inspect, you can inspect and you can check your terminal. You want to basically, if you want to work with your PostgreSQL, if you want to give Postgre queries, then from here you can give actually. So that's the main purpose of having this Postgre uh, that's the main purpose of log entering into the terminal. So from there you can do you can give postgre command, postgres. You see that at this moment it's a root execution, but still fine. You can, from here you can give. So let me get into the containers. You see one is dead, this is not working. I will delete that. See, two containers are running from the same image with a different user super admins. So I will run one more container with a different super admin, but image remains same. This is database version 3 8070, and here Postgres password, and here I'll give same passwd and run it. Yes, it's running. Inspect terminal stats, get back to the containers. You see all three are running with at different ports with different super admins with different super admin passwords. Hence, so the left side has been proved and right side running processes running different containers with the same image also has been proved. So get into our, so this both the agenda example 2 also done, it's been proved. So click, yeah. So we have run Postgres container in Windows based server using Docker desktop, and we have proven that. We have shown various layers and we have proven that also, and we have also proven that same image you can run multiple containers with the different super admins and different super users. Let's look into one more example. So this time we are going to run a getting started container, the Docker getting started container from Ubuntu instance, EC2 instance that we have created. So we call that instance as a Docker server. So from that machine we are going to run Docker getting started container, and we will access that container application that is hosted inside that container through public IP of the EC2 instance, the Docker server, and the port that we have mapped with the container. Okay, and then after the accessing it, we will we will inspect the container once. That's what we are going to do in this exercise. Now let's jump into the exercise. For that I have to take, so clear the, okay, clear the screen. So at this moment I have Docker images, two images, nginx and Helloworld, and Docker ps, four containers which are running. So 8080, 8010, 8020, 8040, and on the browser all four are still up and running from the same server. Okay, so this time I'm gonna use 80, that's it. So I'll pull docker, pull docker getting started image. So using default tag latest, so it's pulling from Docker getting started. It's been pulled. So now let me check Docker images to list the images. You see Docker images, you found Docker getting started with our latest tag, and this is the image ID. So now let me run it. So Docker run, and the first thing that we are attaching is a name. This is documentation, document container, document container version 1, and detached mode and port mapping 80 of the host machine with 80 of the container. Then name of the container is Docker getting started. So let me execute the run. So the container has been built. You can see that here. So now I say Docker PS. There are a lot of containers. But where is mine? Yeah, document container version 1. That's the top one. So public IP we need to take, and then port of 8 host port is 80. So let's access it first, and then we'll see what's going to happen. For that I have to enter. I'll take the same IP. Let me cross check the public IP once. Yeah, public IP remains same, and then port is 80. Copied. Open a new tab. Paste it. Default port is 80. I don't need to give, but still I will give 80, and let's see what's gonna happen. 80, and click enter. That's it. That's it. You see, 65. You have accessed this application from or through internet using Docker container. This application has been hosted. So let me get back to the source code, PPT once. 1, 3, 2 exercises. Yeah, if you see here, one layer would be base image, and after that you have to attach an application code layer. Okay, so that's what we are seeing here. This is the application code layer. This is what the application is. So this application code is will be attached in one layer. So when you run it, we are going to see that application, and we are able to see this application, and we can move across this application. The complete web application has been stored here using bind mounts, completely a brilliant one. Multi containers. How do you connect with the multi containers? And if it is MySQL, then how will you do that? So you can attach your environment variable. So your MySQL root password, then volume, bind mounts, and MySQL database name. This is the database name. Okay, this we are going to do. This we are going to do anyway. Okay, so this is the detailed documentation, but we used Docker container to run it, and we have run it successfully. So let's create one more container with the same image at the different port. So Docker run, everything remains same. This time I'll give port number 70 and version number 2. Rest all remains same. Container has been built. Docker PS, Docker container version number 2 and port number 80. So let me get into the browser again and copy this and paste it here in a new browser, and remove this and put 70. That's it. That's it. So from the same server, how many containers are running? You see, 6 containers are running. from the same servers, up and running, still up and running. That is the power of containerization of applications. This is the power of containerization of applications. Okay, so now we have seen these are up and running. Now if you want to inspect, use docker inspect, and it is docker getting started. You can see that each layer, various layers, so these many layers are present in that. And working directory, if you want to see, this is the working directory. Just remember this working directory. When we log into this, we should, when we enter into the terminal, we should automatically log into this. Okay, let's do docker exec it. Okay, name of the container is mm, docker. No, this is, what is the name of the container? Docker ps. It's docker, oh, document, sir. Docker exec it option, and it is document version 2. I will do that, version 2. Okay, sorry, my mistake. So bin and bash. What's the issue? A runtime exec failed, unable to start container process. Exec bin bash stat, no such file, or docker exec it container name. Okay, let me give just ls. You see that bin dev. Let me click, let me say pwd. We should get it present working directory of that. It's in root directory. Okay, so in root directory you have all this media, mnt, and srv systmp uservar. So it means it is a miniature Ubuntu or Debian OS, or either Ubuntu or Debian OS, and that's also been proved even with this also. So let me clear the screen and let me get back to the ppt. So with, even with the third exercise, we are able to prove the same things. So this is what we have done. In third exercise, we have run a Docker getting started container, and we have exposed it to the browser, and through browser we have accessed the same application, and we have gone through that application. Now our fourth example here is, let's run the similar app getting started container from Windows PowerShell through the Docker command line without using Docker desktop directly, explicitly. So implicitly the usage of Docker desktop will happen, but explicitly we are not using. So we will open the Windows PowerShell, and in Windows PowerShell we will have a Docker command line. We will give the Docker commands there, and we will run the container, and the container should be built, and the container should be appeared and in Docker desktop. Let's do this exercise, and then we will host that similar application in our local host machine, and we'll see. Okay, so let's get into that. So let me open Windows PowerShell as run as administrator, and I say S. Let me clear the screen, and Docker help. Okay, yes, you got the commands. That means the Docker has thrown help. That means the Docker client, that is CLI command line, Docker command line interface is available. The Docker CLI is available. Anyway, Docker engine is available with the Docker desktop, and API connection is anyway there. So now I will give commands from Docker CLI through Windows PowerShell, and it will go to the Docker engine and it will be executed there, and it will be shown through the Docker desktop. That's what the process is going to happen here. Okay, let me type that. This is the fourth exercise. Example 4. So I'll type it clearly. Client Docker command line interface, that is our client. This client will be executed, the client will be operated through Windows PowerShell, and we have API which makes connection and communication between Docker CLI and Dockered or server or client server. Then we have a server, that is, or else we call it as a Dockered. Okay, this is our Docker engine, and so the commands that we give from the Docker CLI will be executed by Dockered or server, and or engine or Docker engine, all are same. Dockered or Docker server or Docker engine, all are same. Through API, and these will be displayed by Docker desktop in a graphical user interface. That's what is this exercise. So now I have opened the client Docker CLI and it is working properly, so I will mark it. So now let me give commands from here. So first activity I'm going to do is Docker pull, it is Docker and getting started. So the image is being pulled. So pulling from Docker, getting started. So 3.371 MB. There are a lot of layers. Almost 3 plus 3 plus 3. 9 layers are present. 6 layers has been pulled. 8 layers, 8 layers has been pulled, and last layer has been. So all layers has been pulled. So now getting started latest. Now let me go to the Docker desktop and we should find. You see that? Just you see Docker getting started latest unused about. Okay, it was created 1 month ago, that's fine, it's a recent one, but it's been pulled into our local machine. Okay, through this I'll give Docker images. We should find two images here. You see, postgres is one image, and this is our Docker CLI, and second one is Docker getting started, two images. And let me check here. You see, postgres and Docker getting started, two images are present. And let me check Docker ps, how many containers are there? 3 containers are running. And let me check here, how many containers are running? 3 containers are running. Absolutely brilliant. 3 containers are running, so hence it's proven. So now I'll go to this. So that means there is a proper communication between client and server is happening through API. So event server has come, takes. Now let's clear the screen and let's run a container. That is docker run name. I'm gonna give this is docker doc container, docker doc container, and detached mode and port mapping 8 50. I'll give localhost, that's fine, 50 and then 80, and content image name is docker. Okay, what's the issue? Image name is docker getting started. Yes, it's been built. I'll say docker ps. You see that docker doc container has been built 3 seconds ago. Let me quickly get into the docker desktop and you see docker doc container has been built. It's running. So I can directly click here to host it in our local machine. Yes, that's it. It's been hosted. Local host and port number is 50. That's what I have mentioned. If you have a doubt, I will show it again. Again. Okay, this is not the one. This is not the right place. I'm sorry. I'm in Windows PowerShell. You see that? 50. This is the port I have hosted, and this is the Docker container which is running at that port in our local machine, in my laptop, in my personal laptop, in my host machine, in my local host. So hence it's been hosted. Even it can be hosted using command line interface even in Windows machine also. So hence we are able to prove that. And if you want to cross check again, you can use docker inspect and then docker no, this is not the one. Docker inspect, docker getting started image. Yeah, this is. And if you want to exec, docker exec it, and it is docker no docker doc container and bin bash. And if you want to run some commands, you can run commands ls. You see that the commands has been run. And if you want to do pwd, you can do pwd, and or else you can do bin sh. Now we have entered inside the container terminal. You see only pound symbol. We have entered inside the container symbol. We can give pwd, you can do ls, you can do whatever you want, because we have inside the container terminal. And let me get back to the docker desktop, and or else you can just click on show container actions, view details, and come to the terminal and say ps. You see that all the processes which are running. So what all processes are running? nginx master process, daemon of nginx worker process, and bin shell and ps. These are the processes which are running inside that. And then you can give ls. You see that it's exactly similar to a, it's similar like a miniature OS. And pwd time and date, uptime, a lot of things. You can do whatever you want. As so now we are able to prove this also, like client API and server architecture and commands. We have executed commands and it were displayed by Docker desktop in our graphical user interface also. So let me mark that. So now let us clean up. So final one is cleanup, or I would say housekeeping. So let's do the housekeeping now. let's begin with here only. So I have two options, but I will clean it. Some I'll clean it from here, some from Docker desktop. Okay, from here to clean. So okay, first I have to exit from here. Yeah, clear the screen. So Docker ps. So how many are there? Docker ps option a. So same. So for me, total 4 containers are running. So I will stop the container first. Docker stop, and I'll give the name of the container Docker. Docker doc container stopped. So the Docker container has been stopped. Docker ps, you see now only 3. Now I can remove the container saying docker rm docker doc container. So now let me check. Docker ps gone. Docker ps option a gone. You have only 3 containers. Okay, so this is how you remove the container. And for images, Docker images. So I have 2 images. So I will delete postgres image from here. No, Docker getting started image from here. So Docker, just a minute, Docker rmi, and I'd say Docker Docker doc. It is no image name, no, sorry. Docker getting started. So the image has been deleted. Each layer has been deleted. So now let me give Docker images. This is called, see, it's been deleted. This is how you delete from Windows PowerShell. So now let me get into Docker desktop and user interface to delete the same. So let me stop the containers first. All containers gone. Stopped, exited. Now I can delete it from here without any commands. Delete forever and delete. Oh sorry, these are logs. That's not a good idea. It will be delete forever and delete forever. So containers has been deleted. So I have only one image, so I will delete the image also. That's it. Our Windows machine or local host or local machine has been cleaned up. So now let me get into my Docker server, and let me do the housekeeping here also. Sudo I clear the screen. Let me check Docker images. I have 3 images, and Docker ps I have a lot of containers. So now Docker ps a. So I have more containers. So now let me stop the container one by one. Docker stop. So hello world has been stopped anyway. And then other containers. So Docker stop. Load balancer 1, load balancer 2, load balancer 3, and document container 1 and document container version 2, and stop it. Error response from daemon, no such container. Load balancer 1, 2, 3. Okay, that's fine. That's my mistake. Let me do that. Version 1, version 2, load balancer version 3, load balancer version 2, load balancer version 1. Yes, all were deleted. All 5 were deleted. Now let me check Docker ps. Okay, still one container is running, that is load balancer. So let me delete that. Let me stop that also. Docker stop load balancer. Done. So now give me Docker ps, no container at all. So now what I will do is I will do Docker psa. There are a lot of containers, so I'm going to delete each container. So Docker rm and type name one by one. Nice tarp is hello world container. Then we have load balancer container, then load balancer version 1 container, then load balancer version 2 container, load balancer version 3 container, and document version 1 and document version 2. Done. All has been deleted. I will say docker psa empty. House is kept clean. Then let me check docker images. Sorry, docker images. I have 3 images. So let me clean up this part also. Docker RMI, nginx, and docker getting started, and Helloworld. That's it. All has been deleted. So docker RMI, sorry, clear the screen. Docker images. That's it. Gone. House is kept cleaned. So here we have seen how to run a getting started container using Windows PowerShell, using Docker command line interface, and accessing the application in localhost. And we have done the housekeeping for all the containers that we have run till now in Windows host machine as well as Linux server. That's a Docker server in both cases. And let's, before we close, let's get into the browser and we'll cross check all one by one. So this is what, welcome to nginx. We have stopped this container, we deleted the container, we have LC. What's going to happen? Gone. This is also deleted. Gone. This is also deleted. Gone. This is also deleted. Gone. Getting started is also deleted. Gone. This getting started with port number 70 is also deleted. Gone. And getting started with port number 50 in the local host is also gone, because we have stopped the containers and we have deleted the containers. We have kept the house cleaned. Now let's look into images and containers together. If you are unfamiliar with Docker, this may be the first time you have come across the words containers and images in this context, in software context. Okay, so you might have heard in some other context, in shipping related or transport related or workshop related, but here it's software related, deployment related. So they're probably the most important concept in Docker. So it's worth spending a bit of time to make sure the difference between image and container is pretty clear. So in this slide you will see an illustration of these concepts, image and container. So with 3 containers started up from 1 image. Of course we have done it in our previous examples, so but still I just want to make it clear. So one way to look at images and containers is to see them as analogous to programs and processes. In the same way, a process can be seen as an application being executed. A Docker container can be viewed as a Docker image in execution. So if you are familiar with object-oriented principles, another way to look at images and containers is to view images as classes and containers as objects. In the same way that objects are concrete instantiations of classes, containers are instantiations of images. So you can create multiple containers from a single image, and they are all isolated from one another in the same way objects are. So whatever you change in the object, it won't affect the class definition. They are fundamentally different things. The same thing is applicable to here. So let's take this example which you see on the screen. So the base image that we are going to check is Ubuntu. This is our base image, Docker Ubuntu, that we can get from official website of Docker Hub. That is where is that Docker Hub? Yeah, this is your official Ubuntu image. That's what we have considered here. So now this official Ubuntu image consists of a, as usual, directory system or file system, a bin bash, bin bunzip, busy-cat, and a lot of files in it. And it consists of metadata such as port mapping, environment variables, and it consists of all the directories that a Linux machine consists of. So that is our base Ubuntu image. A Docker image consists of files and metadata. So image files take up most of the space. Why? When you see, I have shown you both a Docker image and container. Container can be spun within a second, whereas to build an image it takes huge amount of time. Why? Because image files take up most of the space because of the isolation each container provides. They must have their own copy of any required tools, including language environments or libraries, because image consists of all the files. Even if your application code, if you have a source code, that source code, or you have a package, everything will be placed in the Docker image only. So that is the reason it is too heavy. Then now let's build three containers from this image. So the container one, now let's run a container one. So container one has taken Ubuntu as a base image, but the process which is running inside this is Node.js. But the base image is Ubuntu only. Okay, container run one process on startup. When this process completes, the container stops. So that's this startup process can spawn other, and changes to files are stored within the container in a copy on a write mechanism. The base image cannot be affected by a container. And we'll look into the second container. Similarly, second container is also going to use base image Ubuntu, but the process that is going to run here is MySQL. Okay, so here, and the third container similar to that, base image is Ubuntu, whereas the process is running is Apache 2. So here it's gonna deploy an application. So containers are created to conclude this, and the matter of the fact, and then if you put everything in a nutshell, containers are created from images, inherit their file systems, and use their metadata to determine their start of configuration. So containers are separate but can be configured to communicate with each other. So now let's look into the most important concept or activity of Docker, is to writing a Docker file. Till now, what we have done, till now we did not even write a single Docker file. We did not build a single Docker image. Everything is pulled from the official Docker hub. Everything we have pulled it from official Docker hub. So now we're gonna write our first Docker file, and we are going to build our first Docker image also, and we are going to run our Docker container from the Docker image. So all those things we are going to do, but without a Docker file you can never ever customize your applications. If you want to add a source code, your source code, how can you do? You have to write, you have to create your own Docker file, taking the inspiration from the existing Docker files and using the base images of official base images from Docker Hub. So now let's look into how to write a Docker image, how to write a Docker file. So there are four standard ways to create Docker images. So the following table itemizes these methods. The first, by hand. So option is fine if you are doing proofs of concepts, POC, to see whether your installation process works. At the same time, you should be keeping notes about the steps you are taking so that you can return to the same point if you need to. And second, you have a Docker file. So in this case, you have to write your own Docker file. The first one is it's by hand. It's nothing but by typing a Docker commands one by one. Okay, fire up a container with Docker run and input the commands to create your image on the Docker command line. So that's one. And second one is using a Docker file. For Docker file, build from a known base image and specify build with a limited set of simple commands. That's called writing a Docker file. And Docker file and configuration management tools. So you can use a configuration management tool with the Docker file. They act hand in hand to bring to make a sophisticated applications, so big, very big applications and microservices. Or scratch image and import a set of files. From an empty image, import a tar file with the required files. So these are different ways of doing, but however the widely used methods are Docker file method and Docker file and configuration management tool for the complex and complicated applications. Okay, now we are going to do a Docker file method. Okay, a Docker file. What is a Docker file? What is a Docker file? A Docker file is a text file with a series of commands or instructions. You say commands, but they are commands, but fundamentally they are instructions in it. That's it. A Docker file is a text file with a series of commands or instructions in it. That's what we call it as a Docker file. So let's look into a Docker file. So a Docker file begins with from. So you begin the Docker file by defining the base image with the from command. So this here in the from command, the value that we have given is the argument that we have gave for the from command is node. So node, this uses a node.js image. So you have to access to the node.js binaries. So the official node.js image is called a node, and that base image will be pulled from the Docker Hub. So then we have next, you will declare the maintainer. Now it's deprecated, but still maintainer. So maintainer command consists of an argument. So that argument you can give your email address just for reference. It's not that important. Then we have one more command, that is you clone the app code with a run command. This uses the specified command to retrieve the code of the application. So running git within the container, git is installed inside the base node image in this case, but you can't take this kind of things for granted. You have to make sure while doing these operations. So if it is not installed by default, so it's better to attach that command also, run apt get install, sudo apt get install git and space and option y. So you have to give by default if it install, but if it is not installed, it's better to install. Okay, then we have work dir app. So what is work dir app? So once now you moved to the new clone directory with a workdir command. So not only does the change directory within the build context, but the last workdir command determines which directory you are in by default when you start up your container from your built image. So workdir app, when you say workdir app, whenever you log into your container or whenever the container is started, whenever the container is spun, at that moment immediately the default folder, the default directory or home directory of that container would be this app. Whatever actions that happen, that will happen in this directory, because that's the home directory, that's the working directory. See, when you log into the Linux server or EC2 instance, where do you log in? By default you log into your user's home directory. Similarly here also, whatever you say workdir app, that is the by default. When you log into your Linux, when you log into your container, you will enter into that directory. Okay, then let's do run again one more time. Now you run the node package manager's install command npm, and this will set up the dependencies for your application. You are, if you aren't interested in the output here, you can redirect this output to the dev null directory. Then we have expose. The port 8000 is used by this application, so that's why we want to expose this application to the 8080 of the container port. Okay, so use the expose command to tell Docker that containers from the built image should listen to this port at 8080. And finally, the most important command is cmd. You use the cmd command to tell Docker which command will be run on start up the container, on start up of the container. So all will be run, remaining all commands or all instructions will be run, will be executed during the building the image. The only one command will be executed when you spin a container is cmd. Okay, when you say docker build, all other commands will be executed from node till expose 8080, but this is the one is not going to execute it during the building the image. This one will be executed only when you spin a container, when you run a container. So now let's we have seen how to write a simple docker file. So now let's do our first exercise by writing a simple welcome docker file. Let's do our first exercise of writing a docker file, a simple a welcome docker file. So that will print a welcome message in Ubuntu server. Okay, using Ubuntu server we will do that too we will do it in Docker server. It's this example is in for a Linux machine. Okay, so let's get into the Linux machine. Let me take a sticky note and this is example 3 is done for, yeah, example for writing Docker file. So this is very simple. We will create a Docker file and we will write some instructions to be executed. That's it, nothing much. Okay, that's what we're going to do. But first we will write it. We will, first step is write the Docker file. Then second, build the Docker image from the Docker file. And third, run or spin the container container defined by the Docker image, and we'll see. Okay, these are the steps for example 4, and this we'll be doing in Linux server, or the name of our server is Docker server. So in this we are going to do that. Okay, so let's get into our exercise now. So let me get into my Linux server. Here it is, and I'll make it bigger so it's gone. Yeah, clear the screen. Sudo option I. Okay, so now it's ready. So let me do make dir docker exercises, and cd docker. That's okay. Yeah, ls nothing is there. So this is our example 4. So I'll say make dir example 4, or just in shortcut ex4, and welcome, cd ex4 welcome. Now let's write our first ever Docker file. So I'll make it smaller because it's not that big. So I just want to show you, yeah, this part also, and I'll keep it aside, side by side both, so then it would be much clearer for you. Okay, so now let's write it clear and make it a little smaller. So now let's write our first Docker file. I hope you're all excited to write your first Docker file as I am. Okay, that's fine. I'd say vim, and so the file name should be capital D and OCKERFILE. This should be the file name, Docker file. And click enter. Yes, and click I to write your first Docker file. So what's the first instruction? Always from. Okay, I say from, and I would use which image? I'll go to the Docker Hub, and yeah, here it is. Here is the Docker Hub, and I will click on explore, click Ubuntu, and pull this. I don't care about tags and all, or else if you're much worried about that, you can. But you just see here we are not pulling the image. We are not pulling the image. We are building our own image. For that you require a base image that we are considering Ubuntu. So we need to get the name of the image. The name of the image is Ubuntu. You see Ubuntu here. Ubuntu is the name, and after the colon it is tag. So we want only name. So Ubuntu is the name. So I will type Ubuntu. Done. So now it's simple. So I want to set up a working directory inside the container, not here, not in our server. So what I want to put is work dir. For work dir, what you want to put? This. Okay, before we put work dir, I would say maintainer. This is okay. Then work dir I'll put root directory of the container. Okay. Then a final one, it's most important. So till now the instructions or the commands that I have given will be executed when you build an image. Now I'm gonna give one command that will be executed if and only if you run or spin the container. That's what is that? What is that you see here? CMD. Specify which command will be run on start up of a container. I'll give it here. Okay. That is CMD and square bracket echo. What I want to print, I want to echo what? Welcome to the world of Docker from AI Charan. Done. And let me close the square bracket. Sorry. So all fine, right? No issue. So echo is the command, and after that we gave an argument. So both the, it's like Linux only. So Linux command. So this is command and this is argument. So when we spin a container, it will echoes this argument. Nothing much will happen. That's what is going to happen when you spin a container. Okay. So let me save this because it's done. So our Docker file has been created. Let me save this. W save Q quit. Done. Let me do ls and see. Here it is, your Docker file. And lsl, yeah, read, write, read, but no execution permission for anybody. But for root user, it's all okay. Docker is there. Okay. So now this activity has been done. Writing a Docker file has been done. So now let me go to the sticky note. Done. So now the second thing is to build the Docker image from the Docker file. So before we build a Docker image, let's see what does a building a Docker image mean. Okay, we will look into that first and then we'll come back. So building a Docker image, what does it mean? So to build a Docker image, which command we are going to use? So you have defined your Docker files build steps or build instructions or build commands. I'll show that if you have a doubt. So these are the, I'll put that cat Docker file. So these are the instructions or commands or steps that we have defined. Now it's time to build the Docker image from that Docker file by typing docker build and dot. That's it, nothing else. Okay, just type it, docker build dot. That's it. Okay, so in this, when you the first one is docker command and second one is the sub command and then the path to the Docker file here. So when you execute this command, you should be in the directory where the Docker file has been put or has been placed or has been created. That's very, very important point. Okay, so then once you execute this code, you will see this kind of output. So in that, the initial 2 lines is Docker uploads the files and directories under the path supplied to the Docker command or subcommand. Then step 0. Step 0 means each instruction or each line that you have mentioned inside the Docker file is called as a single step. So first we said from Ubuntu, that means that's the step 0. And the step 0 will be executed. Each build step is numbered sequentially from 0 and output with the command. You see that here, you can see that that steps number, we also call it as a layer another way. And then maintainer, so each command results in a new image being created and the image id output. To save the space, you see sometime you will find this removing intermediate container, this kind of information you will find. What does it mean? To save the space, each intermediate containers will be removed before continuing to the next step inside that you have mentioned inside the Docker file. Then step 2 is to cloning the git, and step 3, step 4, same thing, and finally debugging of the build is output here. And the last step is run, the step 5 is run chmod. This is again giving the access, giving the permissions to other user to execute it. And then expose it to the world 8000 using the 8000 port, and cmd npm start. This is the command. The step 7 is to is the command which runs when you spin a container. So finally you will receive this message successfully built and then an id. This is called a image id for this build. So now if you want to tag, you can use docker tag command and then mention the id and give the image tag name. Okay, we will do this exactly. Okay, clear? Let's do this now. Let's do this. Yeah, I'll keep it here first and then I'll move other side. So commands are clear. So let me clear the screen first. I'll show you ls. You see Docker file is there in this directory, exactly in this directory. I'm going to say docker build dot, and it's fine. Yeah, enter. So the first one, sending build context to Docker daemon. So it's what it is doing. Docker uploads the files and directories under the path supplied to the Docker build command. Okay, that is done. So then after that, the step 1 by 4, total 4 steps we have mentioned in our Docker file, out of which the first step has been started. That is step 1 by 4. What is that? From Ubuntu. What it has done, it has fetched Ubuntu latest, and then once it is done, each command results in a new image being created, and then this is the image id. In literally you can call it as a layer. The best way of saying is a layer. Okay, so you got the first layer because it's literally the final Docker image consists of a different number of layers. Okay, so now if it has a 4 steps, that means it will consist of a 4 layers. Okay, so and step 2, it got again an image id or layer id, and step 3 here, and removing the intermediate container in between. Basically, to set up this maintainer cherry rams, it has to run a container in between. So it has, once it is done, it has removed that container also. Okay, then the container id is this. Then we have step 3 is setting up the working dir. That also has been done. Then after that, we have the last step, that is cmd echo welcome to the world of Docker universe and from AHRN. So that also has been, that command is also has been created like a layer, but it did not get executed. That will be executed when you spin. So the step 4 that we have mentioned was, now it's been added like a layer to the total image. So now finally you got the successfully built image with this image id. What does this mean? So total 4 steps you have mentioned inside the Docker file. So all the steps were converted into a layer, and all the layers were put on or stacked up one by one, and finally we have made a one main image called 155b12ea9b5c. Okay, so calling this image with this id is pretty, it's very difficult. So that's the reason what I'm gonna do is, before we do anything else, we're gonna tag it. So Docker tag and copy this image ID and paste it here, and we're gonna say welcome version 1. Okay, welcome message version 1. Okay, let's click enter and see what's gonna happen. That's it. It's executed. Now let me check Docker images, and we have a welcome message version 1 image. You can see that clearly. This is what we have built. If you remember 155B12EA9B5C, see the same image ID, and then here it is welcome message. Okay, with this we have successfully built our first ever Docker image inside our Linux server. So let me mark this also. So now what's next? What's there to do next? Now to spin the container, that's what is left. So now it's time to spin a container. Now it's time to spin a container, run a Docker container. So for that, the command that you have to mention here is Docker and then run and then image name. So, and then image name, the last one. So the Docker run subcommand starts the container. So port P, this P basically P option maps the container port 8000 with the 8090 in this case on the host machine, and then option name gives the container a name. In this case we said container name as a sample 1, and the last argument here is the image name. And once you execute, this is what the output you get it. So in this this part is the output of the container starting process is sent to the terminal. That's what it means. Then the steps are being executed one by one, and you will go on. It goes on like that. Each one will be run, and finally you see, if you want, this is if you run this not in a detached mode, if you run this on interactive mode, you could see all these logs. If you run this on detached mode, you will not find any log on the screen. Okay, so as this command is in interactive, it is in interactive mode, so that's the reason you see all these logs. Okay, so even now we are going to run our first container. We are going to spin our first container from our customized Docker file interactively, not in a detached mode. So that's the reason I'm showing this. Okay, let's spin it in an interactive mode, and then we will use Docker ps commands or psa commands to see how many containers are presently running in our server. Okay, so Docker psa command is used. Run this command to see containers that have been started and removed, okay, along with an ID and status like this. And if you say Docker PSA, that's what, even if you don't, even if the container has been stopped, that container can also be seen using Docker Docker PS option A. If you want to start a stopped container, then you can say Docker start here, Docker start, and then container name. Okay, so now let's get into the action. Let's run our first ever container. You should be proud. You should be proud now. You should be proud now. You have built your You have written your own Docker file, you have built your own image. Now you are going to run your own Docker container. Take a bow. So let me do this. So let us get into the Docker server and let me make it bigger, much bigger. Yeah, this would be better this time. So I will keep it here and let me clear the screen. I say Docker run. Name I'm gonna give. Name port is not required because it's just it will just print a message and it will die. The container will print a message and it will die. So that's the reason you don't need to give a port at all. So name I'm gonna give welcome message or welcome container. Welcome container and after that image name. What is our image name? Welcome local message and version 1. Correct? So Docker run and name is mentioned, and at the end you have mentioned the image. Docker run, this is name option. After the, if you mention the name option, then you can attach a name here next to the name option. Then finally you have to provide the name of the image. Let's execute. It's gonna run interactively. Yes, it started. It's been printed. You see that? Welcome to the world of Docker from Charan. Congrats to everyone and everybody who is able to do this step by step. So let me get into this. So this also has been done. So the message has been printed successfully. So let me zoom it and show you. You see that here? You see that? Here? Fine. So now let me check the containers. So if I give docker ps, there is no container running because this container that we have just created will come and die. It will come and die. That's it. It's not going to sustain. So that's the reason we have to use another command. It's docker ps option a. You see that? You can see your command container. It's welcome container. Okay. It was in an exited state. You see that? It's in exited state about a minute ago. An image that it has used is welcome message version 1. Okay. So with this, we have completed our example 4 successfully. We have created our own Docker file. We have built our own Docker image and we have run our own Docker container. So now one more thing, a bonus thing that I want to give you, I want to show you is, I want to pull this, the fourth one. I want to push this image that we have created into Docker Hub. Okay. So before you push an image into Docker Hub, you have to create your own Docker Hub account. That is very important. Without that, it's not difficult. Creating a Docker Hub account is similar to creating a Facebook account. It's not that difficult and it's much easier than that. If you have a GitHub account, you can create your Docker Hub account using GitHub account within a one click, a single click. Okay. So now let me make it bigger and clear the screen. Docker, let me check, let us list out images. Docker images. You see, you have two images, welcome message and Ubuntu. We're not bothered about Ubuntu. We will only bother about welcome message. So I have to push this image to Docker Hub. Docker push and image name welcome message version tag 1. So let me click here. So the push refers to a repository docker dot. So denied requested access to the resource is denied. Why? There is a problem with this. So now what we are going to do is we're going to change the tag of this. Docker tag and welcome. And now I'm gonna say cube Charan and welcome message version 1. Now let's push it. I will explain it very clearly when you come to that exercise, but for now just tag itself does not exist. Okay, so let me check the Docker images. Okay, it's existed. So now what I'll do, Docker push, and it's a cube Charan and version 1. The push refers to the repository and preparing. Okay, before that we will Docker login username. That's what the issue. So you have to log into your system first, then only it's possible. Username is kubecharan and password so login succeeded. It's time to push. Preparing mounted from library Ubuntu, then digested. So let's get into the Docker hub of mine. Okay, click on kubecharan. Here it is. kubecharan welcome message and tag is v1. When did it push? It was pushed just a second ago, a few seconds ago. You see that? And now if I want to use this in some other place, I can just copy this and I can pull it into that, and I can do that. Okay, so now we have successfully pushed the image into the Docker hub also. So with this we have successfully completed our example 4. Okay, first Docker file has been written, built and run and pushed into the Docker hub, all done in one example. Now let's write our first Docker file in Windows machine, and we will execute using Docker desktop. Okay, in Windows based server using Docker desktop. This is example 5. So let me attach our, so let me copy this exactly, example 5, and paste it here. So this time it's example 5. So it is Windows machine and using Docker desktop. So same thing, process, create a Docker file, build a Docker image, spin the container and push the image into the Docker hub. So let's get into the action. So I will cat Docker file. I'll copy this code exactly. I don't want to waste your time writing the same thing again and again. I'll copy this. So now I'll get back to the, I'll open, where's that, Windows PowerShell, run as administrator and click OK. Clear the screen first and make it smaller. Okay, this is smaller. Yeah, this is fine. So let's Where are we now? It's not now. Let me close this. I will open in a specific directory where I want to run. Okay, I'll open a specific directory. Yeah, build image. So Docker. So here I am gonna create one directory. This is 3000 and welcome message example. Here I am gonna open Windows PowerShell. Open PowerShell window here. Yeah, now you got it. So let me clear the screen here first. Done. And let me do ls. Nothing is there inside the directory. Now I will create vim docker file. Okay, we will do it in another way, the most simplest way. It would be easy for you also, the Windows users. So I just want to make it in a most simplest way. Open with VS Code. So in this directory, create a Docker file. Yes, you see the symbol. Now let me paste it. Okay, maintainer got deprecated, so that's the reason. So anyway, it's not required. I will remove this. So now we will have only 3 steps. Save this. So now let me get into the same directory and hold shift button for Windows. For Windows, hold shift button and click on right mouse button and click on open PowerShell window here. Okay, it's been opened. So now let me do ls, and here you can find Docker file. You see that Docker file, and lost written all that information. We are not worried about that. Now let me say Docker. The file is ready. Now it's time to build. So Docker build, and in spite of giving the tag name separately, I will attach a tag directly. So I would say tag option T, and I'll say cube Charan and welcome Windows. Okay, and version 1 and dot is very important, and execute. Here it is, the action started. Here you can see the building timing, and from Docker this is the step 1 by 2. You see that it's built, the image is being built, and here you can see the timing. Of course, whatever we say, but however, Linux server is much faster than Windows when it comes to the operational activities. And 22.3 MB, so it's taking some time. Let's wait for action to be done. But by the time you look into this command, so Docker build option T, and then this is the name of the image, and dot. So dot means in this directory you have a folder. So use Docker. Okay, done, finished. So I say Docker images. You see that your image, cube Charan welcome Windows, and version 1 tag and image ID and the size. Now let us get into the Docker desktop and see. Here it is. There is no volumes, there is no containers, but you should see the image as cube Charan welcome Windows. This is the image, and now here we have a containers. There is no container. You can start this image, you can run this image from here by pressing this triangle or play symbol or play icon, or else you can say Docker run and option name I say this is welcome win container, and image name is cube Charan, welcome welcome Windows. So unable to find image. Okay, okay, got it. That's my mistake. So I gave a wrong tag. I did not give the tag. That's my mistake. Docker run option name. Mm, name I say welcome win container. Now image name should be cube charan / welcome. Let me check the name one more time. It's better to check one more time. Okay, copy to clipboard. Welcome Windows. Tag v1. Done. Welcome to the world of Docker from AH. You see that? It's been successfully printed. So we have written, we have built, we have spun. We have spun the container. And let's get into the Docker desktop and we'll see. And you see that welcome container exited. Now if you want to do it, if you want to run it again, you can click and you can run it. It's exited. So you go to the view details and you see the logs. The log is welcome to the world of Docker from AS Charan. You can run how many times you want. Okay. So now you have two options to push. Either you can do it from here saying docker push, or else the simplest way, the easiest way is doing come to the images section. Your image is there, then click on push to the hub and wait, relax, chill. It will do the rest of the work. You don't need to worry about anything. You don't need to worry about the login, configuration, nothing. It will do the rest. You just chill out. So here you can see V1 digest, and it's been digested into the Docker Hub. Now let's get into the Docker Hub and we'll check what's the condition. So let me click on kube charan repositories. Here it is, welcome Windows. Okay. So now you can clearly see that with this we are able to demonstrate this exercise using Dockerfile inside the Windows server using Docker desktop is done. Creating your own Docker file, building your own Docker image, spinning your own Docker container and pushing that into a Docker hub. So far we have seen a container that comes, that spins and prints a message on the console inside the logs, and it exits. So that kind of container we have spun using a Docker file that was hand written by us. We have written our own Docker file and it has come and it has printed a welcome message and it was exited. But now we are going to write a Docker file. So when you build an image, after that when you spin that container, this is going to run an application. When you access that application through browser, it is going to show a welcome page on your browser. I hope you're excited to work on this. So then join with me. Why are you waiting for that? What are you waiting for? So let me take the sticky note. And this is example welcome example 5 underscore 1 welcome app. So as usual, 3 stages. One, this we will be doing in Ubuntu server or Docker server. One, write a Docker file. Two, build a Docker image. Three, run or spin a container from the defined Docker image. And fourth, this bonus step, push it to the Docker hub. So let's begin our Docker file. Anyway, Ubuntu server remains same. So let's do our first step. So let me get into the server. Here is it, instances. Okay, it's timed out for what? Timed out for what? Let me cross check. Let me troubleshoot this. What had happened in between? So security, Docker security group, inbound rules. Okay, it's absolutely fine. It's not an issue. Okay, changed. Oh, that's the issue. This is the issue. I have reset it. Now let me do the SSH. Yeah, it's done. Sudo I and clear the screen. CD home Ubuntu and CD Docker examples. Yes, so in this Docker examples, so let's create a directory saying make mkdir space welcome app ls. Now let me do cd to welcome app. Yes, inside the welcome app nothing is there. So here in this we are going to write our Docker file, vim Docker file. So from, as usual, it starts with the from. I'm gonna use nginx and latest tag. And let me get to the sticky note. So that in this Docker file, the base image, we're going to take nginx service, and after that we are going to write we are going to develop our welcome app, and then place this welcome app inside the hosting directory. That's what the steps here. So before we write the remaining steps, we have to do the second step, that is developing our welcome app. So let me say vim index.html. So it's been opened. I have written that file. I am just copying that, insert and paste it here. So this is our welcome app, and do wq. So now check, you have Docker file and index.html both. So with this, our second step is also done in this. So nginx service is the base image, and we have our welcome app. Now we have to place this welcome app inside the hosting directory. So the hosting directory of nginx is, I'll tell you here, user share nginx. This is the hosting directory of nginx. This is where we have to place. Okay, and html. So this is where we are gonna place our index.html file. So this is our, so let me copy this. So my application, that is index.html, should be inside the hosting directory, exactly inside that. So this step I have to add it. Okay, so to do this, what I'm gonna do is, again I'll do vim docker file. So first step is absolutely fine. Then the second step is to copy the index.html file which is there in present working directory, and paste it to, and it should be pasted into / user share nginx html directory. So this is where it should be pasted, so that the application can be hosted in that container, and this application can be accessed through the browser. Okay, so now let me say wq save is been done. So with this, our docker file is ready. So let me mark this, docker file, creation of docker file is ready. So this is done. Now it's time to build a docker image with this. So I'll say docker and build option T. Then what's the name? I'll say cube charan / this is welcome app, and version 1 or tag 1. Tag is version v1. And where is the docker file? In the present working directory. So dot, let us build it. So sending build context to docker daemon, and from nginx latest, and it has pulled all the layers of nginx. Now the second, copy index.html from this present working directory into the hosting directory of nginx service, that is user share nginx html. So it's successful. You can see that successfully built, and this is the image id, and then successfully tagged, and this is the docker image name. So let me check docker. You can see that your kubecharan welcome app. So clear the screen. So the second step has also been done. If you want to inspect it, you can say docker inspect and then image name to check it. So then the third step is to run a container. So docker run name, I'm gonna give welcome app. That's it, welcome app. and detached mode and port. This is 80 is fine. I think 80 is running, 8080 is also running. So 9000 I'll give. 9000 map with 80 and image name cube. Unable to find. Oh, that's okay. That's my mistake. V1. Yes, it's been built. Now let me do the Docker exec. I just want to enter inside that and I will check whether it's properly copied or not. Docker exec it and it is welcome app and it's bin bash. Now we are inside that. You see that D3047 is the ID of container. We are inside the container. So ls, yeah, we are inside the root directory. So now let me get into the cd /user and / just a minute, share ls. You should find nginx. Yes, here you find nginx. Now let me do nginx. You should find html here and do cd html. You see that html and ls index.html. It's there. It's been copied. So now let's check the port. Okay, now it's 9000 is the one which we have mapped. So let me get into that. Okay, let me do docker ps. Okay, I'm inside the terminal. Let me exit first and docker ps welcome app here. This is welcome app. So 9000 port has been mapped with 80. So now let me get into the browser. So this is a browser. See, this is a browser and let me say 9000 here. That's it. Congrats. So this is our first welcome app after the welcome message. So the previous container was is just prints welcome message, but this gives an application and which displays welcome to the MLAC universe, the universe where you can learn everything about AI, everything about MLOps, everything about Python, everything about SQL, everything about everything. Just kidding. Okay, but this is my universe, a software universe, MLAC universe, AI universe. Okay, enough of fun. So let's get into the work. Okay, so we have successfully created, written a Docker file, built a Docker image, and then spun a Docker container from that Docker image. So, and we have successfully accessed that through a browser over internet. So now the final bonus task to be done is to push it to the Docker Hub. Yeah. So clear the screen. So Docker push and name sorry, that's my mistake. Kubectl welcome app version 1. Yep, it's going. It's going. Let's wait for that. as it's done. So let me get into the browser and I'll show you. So repositories, and let me refresh it. Here it is. KubeCharan welcome app. You see, and tag version 1 and click on this version 1 and you can clearly find Docker pull welcome version 1. With this, we have finished all the steps that we supposed to do in example 5.1 welcome app, and we have successfully demonstrated our first welcome application, and we have deployed it using a container. We have containerized an application, and then we have accessed that application which is inside the container through browser over internet. A big congratulations to everybody, whoever is watching this and practicing with me, and congrats. Now we are going to do manual deployment of static web application. So you may ask, why are you doing the manual deployment of a static web application in Docker module? Do you so so you may get the doubt. So the reason behind this is I want to show you the manual deployment, so that I can explain, I can show you the each step that we follow in deploying a static web application manually, and we will note down all the activities or steps that we have taken in deploying that application manually. Then same steps we will write it as a commands inside a Docker file, and we'll create a Docker file and we'll deploy that application. Got it? Got it? This is how I can prove that a Docker file is nothing but a set of instructions. That's it. It's that simple. You should not bog your mind with bloody different kind of definitions. You should not be worried, and you should not be gone mad with lot of definitions that are coming around from internet and all the social media apps and LinkedIn everywhere. If you see, there are a lot of definitions you will find. No, you should not care about those things. A Docker file is simply a set of instructions to do something. So that's what we're going to prove here. First, we'll do the manual deployment first. So let me open as usual our sticky note, and this is example 6 manual deployment. Done. We'll begin. First step in this is login, setting up EC2 instance or anything, setting up EC2 instance or provisioning any VM, whatever it may be. That is done. We have done it. We have our EC2 instance, and we have installed Ubuntu in this. Okay, we have our server ready. Okay, we have our virtual machine ready. So now the second step is to get your the next thing is to get your source code there. Okay, so here I'm gonna use a sample website that you also can download from Plate. So here we have to get the source code from the Plate. Okay, Now to download the template, what all tools are required? To download the source code from template website, what all tools are required? First thing is wget. So I will install wget first. To do this, I need a wget. So I will install wget tool, and then we'll get a zip file. To unzip that, I need unzip. Okay. So once you unzip, you will have all your source code in your server. Now the third step is to copy all the, and the third step is to, now to run this application, to expose this application as a uh, to the external world, you need some service. You need some service to serve this application to the external world. For that, we are going to use, as it is a Ubuntu, I am going to use an Ubuntu, and that to HTML CSS specific static web application, I will use Apache 2. So then I will install Apache 2 service. That's it. So our source code is ready and our service is also ready. Okay. So then what I will do is, I will copy all the source code and paste it into the var www html. So that's where we have to paste, that's where we have to paste our source code, that's where we have to deploy our source code, so that this can be exposed by the, this can be exposed to the external world by the Apache 2 service. So once you pasted it, now it's time to start our service, enable our service. So once you start and enable your service, the Apache 2 starts running, and once it starts running, then anybody can, external world with public IP of our instance, our server can access that. So the last step is to start and enable Apache 2 service. Okay, so let's do one by one. So let me check. Anyway, my EC2 instance is ready. I have done it before. Anyway, you also know. I will log into that instance directly. Okay. So with this, our first step is ready. And that too, mine is Ubuntu. So no issue at all. So now, second step. We have to get the source code from the template. Okay. For this, what I'm going to do is, I will get into the browser. Okay, I'll click here only, and www.template, go to the template, anything is fine. I'll go with yeah, anyone would be fine, the first one only. So now I have to download that. To download this, I need to get a URL. So for that, what I will do is, I will use a small hack. Okay, I will click on F12 and open DevTools. The DevTools has been opened. Now let me scroll this side and scroll up. Let me extend it and let me scroll up and click on download. And now let me scroll down to find the download up. See here, you can see that cleanwork.zip, and click on that file, and you go to the headers and you copy the URL. This is the request URL. You copy this request URL. Oh, wait. Exactly, copy this request URL. Okay, copy, done. So now the URL has been copied. So I will keep it here. Okay, so now our URL is ready, but to download that we need a tool, we need a utility, GNU utility. So how do you do that? So now I am gonna install our utilities. So it is apt update apt update is done. Now I have to install wget. Okay, I will install apt install wget option y. So wget has been installed successfully. Brilliant. Now let me clear the screen, and where I am in, okay, cd, it is in this thing, root. I will get into home, ls, ubuntu. Yeah, here I will open I'll create a directory mkdir and man deployment. That's a manual deployment, and cd man deployment. And here I'm gonna download the zipped file using wget. So wget, and come here and copy this link and paste it here. So it's downloading a clean work.zip. Let me check now. ls, you see that? So but what I want is, I want a source code in it. I want the code which is there inside it. How can I get it? You tell me, how can I get it? It's a zipped file. How can I open it? So then I need one more utility, that is unzip utility. Okay, to unzip that I need unzip utility. So I will install unzip utility now. Apt install unzip option y. So unzip is getting installed. It's done. So now let us unzip that ls, and it's there. So now let me unzip the directory. So unzip, and it's 2132, and click OK. That's it. It's been unzipped. Let me check ls. Let me do it. You see that this has been unzipped here. So now let me enter into that cd 2132. Okay, now ls, you have all the files here. That's it. So till now we have done 2 steps. We have successfully completed 2 steps. So getting the source code from the template and downloading it and unzipping it and entering into the unzipped source code directory. Both are done. So second step is done. So your source code is ready. So now what's left now? It's time to install Apache to service, the main important element. So I would say now again apt update, then apt, okay, let me clear the screen first. Apt install Apache to option y. Enter. So Apache 2 is being installed. So that means our service is being installed. You can see that installation of Apache 2 is successful. So our service is ready. So you have your, let me get to this. Yeah, you have your source code and you have your service installed. Now it's time to copy all the source code and paste it into the directory where it will host an application. This is called the hosting directory of Apache 2 service. Apache, every service will have a certain hosting directories. You have to place your application in that hosting directory only. So now I'm gonna paste my all the contents of the application in hosting directory. Okay, so ls, this is my directory. Inside that, this is my source code. I have about this html. Okay, contact.html, that is one page. Index.html, this is another page. And whatever images that will be shown uh, on the interface, all are placed here. And styling templates are here. And these are other templates: about.html, coming soon.html, and services.html, all. Okay, and a bit of javascript. So this is the complete source code of our application. Now this should be placed in the hosting directory of the service. Now let me check what is there inside the hosting directory at this moment. So cd var dub. You see that html. So let's get into that also. Cd html. So this is our hosting directory of the Apache 2 service. What is there in that? You have a default index.html. Let's cat it and see what's there. So default index.html has some page. So anyway, it has a default index.html. So that's the reason what we will do is we will take the public IP of our server, and we will open it in a browser, and we'll see what we're gonna get. Instance is here. So let me take the public IP and copy here and enter. Yes, this is Apache 2 Ubuntu default page. It's default page. Okay, it's not the actual it's a default page, but whichever application you want to host, you should place it in that location, then only it can be hosted. Okay, so now I'll do a little bit of modifications to this default page, and we'll change. So vim and index.html. So it started from here. This is the head, meta, style, Apache 2, body. Okay, this is css. There is a lot of css. That's brilliant. Then let's come to the body. The css tags are placed in this is in place css. Yeah, here the body has come. So let me, so this is Apache default page, correct? Apache 2 Ubuntu default page, and it works. I will type. Yes, it is working. This is the default welcome page used to test the correct. Yeah, rest all I'll keep same. Yeah, rest all let it be same. I just want to do some modification. I just want to show it. That's it. Nothing else. Or else we will add a heading also. We will add our heading. So here what I'm going to do is, yeah, welcome to the manual deployment with Sharon. So now let me close this, save it and quit it. So now let's get into our browser and see. Let's refresh it. Yes, it's working. The name has been missed. Let me check what's the mistake there. Okay, vim.index. Okay, that's okay. Welcome to the imlike. That's it. You see that? Welcome to the imlike my YouTube channel, and it's working. So this is a default page. Now exactly in this directory, where is that? Yeah, exactly in this directory I have to replace this content with the my content. So my content, where it is, cd home Ubuntu and mandip. Okay, what's wrong, man? What's wrong? Q exclamation mark. Okay, you get lost from me. Oh, okay. Okay. cd home Ubuntu mandep ls here and 2132. So this is my content. This is my source code. Now I have to place this source code into host directory, the hosting directory of the Apache 2 service. So now what I'm gonna do is I will say copy and option R recursively everything from this present working directory to /var dub html. Yes, now let me get into the var dub html and ls. You see, all the source code has been copied here. So this step is also done. So copying all the source code and paste it into the hosting directory of Apache 2 service is done. So now what left? Now it's time to start and enable the Apache 2 server. By default, after installation, it will get started and enabled, but just as a safety purpose, so we just want to make sure it is started and running. So that's the reason we will give the command. So system ctl start Apache 2 service. So then system ctl enable Apache 2 service. See, it's been enabled properly, because now we have put our customized application. Now we should be very careful. We should make sure that the service is started and enabled. So now let me cross check systemctl status and Apache 2. You see that it's active and it's running. Now no problem at all. Now let's get into the browser and see what magic is going to happen. Tin, 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 ting. Okay, you see that a website has been hosted. See that? Like it? Do you like it? It's good one. Yeah, it's nice website. So we have manually deployed an application and hosted that web application in our Ubuntu server using Apache 2 service. It's successful. So let me cross this also. Yes. So you can see that. I will refresh it one more time, but still it. And with public IP, you can give this public IP to anybody if it is elastic IP. If it is elastic IP, if it is elastic public IP, you can give it to anybody, and anybody can access your application that you have deployed in your server. So this is how manual deployment works. So this is in Ubuntu. Now if you want to do a similar kind of deployment in CentOS, how will you do that? I will show you. To do the similar kind of deployment in CentOS, so this is what. The first step is setting up either Vagrant machine if it is in your personal computer, or take the EC2 instance, or any other cloud provider's virtual machine, and then go for CentOS 7 AMI if it is EC2 instance. Then first step, similar, install wget and then unzip. But this time, as it is a CentOS, for CentOS we are using YUM. That's the package management tool. That's the package management tool or repository. So that's the reason we can't use Apache 2. So Apache 2 won't be there in YUM package repository. You will find only HTTPD. So if you want to host a web application inside the CentOS server, you have only one option, that is HTTPD. Apache 2 doesn't work. Similarly, HTTPD doesn't work for Ubuntu. For Ubuntu, it is for Ubuntu it is yes for Ubuntu it is what? For Ubuntu it is Apache 2. For CentOS it is HTTPD service that we use to host a web application. So now after that installation of wget, because we have to uh, download the source code and then unzip it so that we can access the source code and we can look into the source code and we'll find the source code. Then we will install the HTTPD. This is what the service, it hosts our application. Then this is the process of downloading, then unzipping this thing, then copy everything from here and paste it in the hosting directory or host directory. You see that hosting directory, and once you host it, then it's time to start your HTTPD service and enable the HTTPD service and take your public IP and with port 80 and put it in the browser, and you should be able to see your application should be running up and running. So the procedure remains same, but the package management tool changes. So I hope you got how to do the manual deployment in CentOS also. So with this we have done manual deployment of web application in CentOS as well as Ubuntu. So the agenda for this, the motive to do this is to see the manual steps what we have done. So we have, let me summarize that. This is what we have done: setting up the EC2 instance, or setting up the server first, provisioning a server, that's Ubuntu. Then we have to get the source code from the toolkit. For that we need wget and unzip and a URL. Then after that you need to install Apache 2, then copy all the source code from your directory, unzipped directory, to the hosting directory. That's where html, and finally start and enable Apache 2 service. That's it. Your application will be up and running. So these are the manual steps. Now in our next example we are gonna do the same thing using Docker. More fun and excitement is loading. Whoever is excited for the more fun, I I welcome them one more time. Welcome to the world of fun and excitement. Okay, so now let's do a most fun and excited, uh, fantastic and excited uh, exercise or example. So now for the same static website that we have deployed manually, we are gonna deploy it using Docker file. So what we are gonna do is we will write write it. this is example 7 and deployment using Docker container, and 3 steps. Step 1, writing a Docker file. Step 2, building a Docker image from the Docker file. And third step, running or spinning a container defined by the Docker file, Docker image. And the last step here is, that's an additional one, or augmented step, that is pushing to the Docker hub. So these are the 4 steps we're gonna do. So now it's time to write our Docker file. So, but before that, you should go through the activities that we have done, the steps that we have followed to deploy the same web application in manually inside the manual deployment example. You see that here? So now, so let's write our Docker file. So, but before writing a Docker file, so we will do this activities as usual. So these 2 steps, the initial 2 steps remain same. So setting up EC2 instance or provisioning a VM and getting the source code. So till that it remains same, we'll keep the same, and then from here we will build a Docker file. So let's get into the EC2 instance first. So the first step is done. EC2 instance with the Ubuntu, we call it as a Docker server, and the second step is to fetch or download the source code. Okay, for that we will get into, so let me, okay, it's gone. Clear the screen. Okay, it'll become a sudo I. Clear the screen. Root user. Let me get into the home and Ubuntu. Yes, ls. Here I will create mkdir, and this is Docker web Docker. Okay, and cd web Docker. So inside you see nothing is there, completely empty. So now let me get into the sticky note. So the first step is done. The second step is to fetch the source code from the two-plate. For that, what we require, we need to download that. For that, we need wget, and we need to unzip that. For that, we need unzip. So these 2 steps presently at this moment, it's manual step only. Let's do it manually. Then after that, we can make it completely automated. But for now, it's manual. So let me do apt update and apt install wget unzip at a time, single command. I just want to do a single stretch. So that's it. Installation has been done. Now wget, and so let's copy the same link, and we'll fetch the zip file from two-plate. Copy it. I will paste it here. That's okay. Where I am, ls pwd Yeah, wget and paste URL. Okay, it's not copied properly. Copy, clear the screen, wget, paste it, enter. ls. So now it's time to unzip it. So to unzip, I'll say unzip and 2132. So let me check ls. It's been unzipped. So now what we have to do is we have to package it into tarball. So why we are doing this packaging into tarball? Because after that we will do the similar activity inside the container. So we will provide a tarball in spite of, see, we are downloading the .zip file, but so installing a zip unzipping a zipped file inside the container is pretty difficult. So that's the reason we will make a tarball and then we will give a tarball to the container. So container will unzip it, container will untar it, and it will place it uh, inside the hosting directory. So that's the main motivation, main agenda here. So let me, after unzipping, so let me enter into that 2132 ls. You see all the files. Now let me do tar czf, tar czf. The name I'm gonna give is clean work tgz, and let me click OK. What's wrong? Okay, we are missing something. That is this. Yes, we need to give the files. We forgot to attach that files. Okay, now I'm entering. So now let me check ls. You see that here the clean work.tgz. So it's been created. Our tar file, a tar ball has been created. So with this, our all manual steps has been completed. The final step what we are going to do is we will move this tar ball into clean to the, okay, we'll keep it here only. No, we'll move it outside. See, congrats. Or we'll copy it clean to, yeah, you see, you got the tar ball now. So exactly in this directory we are going to create our Docker file. So the first two steps are successful. These are manual steps only. Now the actual steps are begun. Yeah. So now let's write our Docker file first. So vim capital D Docker file. Yes. Now let's discuss the activity. What are the activities we have done it manually? So let me put this here. Now let's go through it one by one. So this is the manual deployment. The first step of manual deployment is to setting up an EC2 instance or provisioning a virtual machine. Okay. So we have used Ubuntu AMI for EC2 instance. So here also the first step for us to have a basic image, which could be a Ubuntu or CentOS, whatever it may be. So here I am going to take Ubuntu, the basic image, Ubuntu. Inside that Ubuntu machine, inside that Ubuntu instance or inside that Ubuntu virtual machine, I'm gonna deploy my project, deploy my web application. So that's the reason I'll give from, and it's Ubuntu tag is latest. Done. So then it's not necessary. If you want to attach a label, it's fine, or else it's not required. Still we will attach the labels. Project, this is AI project. Okay, done. Then environment env. So Debian front end, whether you want interactive or non-interactive. Here in this case, I want non-interactive. Everything should happen behind the screen. So nothing should be printed on the screen. So for that, I need to take an environment variable. So that's the reason I have mentioned env. So Debian front end. This should be non-interactive. So as per the manual deployment, the first step is to setting up a EC2 instance or provisioning a VM and install Ubuntu or CentOS. So the first step has been done with that. You see Ubuntu. So the first step has been done. So now let's move into the second step. So what is second step and third step for us here? So second step and third step for us here is to download the source code and then unzip it and install the service Apache 2. Okay, so but here in manual deployment we got it .zip, but here we have tarball. So we have a tar package. So now we have to, the next step for us is to install Apache 2, that's the service, and after that we have to copy the tarball and then place it inside the container and untar it, and then copy it, the source code inside the untarred directory, and place it in the hosted directory, and start and enable the Apache 2. That's it. If that is done, so these activities we have to convert into commands in the Ubuntu, in the Docker file. Let's see. So the next step for us to install Apache 2 service. So for that I will say run is the command that we use to run some commands, some Linux commands in Docker container. So run and apt update first. So before we install any tool, we will update. So that's the reason we will update first, and then double ampersand. So you after that update, you execute apt install Apache 2, then as well as git wget and y. So git and wget are not required at this moment, but still we have installed it. Okay, wget is done. So now this is done. So let us get into the activity list. So installation of Apache 2 step is done. We have attached that also. Now what's next? Now it's time to copy the tarball. Okay, source code, we require source code, correct? Copy the tarball. It is in at present directory, present working directory pwd. So I'll say asterisk, or it's better to use let's see, we'll use asterisk, all in the present directory, and then copy to var www html. So here it's going to copy our tarball from present working directory where this Docker file is there, and it will place it into var www html of the container, not ours, not in the Docker server. It will place it in the containers directory. Okay, containers hosting directory. Then So once this is done, now it's time, as we are copying the tarball, now we have to untar the tarball. So for that we have to enter inside that directory, run cd, enter into the var dub, that's a hosting directory, html. And once you enter inside that, what you have to do next you have to untar it, tar xzf. And what's the file name? File name is clean, okay, clean work dot tgz. I hope we'll cross check it. Then once you untar it, your source code is exposed. Now it's all done. Till this step it's all done. So this is done, and copying the source code to hosting directory is also done. What's left now? Now it's time to start your Apache 2 service. It's time to enable the Apache 2 service. For that I will use cmd. What is cmd? Cmd means whatever you mention, whatever commands that you give in cmd, that will be executed when you spin a container, when you run a container. So now what I want to execute when my container is getting started, that time I want to start Apache 2. So that's what I'm going to give here. I'm going to start my Apache 2 service. User bin, has been an Apache 2 CTL. So you go there, you will find this Apache 2 CTL binary, and then you pick it up, then use capital D option, and then run this on foreground there inside the container. That's it. So now it's all up to you to add volume or not. So I will add a volume. Volume is again where these are additional. These are all additional, so I don't add additional things. So work there, we'll set up work there. This is anywhere required. Work there is common. So where dub html. This is our working directory. Okay. As soon as you log into the container, this is where you will enter. As soon as you enter inside the container terminal, the directory will be here. This directory you will be entered. So then we will expose this to port number 80. This is container port 80. With this, our Docker file is absolutely ready, but let us cross check one more time all the activities. So activity 1, our Ubuntu machine. Then after that, we need to install Apache 2 service. Then we need a tarball, source code tarball. So we got it, and we have to untar the tarball. So we have untarred it. Once your source code is exposed to the hosting directory, now it's time to start and enable our Apache 2 service, and that's been done. And finally we want to expose this application inside the container at port number 80. This is container port number 80, and this application will be this service, this Apache 2 service will be running at port number 80 of container. Okay, let's get here. Let's get into here. So writing a Docker file is done. So what's left next? Now it's time to build a Docker image from the Docker file. So before that, let me check the name of the wq ls. Here it is, our Docker file. So name cleanwork.tgz. I hope it's correct. Yeah. So our Docker file is ready. So now let's build our Docker image. For that, I should be in the same directory where my Docker file presented. So let me do ls. You see here. So now I will build image. Docker build option T to provide tag. So I will tag it as a cube charan, and this is clean work and version 1 and space. Where is the Docker file? Inside this directory. So that's why I'll say dot, and let's enter. Let's click enter. App does not have a stable CLI interface. Use with caution. That's okay. 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 That's fine. We have built a Docker file from scratch. Now it's done. When using copy with more than one source file, the destination must be a directory and with, oh sorry, Docker images. Let's see whether it's been created or not. There is some issue. Yeah, it got created, but we have to delete that. It won't work. Docker RMI. Okay, I have deleted the wrong one. So Docker RMI cube. Okay, clear. So now let me give them Docker file. Open. So what's wrong? Where is that? Yeah, here. So forward slash, that will become a root directory. Yeah. So let's build it. This time it's successful. You can see that successfully built and successfully tagged. So let's cross check. Okay, this has been image has been built, but before that I just want to cross check the let me click on, yeah, step 2 building a Docker image from Docker file is also done, but let me cross check. Docker exec it and the name, no, Docker inspect cube. Yeah, last thing, time layers. Okay, fine, directory, your Linux size virtual. Okay, foreground var www html. So let me check. Now let's run Docker run name. This is clean work app, and detached mode and port 8080 it's running. I think 8080 is running. One application is running at 80. So now I'm gonna give 8080 mapped with 80 of the container port, and image name is cube charan. What's the image name? Yeah, user has been Apache 2. Okay, it's been executed. And here, let me cross check that. Image name, kubecharan clean work tag 1. Clean work tag 1. Clean work v1. So user has been Apache 2 CTL, no such file or directory. Okay, got it. One more mistake. For that I have to create again. I have to stop that image. I have to remove the image. Docker RMI, or else we'll leave it like that and we'll create version 2 of it. So vim docker file open I. So here is the mistake. WQ and let's run docker build. This time it is version 2. Yeah, successfully built. Now we'll run the container version 2 and yeah, container clean work container 1. Yes, now it's successfully built without any problem. So let me, before we uh, go to the browser and check, let me say docker ps. Yes, it's 8080 at this port it's running, and user has been Apache 2. Okay, that's fine, but let me do docker exec. I just want to confirm one thing. So container name is clean work 1, correct? Then bin bash. Yeah, see, we have landed up in var dub html because that's what the working directory we have given. Yes. Now let me do ls. Yes. Okay. It's been correctly untarred. You can see all the files. No problem. So now let me directly get into the. So let me copy the same browse same public IP and uh, paste it here. This time it is 8080. Just a minute. That's it. That's it. Okay. At the both places. So you see the public IP, but this is port number 8080 default one. This is port number 80 default one. This is port number 8080. So at this port application is running without container, but here the containerized application is running from the same server at port number 80. Let me refresh it. You see that it's running. Let me refresh it one more time. See, this is at 80. This is the application that we have deployed manually. It is an application, and this is containerized application. Containerized application is running at 8080, and a normal application which is deployed inside the uh, server, Docker server, is running at 80 port. You can see that magic. Both are running. So we have built it. We have built. So now let me check mark this. So running and spinning a container, spinning a container defined by the Docker image is also done. So we have created a Docker file from scratch. We have built the Docker image, then we have spun the Docker image, and we have spun the container. You can see that it looks good. It's all fun. I enjoy it. You see, both are working, and this is containerized application working from the same server. See, office cleaning. Let me get back to the home. Click on kitchen cleaning. You see, kitchen cleaning template. Let me get back to the home or click pages. Our service coming soon page. So click on coming soon. You see that? Everything. So hence proved. So hence proved that a Docker file is nothing but a set of instructions that we do manually. So the set of activities or steps that we do manually, we have to convert that into commands and give it to the Docker file. That's it. That's what the Docker file in the simplest way. The most rudimentary way of explanation is this. And I have proven it also. Okay. So these activities, we have all these activities, we have converted it to, and we have proven it. So now the bonus step, pushing this to Docker Hub, that also will do. So let me get into the, yeah, ls. So now, okay, sorry, I'm inside the container now. I have to exit from the container. You see that? I have told you, if I put a working dir as this, when I enter inside the container, when I log into the container, it will, I will land up there. I will be landed up in this hosting directory. Yes, it is. Yes. See, and all the files has been pasted into the hosting directory, and we could see the application hosted in this container. Okay. So in a simplistic way, a container is a miniature virtual machine. It's not, don't take it exactly. Yeah. So it's a miniature, container is a miniature virtual machine or instance. Okay. Consider it like that only, because you can see that. You see, same. You have everything, a root user, and you have host machine, host name, then you have directories, and inside that we have installed the service, we have run the service, we have started the service, we have enabled the service, we have copied the file source code, and we have moved the source code, we have entered the source code. What is there? What is that? It's nothing but a miniature virtual machine, a lightweight virtual machine. Okay, consider it as a lightweight virtual machine. Whatever is required for our application, so that only will be presented in that. Okay, this is the simplest way of explaining. Okay, so now let me exit from the container. Now I came out of the container. So now let me do Docker push. Okay, let's check the images first. We have version 2 is working properly. Version 1 we have some issue. So that's the reason I will remove the version 1. It's not required. Cube version 1. Now Docker image. Okay, one container is running with the Docker version 1. Okay, I have to remove that first. Docker ps option A. What is that? Where, clean work, this one. So Docker ps Docker rm clean work. Now I can remove Docker rmi cube version 1. Yes, done. So Docker images. Now I am gonna push this image into my directory, my GitHub, my Docker Hub account. docker push cleanwork version 2. Let's push it. Preparing all the layers have been being pushed. You see, layer wise, it's pushing layer wise. Oh, okay, it's mounted from this. Okay, I pushed this image and it's giving something. Okay, it has pushed something else. I gave this cube and clean work, but it had pushed this. Okay, let me cross check this repository, refresh it. Yeah, got it. You see here, clean work. See that? So hence we have proven what is a Docker file. Okay, now just for fun, we are going to do one more activity. What is that? So now I will use this image so that I have just created and I have pushed it into the Docker hub. I will copy this. Okay. No, this is tag. So I'll click on this tags. Yeah, I'll copy this one. Yeah, full command has been copied. Now I will get into the Windows machine, clear the screen. So here, okay, I'll open Windows PowerShell, Windows PowerShell run as administrator. Yeah, clear the screen, and I'm gonna pull that image from Docker Hub and I run the same image. You can see the power of Docker images. Okay, I have written from scratch, built it, and I have pushed it into the Docker Hub. Now I will pull that and we'll see what's gonna happen. Let me click enter. Okay, it's pulling the layers one by one. Oh, this is too much. It will take a lot of time. Okay, finally it's done. So let's get into the Docker Hub and let's check the image. You see that it's cube Charan clean work. It's unused till now. So let me check here also Docker images and cube Charan. So now let me run it from here, from Docker. I'll run it from here only because we have run it from there last time. Run optional settings, host port, that's okay, 80. The rest let it be. Okay, that's fine. Apache 2 could not reliably determine the server fully qualified domain name. That's the problem with the server because it's a Windows. For this Windows, you need a Windows machine. That's okay. But you should got the logic. What I'm trying to prove here. So what I'm trying to prove here is once the image is built, it can be used by anybody. Anybody means literally anybody who has the access to that. let's have more fun with Docker. So this time we are going to containerize a scheduler app which is written by me, and that app we will containerize it and we will deploy that into Ubuntu server using node service, and this is our example 8. Okay, and the steps that we are going to follow is, I'm going to write here example 8 containerizing scheduler app. Okay, so now so what are the steps here? So first, step 1, get the source code to create a GitHub repository okay, and get the source code. Third, connect a remote repo with the local repo where source code is present. And fourth, write a Docker file in our local machine using VS Code in 5 and push this to remote repo. Then 5, clone the remote repo into the Docker server or Ubuntu server. For that we have to install git. Then after cloning, so build the Docker image, and 7, run the Docker image, run or spin the Docker container defined by the Docker image. This is what we are going to do here. So let me begin by creating a GitHub repository. For that, yeah, here is my GitHub repository. Now let me click on new. So I'm going to create new repository saying Docker scheduler app deployment. Make it public, add a readme file, create a repository, and copy this. So now the first step has been done. So let me mark this one. Underline this. It's done. Then let's get into the source code. So my source code is here. So here I'm gonna open our okay, or else what will I'll just open Visual Studio Code, new window. So clone a repository first, clone a repository, clone a repository, a remote repository. What is that? That's Docker scheduler app deployment. Let me cross check it. Yeah, Docker scheduler app deployment, correct. Click on it, and I have to find the destination, so I'm gonna give the destination now. So here it is, like projects Docker, and it is scheduler. Yeah, so this is what. So now it's getting cloned. Keep it in the same window. Open it. Yes. Close the get started. Now let me get into that repository once and place all these things in the specific. So now, yeah, so this is our source code repository. So before I add this, okay, let us first add these new changes. 41 changes are there. Let me click on add. So it's been added. Now add all the source code files and commit. So say sync changes. Now let's get into the, yeah, still it's syncing the changes, or basically we can say it's pushing the changes into the remote repository. It's done. The changes has been pushed into the remote repository. It's done. You can see the source code and package.json and all the other stuff. So let me get back to this and click on files explorer. Now here you have package.json. So let me put either scheduler or just normal app is also fine. I'll say app 101 license and dependencies, all dependencies related to that here. So everything, it's completely package.json. Then we have source. Here you have index.js. So this is main JavaScript. You can see that app.get is one we are using, post, put, delete. So these are to add items and get items, update items and delete items. This is the main purpose of this application. So we'll show that. So this is the backend. JavaScript is backend for us now at this moment. So this is gonna do this, and front end I am gonna show. This is index.html. This is our front end. This is a front end of our application, and you will find cs styles.css. This is a friend. This is a styling template. This is our styling templates, and inside that you can see the rules. Here you have seen the classes and tags, and here you could see the style rules. So this is our static front end, and then back end both, and this is index.js is the main one, and this is static. And here you could find routes. Add item, to add item it's gonna use this. To delete an item, get item. So these are all routes. And a persistent, to make the persistent data persistent, you need a databases. So we have taken SQLite database. This is SQLite database schema. Then this is MySQL. You see that MySQL constants, MySQL host file, MySQL user, and MySQL password file DB. So these are all environment variables or constants. And so here it started, and this is MySQL schema. And index.js, if else the connections between if process.env is MySQL host, then module.exports require a MySQL database, or else if it is module.exports then you require a SQLite. So this is how you switch from one databases to other databases, and this is how you connect your front end. We have till now we have seen static web pages, we haven't seen an application. We have seen a static websites. So this is called an application. So specific application, it's a dynamic application. You can input the data and that data will be stored in your databases. For that it's written a schema has been written to make your data persistent. Okay, you have seen this is how an application, a dynamic application is built. You will have a front end, you see that front end, and a back end, main template, and then routes and persistence, that the databases to store the data. You could see all three modules. This is called a dynamic application. And you will have a package.json which handles which connects all together. That's called npm. Here we have used an npm node related package manager, and it connects all together. They have dependencies, Protea, and dependencies MySQL, SQLite, UID, all those things. So let me save this. So now, yeah, here I'm gonna write a Docker file. That is our Docker file. Yeah, you can see the symbol, Docker file symbol. So let's begin now. We'll begin with from, and from. So which base image you want to take? Node base image with 18 alpine tag. Okay, done. So our base image is done. That means, so node, because we are using npm uh, to package everything, so the package .json, so npm we are using, so we have taken from node. Then after that, label project AI tech project. So label is done. Now let's set work directory. You know work directory. So the work directory I'm gonna give is / just app. This is going to be our work directory inside the container. Then copy, nothing, dot space dot. So whatever is there inside this present working directory should be copied into the work directory that is mentioned inside the container. What is the work directory? / app is the work directory, and whatever is there in this directory, present working directory, should be copied into the / app. That's what we are telling. That's what activity is going to happen there. Then, so now let's run some shell commands. Run, and anyway we have arn.lock. So arn and install. What do you want to install here? I want to arn install production. Done. So our almost image level instructions are done. Now it's time to give cmd. So you see that cmd, it's an executable. Once you spin your container, whatever you mention inside the cmd will be executed. So what all are there for us? Node, because node, you see that your node, and it will be running node and space and src / index.js. That's it. You node will come into the picture and it will find the src inside the src directory. You see that? I'll show you. You see, you go there. So src, you will find index.js. So it's saying node will come into the picture and it will execute this one, or it will execute this file. So then whatever is there in this file and whatever is connected with this file, so when you run a dynamic web application, so index.js is very important because all will be connected with this. All will, you see that? For example, constant to get items, you require this. So in this directory you will find a routes directory. In that the get item is written. I will go there and I'll show you. You see that get item.js. So when this way all will be attached to this index.js. Everything app.get. So again / items and you will get items and all will be attached to this. So that's how it works. So index.js is the main file and all so how it will be connected to the database through routes, and routes will be attached to the persistence database. That's how it works. So for us index.js is very important. Okay, and here you can see initialization of db. So app.listen when app starts and db should be initialized. So let's get into the Docker file. So that's what we are saying. So we will give this command node command space and source index.js. That's what, execute this. And finally let's expose this to port 3000. That's it. Our Docker file is ready. So let me mark these things. Get the source code is done. Connect the remote repo with the source code is also done, and write the Docker file in the local machine using VS Code is done. Now it's time to push this to remote repo. Let me save this and click on source control. Two pending changes are there. So you see two pending changes are there. So let me click on stage all changes, add these changes to staging area, and these changes has been added to the staging area. Now let me give committing Docker file and commit. So sync changes. Yes, it's done. Now let me get into our repository. Here it is. This is your Docker file. You see? So now let me go one step back. Now this step is also done. So underline this. Now it's time to clone the remote repo in the Docker server or Ubuntu server. Okay. So but before that we have to install GitHub. So let me go there. Okay, it's gone. Sudo I and clear. So let me install app. Let's check whether we have git or not. Yeah, git is there. We don't need to install. So now let me clone this. Git clone and take the http URL, https clone URL. No, but I'll find a place first. Home, Ubuntu, and Docker exercise examples. Here you have welcome app. So let me create one more directory. Make there. So web application. Web application. So cd web application ls. So here I am gonna clone it. Git clone and URL of this. Yes. Now let me click enter. So cloning into Docker scheduler app deployment. So it's done. So now let me see Docker scheduler app deployment. So now let me enter into that. So clear the screen and ls lrt. You see that src spec package.json readme.md is not important for us. Docker file iron.lock. So all the required files are there. We have source code and we have everything. So we have done this step also. Now it's time to build the Docker. So but before we build the Docker, let's cross check whether we have cloned all the required source code or not. So let me quickly look into ls src. Okay, index.js, this is main very important file. It is there. And persistence databases routes which connects index.js with the persistence, and static which gives front end, basically user interface and styling. Okay, and this is what our main file, so it's there, so we don't need to worry. So rest all it's fine. So let's do cat docker file one more time and let's check. So label project AI check, Alpine work there, copy. So everything is fine, I guess. Nothing to worry. Copy from this directory. So all these files, copy all these files from this directory and paste it into this directory, that / app in the container. Okay. So now it's time to build the image. ls, you see Docker is in the same directory, so now I'm gonna run docker build option t, that says you can tag. So option t, after that I have to give tag the image. So the name I'm gonna give is cube charan / this is scheduler scheduler yeah, scheduler is enough, and version 1. Yeah, it's fine, nah? Scheduler. So scheduler is fine, version 1. And where is docker file is in this present working directory. So I will say dot, then enter. So it's started building. So step 1/7 is from node. It's gonna pull this node. So it's pulling all the layers of node. Then the second step is labeling the project, and third step is work their app. That's also said. Then copying all the files which are in present working directory into the / app directory of the container. Okay, then command, this is just copied like that, it's not been executed. So expose it to the 3000. So finally successfully the image has been built with this image id, and it's successfully tagged with this image name. So let me check docker images, and you see that scheduler, this is what, just 28 seconds ago our scheduler is ready. So now let us clear the screen and let's give me the let me give you the status. So building the docker image is also done. So now it's time to run the docker container defined by the docker image. So docker run name, then name of the container is scheduler 1, that's version 1, this is 1. And detached mode port, okay, last time we give 80 and 80. So 7,000 I'll give this time, or 3,000. We'll map 3,000 of host with 3,000 of container. Then image name is cube charan / scheduler and version 1. Okay, scheduler. Yeah, let's see. Yes, it's done. So docker ps, let's check. You see, cube charan scheduler v1, that's the image name. And where is the name of the container? I couldn't. Yeah, here, the scheduler 1, this is the name of the container. 3000 is mapped with the 3000. Let me cross check whether the application has been properly copied or not. So to do that, I had to use docker exec it, that is interactive with terminal. Then name of the container is scheduler 1 and bin bash. There is something wrong. Okay, this is nginx, no bin bash, so then I have to give sh. Okay, see, work dir we have mentioned. Let me show it parallelly, so then you will get more clarity. And where is my, yeah, let me make it other off, then close this one. Okay, now you see, work dir, this is our work dir, this is our work dir /app. So where did we land up? We landed in the /app. That's what I'm saying. When you enter inside your container terminal, it will lead you to the /app in the same directory what you have mentioned in the workdir command. Okay, so then let's check the ls. Oh, congrats. Docker file spec readme.md src node modules lock pack.json, everything has been copied, no issue at all. Okay, so as src is there, means obviously it's gonna run index.js. So I'm pretty confident now. So now let us get into the browser and take the public ip of this and use 9000. So this is one container which is running continuously that we have deployed it. So I will put 3000 and see what's gonna happen. See the magic. Here it is. Here it is. I hope you like this. I designed it well. Did you do you like it? Okay. Uh, don't look into the user interface. Just okay. I hope you like the user interface also. This is the scheduler app that I have built. Uh, of course, I have used some boilerplate templates of HTTP and HTML and CSS Java, but that's okay. But the main functionality of this application is scheduler. Okay, so this is my this is my website, and a very simple way to create and schedule your task. So now I will add. So today now I'm working on Docker. So now next item is to work on Kubernetes. So Kubernetes, next is Kubernetes or K8s. So K8s is next item. So let me add this item. So K8s had been added. Now after the K8s, Postman has been added. Now after the Postman, I have to work on SonarQube. SonarQube for the static code analysis. So this is how you add your items, and whenever you want, You can come and you can cross check if this is done. You just mark it done, mark it done, mark it. So as it is done, you can delete it or you don't need to delete it. So I will unmark this now. At this moment it's not required. So whatever has so far has been done, that I will mark it. So done Linux is done, I'll mark it. And DevOps fundamentals, DevOps basics, done, I will mark it. And Git is done, I will mark that too. And after Git, we have worked on networking. That's also done. So let me mark networking also. Then after networking, we moved to Maven, Jenkins, Packer, Terraform, Ansible, and few other tools. Vagrant, of course, we did not use Vagrant here, but I will I'll do one or two videos on Vagrant also, because that is also useful. But it's creating a virtual machines. I don't think it is much useful. But if somebody wants to know Vagrant, I will make one or two videos. It's not that difficult. It's very easy. So Vagrant is done. Vagrant. Okay, this I'll remove it. This we will do it later. Ansible is done. Terraform is done. Packer is done. Jenkins. Okay, spelling is wrong. That's okay. Maven is done. Networking, Git, DevOps basic, Linux, and even Agile and waterfalls and SDLC. So all these topics are done. So as this is a scheduler app, na? This is as a to-do scheduler app. So that's the reason. So now let me write what all to be done now. So kh postman sonacube jap or Zapier and Zapier, kh postman sonacube and mega projects. That's it. These 5 items to be completed. So rest all done. Oh, we have completed so many tools. It's a big DevOps tool stack. I hope you are liking it. Anyway, so this is our scheduler app. This consists of a database and all will be stored, and you can see that it's an application. It's a dynamic application. Of course, we have attached some static content also, just for the visual appeal. Okay, I hope you really liked it. So now let us get back to our running Docker container is also done, and we have accessed the containerized application through browser over internet and validated the functioning of the scheduler app or scheduler or to do app. Okay, this is also done. So now it's time to get into our server once again, and let's check sudo option I clear and docker ps where is that? Scheduler 1 is fantastically running, and oh, at this moment, three applications are running in this. Okay, one is clean work 1, which is containerized application. Okay, clean 1 8080 9000 3000. So total three applications are running. Okay, let's check it now. One is 9000, other one is 8080. So this one is 9000. Yes, it's working. So let me copy this and put it in another browser. Basically, that's the magic of a container Docker. Yeah, brilliant. From one server, three applications are brilliantly running. You see that? One, two, three. Superb. So let's get back to the server again. Now let me give Docker images. Oh, huge amount of images are there. But this is the latest one, na? V1. So now the last step or bonus step after building the image, after running the image, what is the bonus step? It is to push the image to Docker Hub. Let's do that. Docker push image name kubectl scheduler version 1 and click enter. So preparing, waiting, and it's pushing. I think it might take some time. Let's wait for that. Yes, it's done. You can see the digest. So it's been digested into a Docker Hub. So let me get into the Docker Hub. Here it is. Here is the Docker Hub. Let me refresh it and we should be able to see that. Yes, that's it. Here is the image. Anybody, even you or somebody else, anybody can pull this image and then just by running you can deploy one application. See the magic, man. See the power of Docker. I have built it, I have set it everything, source code and everything. What you have to do is you just pull the image or you just simply run this image from your server. That's it. It's gonna deployed. It's going to be deployed into the server and then you can access that application through your browser over the internet. That's the power of Docker. That's how it makes our life so easy, damn easy. So with this we have done the eighth activity also. Let me mark this and let me get into the slides. So with this, the example 8, the Docker file for scheduler app has been successfully written, pushed into the GitHub, cloned into the server, then image has been built, then container has been spun, and application has been accessed through browser over the internet. So far we have created a lot of mess in our engine room, Docker engine room. So now it's time to clean up. Now it's time to clear everything. Now it's time to make our engine room so Docker engine room so neat, so clean, so tidy. So how can we do that? So we have to use, so now this is done. Yeah, exercise 8_1 housekeeping. So here we're gonna use commands such as commands commands such as docker ps, docker stop, docker rm, docker rmi, and we are going to stop the container. If the container is running, we cannot delete the container, and we can't even remove the image which is related to that container. So that's the reason the first activity to be done is to check the containers which are running. Then you have to stop the container, then delete the container, then delete the images. That's what is the procedure. So let's get into the action. So let's jump into the our Docker server or Ubuntu server. Clear the screen. So first let me give Docker ps. Lot of messes there. I think 3 containers are running, and let me give Docker psa. How many containers are stopped? Okay, same number by and large. So let me stop the containers first. Docker stop, and I have to find the names. First one is welcome container. I'm not giving. Okay, welcome message, welcome app. One I got it, and second one welcome app. Other image. So names are here. Scheduler one is one. You see that created names, and welcome app. Other one is welcome container. Okay. Welcome container. Okay. Then clean work one and scheduler one. Yeah. Welcome app, welcome container has been deleted and okay, stopped. Welcome. So all containers has been stopped. Welcome app, welcome container, clean work one, scheduler, all are stopped. Let's check the browser and see. See, before all are running, na. So even now they are running. It doesn't mean they're. It doesn't mean so they are appearing. It doesn't mean they are running. So I will refresh it and we'll see what's gonna happen. Let's wait. Gone. If your container is not running, how can this run? Gone. Because we stopped the container. Gone. It should, and it had. So it had gone because we have stopped the containers. So now let us check Docker ps. Not even a single container is running. So now let me do Docker ps here one more time just to cross check. Okay. So now let us remove the containers. Docker rm, and tell me the container name one by one. What's the first container? Welcome app. Second one is welcome container, and third one is clean work, and last one is scheduler one. That's it. All the containers has been deleted. Now you should not find any container anywhere. No container. Docker ps option here, no container. Completely cleaned. The containers have been removed. So now it's little better. Before it was messy, now it's little better. Containers were removed, but still there is lot of messes there. Lot of, what is that? Docker images. You see, too many images, too many. Do you want this much of mess in your room? You don't want, nah? Then why do you want to keep here? Same thing we're gonna do. We are going to clean it up. So to clean it up, simple. Docker rmi, and start giving the names of each image. Ubuntu latest, Node 18 Alpine, nginx latest, welcome version 1, kubecheren clean work version 2, kubecheren welcome app version 1, kubecheren scheduler version 1. Done. All are being deleted. Oh, okay, it's been deleted. It's been deleted. Now let me say docker r docker images. That's it. Gone. Docker ps option a gone. Docker ps gone. So no image, no docker image, no docker container. So it's completely cleaned and neat, tidy. So our docker engine room is clean and tidy. That's what we call it as a housekeeping of docker engine room, or housekeeping simply. So this we have done it in our server in Ubuntu or Docker server. Now let's do that in even Docker desktop also. So for Docker desktop, I will check images. It's been cleaned, not even a single image. And containers, oh, not even a single container. It's absolutely clean. It's absolutely cleaned and neat and tidy. So this is how we clean our servers. You stop, you check the container status, you stop the container, then you delete the container, then you list out the images and you delete the images. That's how you clean up your server. That's how you clean up your engine room. You have to keep your Docker spaces clean so that while you are working you will not have any confusion. So that is the reason I'm saying this. Now let's see how basically Docker helps us, how Docker makes our life easy, how Docker makes lives of the operations team easy. So first example that we have taken, this is my server, so that I have provisioned, and this is your server, so that you have provisioned, whoever is watching this video. Okay, so then I have written a Docker file which consists of a source code also, everything, and then I have written a Docker file, and then I have placed the Docker file inside the Git repository, and this Git repository is public. It's a public Git repository. So now I will just fetch the source code as well as Docker file into my server. It could be Ubuntu or CentOS. Then I will say build, so the image will be built. So this Docker file through Git repository, I'm gonna clone it into my server, and I will say Docker build. Then I'm gonna build my image. So the Docker app image app. Uh, so applications Docker image will be built. And similarly, as this is a public repository, you you whoever is watching this video, you also can clone the Git repository from my GitHub account, and you can also give Docker build from your server, and you can also build the Docker, that applications Docker image. So the fact of the matter is, the point to be discussed here is, one Docker file, if you put into the GitHub repository, anybody can use. You, me, your girlfriend, and my girlfriend's friend, and your girlfriend's friend, and your family, everybody, whoever wants. the whole world can use, because I have made this Git repository public. So that's how one Docker file with a source code can be used by anybody, if provided that it is placed in a public Git repository. So now I have built the Docker image. This is the output of this slide. The output of this slide is to building a Docker image. Okay, I have built this Docker image. Then after building the Docker image, I have placed this Docker image in either container registry or Docker Hub. Basically, I have pushed the Docker image that I have built in our previous slide into the Docker Hub. So you can either use container registry, but we are using Docker Hub only, or else you can use ECR, KCR. So elastic container registry you can use. So there are a lot of ways, lot of registries are available, but Docker Hub is the famous one. So I have pushed my Docker image that I have built into the I have pushed this Docker apps Docker image into Docker Hub repository. So now once the image is ready, so obviously the image consists of source code, everything, source code, service, exposed to the ports, everything it will consist of. So now this is my server and this is your server. So and you might somebody else has their server. As I have kept my Docker Hub repository public, anybody can actually say docker pull, and then once the image has been pulled, then you can say docker run and the image name, and you can run the container. That's it. Your app container will be up and running. On the other side, somebody, whoever is watching this video, they are also either from container registry or Docker Hub. They can pull the image, or they can also directly run without pulling. You just say Docker run and mention the image name with the tag. That's it. The container will be spinning in a while, maximum 2 to 3 seconds. It will be spinning in a seconds. So that's how the Docker helps us. So once the image is built and stored in a repository, in a container repository or image repository, so it is anybody in this world can just pull it and run it a container. It has become a 1 minute job, it has become a 2 minutes of job, and you can run your application within a minutes. See the magic. That's how a Docker makes our life much easy and easier. So now we will demonstrate the same concept. Let's pull the Docker image from the Docker Hub to the local machine as well as a Ubuntu server, because we are saying two servers now. So that's why, to prove it, one is Ubuntu server, so that's my server. Other one is a local host. So local host is my machine, that's Windows machine. And then another one is Ubuntu server, which is a EC2 instance. So we will pull the image into both the servers, and we will run the container and we will see the magic. Okay, first we will do it for Ubuntu server, then we will go for the local machine. Okay, so let me go to the Ubuntu server. So clear this. Okay, now I will pull the image, but before pulling that, let me get into my Docker Hub. Yeah, this is my Docker Hub. So which image I am gonna pull is Cube Charan welcome app. I want to pull welcome app. So I want to go with the tag v1. So for that, no, wrong side. Welcome app. Click on see all. Yes, see all. So then here you can copy this. Just click on this icon. The pull command has been copied. Now come to the Ubuntu or Docker server and paste it. That's it. Nothing much. Just paste it exactly and click enter. It's that easy. It's that easy. So now the image, the Docker image has been pulled. So now let me check Docker images. You will find only this image. Other than that, you won't find anything because we have cleaned up. We have cleaned up our Docker engine in our last session. Okay, in our last session. So our image is ready here also. So at the same time, we will go to our Docker, we will go to our local machine and we will pull it. Windows PowerShell run as administrator. This is in our local machine. So clear it and paste it. That's it. Okay, something wrong. Okay, let me get into the Docker Hub one more time and click on copy. Yeah. Now, yes. Now let me execute it. So we are pulling it into local machine. You see this is a local machine. It's gonna take more time because 31.4 MB and 25.47 MB means it will take more time. So by the time it gets pulled, so let's get into our Ubuntu server or Docker server, which is an EC2 instance. Okay, so now here I'm gonna run our container. So Docker run. So name of this container is welcome app. That's it. And detached mode and port mapping would be, I think I will give 8080 to 80, and name of the container, name of the image is cube charan, and welcome app, welcome app, and version 1. That's it. Your container is spinning now. So let me say Docker PS, absolutely fine. Port mapping 80 TCP and 8080. It's absolutely spinning well. So by the time, let me check the other side, local host or local machine. Okay, this is also successfully pulled into our machine. So you see that the kubeshare and welcome app dot v1. I'll say Docker images. You see that the image has been successfully pulled. Now let me, anyway, Docker desktop is also part of this, so I will see this in Docker desktop. See, kubeshare welcome app, the image has been pulled. So I will run the container here also. In spite of running in Docker desktop, I will run here only. Docker run name welcome app, same, and detached mode port, here I will say 80, map with 80, and image name cube charan welcome app version 1. Correct? That's it. Your container is been spinning. So let's get into the Docker desktop and check. We should see a container which is spinning. Yes, welcome app, and it's spinning at this one. Okay, now let's access both at a time. Okay, uh, where is this? This is our Ubuntu server or Docker server 8080. This is at 8080, and other one Docker desktop, other one is 80. Okay, now let me come to the browser. So this is the public IP of my Ubuntu server or Docker server. So I'll put 8080 port mapping, and on other side, so I need a local host, correct? So let me make these two things side by side so that at a time both will open at a time and we'll have some fun. So okay, this is, and on other side local host http local host. Yeah, this is. So let me click enter here, and let me click enter here, and this is a wrong one. Okay, this is the wrong one. I have to place it here. Okay, this is 8080. Yes, you see that 8080, and another side, this one. I will close this, and I'll directly open it from the Docker desktop because it's a local host now. I'm gonna see here. I'll click HTTP localhost 80. Okay, or I will click here. Yes, that's it. I just come. Now I will keep this here. You see that? I will show both. That's the reason. Same application or same image, obviously. Same image, same application. This is public IP of EC2 instance, which we are accessing through browser over internet. Same application, which containerized application, which is spinning from the image and Docker image, and other one which is hosted in local host. You see that same application which is containerized, and the container is spinning from the same Docker image. So both are running from the same Docker image, hence proved the power of Docker. You see that? I'll check. You see that Docker Hub? I have I have pulled the Docker Hub image. I have pulled the welcome app image to the my server, and then to the local host. Then I said run in my server. The container is up and running. I'm able to access through browser, which is an EC2 instance. So that's why I have to use internet to access it. Whereas on local host in my Windows machine, I have just run it, and I have accessed it through localhost link. So that's it. So this is the power of Docker Hub. Once you build an Docker image and pushed into Docker Hub or container registry, anybody can pull that image and build and run the container from that image in this world. Anybody can do that. That's the power of Docker Hub. So you are having a solid an image with you so that you can do anything with that. So far we have seen what is Docker and what is the history of Docker, and how does it help us, and how it makes our life much easier than before. And we have seen the life before Docker and life with Docker, and we have created our own files after looking into the basics of Docker file commands instructions. Then we have built our own Docker images. Then we have run or spin our own Docker containers, and we have done a lot of projects, and we had a lot of fun in each project. But my question is, who made all these things possible? Of course it is not you. Not you, neither you nor your machine. Something else is doing it's doing these things possible. What is it? That's Docker. Obviously that's Docker. But what part of Docker, what is there inside the Docker that it's making these things possible? So that's what we're gonna look into now. So we're gonna look inside the engine room. We'll look inside the Docker's engine room. So that means we're going to look into the architecture of the Docker, nothing else. We're going to look into the architecture. So Docker architecture. So grasping Docker architecture is key to understanding Docker more fully. So in this slide or overall session, you will get an overview of Docker's major components on your machine and on the network. And you will learn some techniques that will develop this understanding more and more. So now let's jump into the Docker architecture. Let's enter inside the Docker's engine room and we'll explore each and every component of Docker's architecture. So we're going to start with a high level look and then focus on each component, each part with techniques designed to cement your understanding on Docker. So a Docker, so now let's take it. You have two portions of the screen. One portion is completely white box. So this is a private network. This is comes under private network. This is your own network. And on other side, a light gray color is internet, which is a public network. Anybody can access this part. Okay. This is private. It's your own. Privacy is there. Here it's a public. Okay. This is clear. So now let's think. You have a host machine. This is your host machine on your private network. It could be EC2 instance. So my host machine, I'll show you now. Yeah, this is my host machine. I named it as a Docker server, and you can see that clear. Sudo I Docker help. You see that it's hosting Docker. So it is, this server is hosting Docker, so that's why I named this server as a Docker server, and this is my host machine. Similarly, you might also have a host machine in your private network. Here this is a private network of EC2 instance, so anyway we consider it as a private network. Others can't access my machine. Okay, so now let us split this into two parts. One part is Docker client, other part is Docker daemon. So Docker daemon is like a server. This works on client server architecture. So we have discussed and we have seen a lot of examples on this also. So your host machine on which you have installed the Docker, so that's the host machine will typically sits on a private network. So it consists of two uh, parts. One is main is Docker client and other one is a Docker daemon. Now a daemon with a RESTful API and a client that talks to the daemon. So this slide shows your host machine running the Docker client and daemon. You can see that you have a Docker client. You invoke the Docker client program to get information from or give instructions to the Docker daemon. Through what? Through protocol HTTP and TCP, under the hood TCP also. It doesn't possible only just HTTP. Okay, there are HTTP for TCP forward slash IP. It's a better way to put it. Okay, both protocols. Now, so a RESTful API, you see that this connection is made possible through a RESTful API is one that uses standard HTTP request types such as get, post, delete, and others to perform functions that usually correspond to those intended by HTTP's designers. So here let's look into this and we will jump into the our host machine and we'll see whether we have these things in our host machine or not. Okay, so here you see the Docker daemon. Docker daemon receives requests and returns a response from the Docker client using the HTTP requests. Okay, so you have a client and server. So Docker daemon is our server. So now let's get into the our host machine. So this is our host machine. I will make it yeah, this is enough, I guess. This works. Yeah, let me clear the screen. Yeah, fine. So now what I'm saying, I will I will I will demonstrate Docker first. Okay, what Docker client first? What is, let's look into the Docker client. So where is Docker client? Can you tell me? The Docker client is nothing but a Docker CLI. So what is Docker CLI? So it consists of that software. The client consists of set of commands. So that if that set of commands are executed, so it's gonna communicate with the Docker demo. So I will show you the Docker client. So that what you see on the screen when I say Docker and help, so this is our Docker client. Okay, so through which it could be anything, it could be Docker CLI, or it could be Windows PowerShell, or it could be anything. So through that you're you are communicating with Docker daemon. So this command line interface, this CLI, and those commands are called Docker client. So at this moment, whatever that I'm doing on screen using Docker command, so using this Docker command itself makes a client, a Docker client. You see that? If without Docker, if I give some exact same command, build, it's there is no such command itself. When you mention a Docker, so that's our Docker client. Now when I mention a Docker, then I can basically use lot of commands: build, run, tag, push, pull. A lot of commands I can use. Why? Because that's the Docker client. When I execute this will get communicated with the Docker daemon. But now I'm going to show you Docker daemon. So where is Docker daemon? So let me clear the screen. It is cd var ls. You'll find the lib ls. You should see Docker, yeah, ls. This is the Docker daemon directory, data directory. This is Docker daemon's data directory. But if you want to see the Docker daemon's JSON file, it would be in etc. So cd etc and Docker. You see that ls key.json. This is a configuration file, a daemon configuration file. Okay, so let's get back to the var lib docker, and this is our Docker daemon directory. So here you can find everything, all. So runtime, plugins, images, whatever image that you create, all those images will be saved here. Networks and volumes. So you have two types of persistent data. Persistency can be achieved two ways. One is volumes and volume mount, and second one is bind mounts. This here you can use a volume mounts technology. And containers, all containers will be stored here. And overlays, this is like a databases, the overall. So it stores everything. So this is our daemon. This is our daemon directory. So now when I execute, let's do one exercise before going to the next concept here. So let us do one exercise. I'll say Docker pull just image. I'm gonna pull image and we'll see Docker pull, it's cube charan mysql and version 1. So basically I'm giving a command using Docker. When I use Docker means it will become a Docker client. Now when I execute this Docker client will come will tell Docker daemon to pull this image from an external repository that we will discuss later, but at this moment you only see two things: Docker client and Docker daemon. So now, so when I execute this, an RESTful API request will go to the HTTP request, will go to the Docker daemon, and Docker daemon will come and act, and it will fetch or pull the this image, and we will see what's going to happen. Now I'll do ls and Docker images. You could see one image, kubectl and MySQL, and now I will go to the images, and you see that here we have overlays, image db, ls, and sha. Yeah, here is the image. You see that image pull completed. No, Docker images, where I have given. Okay, I'll give it here only. Docker images. You see that CDF3AA69F5F0 and CDF3. So F3AA69F5F0. So basically the Docker daemon is the one which pulled the image and it is stored in their directory. So that's why I call it as a Docker engine room. So more, it's a room, and most of the things will happen inside that, but the commands you have to tell her to do, you have to tell him to do this, you do that, you do that, you do this, you have to do that. And how that will be communicated? When we speak, when you speak to your girlfriend, it will be communicated either mobile phone or through message or through air, through many other. But here they use HTTP RESTful requests, RESTful API connect, or HTTP request and response. Okay, that's how it works. I hope you got the uh, understanding of this, a Docker client and HTTP and Docker daemon. So then you invoke the Docker client to get information from or give instructions to the daemon. So that's what we have did it in our exercise. Then the daemon is a server that receives requests and returns responses from the client using the HTTP protocol. So now the server will accept requests from the command line client. That's what we have used, a command line client using Docker, and then so anyone else authorized to connect, whoever can give commands, so they can give commands and the Docker daemon will act accordingly. So now, so this is all fine. So the architecture is clear, inside the engine room is clear, but how this engine room will be connected with the external world, that is also important. See, if you just keep your engine room isolated or your room completely isolated, where the power house is there, where the power is there, then how can you transfer this power to external worlds? How can you transfer it? How can you communicate with the external worlds? Only this will be completely isolated. If it is isolated, then what you can do? Isolated powerhouse is of no use. So how will you make that communication possible? How will you make that connection possible? So the daemon is also responsible for taking care of your images and containers behind the scenes, whereas the client acts as the intermediary between you and the RESTful API, nothing else. The client is not that important. Docker daemon is the powerhouse for us, and it does everything. So now, to communicate with the external world, to make that exchange possible, we need to have a registries. The daemon, you need to have a registries. Either you can create your private Docker registry, or you can go for the Docker Hub, a public repository or public registry. So whatever it may be, the connection remains same through HTTP request and response. So I will show you the private Docker registry first, and then we'll go for the Docker Hub. So a private Docker registry, let me go to the EC2 and click on ECR, Elastic Container Registry. Here you can share, here you can store your images and share and deploy containers, a lot of things you can do. So here, if you see this picture first, let me make it much bigger. Write a code, this writing a Docker file, and then push that Docker file. After that, as a Docker image, build it as a Docker image, then push that into the Amazon ECR. Then once it is pushed here, then it will be compressed and versioned, tagged, and managed the life cycle. Then your image will be stored always forever, so with tags and all those things. So whenever you want, either it could be Amazon ECS or Amazon EKS or Amazon Cloud or on premises or some other cloud or whatever it could be. You can just pull it and build your container, and then that container can be pulled into any one of these options: Amazon ECS, Amazon EKS, Amazon Cloud, or anything. So that's the power of registry. So a registry is a place where we store our images. Okay, so that if you want a private one, you can go for the Amazon ECR or Google Cloud or IBM. Every cloud has their own type of container registries to storing the images. So this is our, so now how to create that? Just go here and create a repository, and then whether you want private or public, we want a private one. Anyway, we are going to do this also in mega project, in Jenkins, in overall this iDevOps for you mega course, mega projects. In that we are going to do this. So private, and give the repository name, and create a repository, and you can start storing the images here. That's it. Of course it's not free, of course they will charge money. Don't worry. Nothing is free in this world other than my course. Really nothing is free in this world. Even I am doing this course like to use this Amazon web services and EC2 instances and various services in Amazon web services. I have to pay. I'm paying for the services of Amazon web service, and then I'm giving this course for free of cost. That's what I'm saying. That's why I'm saying nothing is free other than my course in this world. That's okay. Okay, let's get back to the work. Yeah. So, yeah, private Docker registry. So this one, and obviously here also the Docker daemon only connects, not the Docker client. Docker daemon connects with this through RESTful API or HTTP request and response way, and then if it is a private, so, or else you can do the same. You can do the same with the public repository. So public repository will be placed in inter-network, not the private network. So this will be in an inter-network. So in this case anybody can access that. So for this again, so let me show that Docker Hub also. So public repository is our Docker Hub. MySQL official image, explore, I think yeah, see, this is a public repository or public registry. Anybody can take images from here. Okay, so, and you can have another lot of other public Docker registry also. So the point of matter here is The point I just want to convey here is your client, a Docker client, calls up and instructs something to do for the Docker daemon. If the Docker daemon doesn't have that thing, then what it will do is it will immediately contact nearby or close by or known registries. Either it could be private Docker registry or it could be public Docker registry. If it is a public Docker registry, it's going to get from the Docker Hub. Private means you have to create your own and it will get it from there. And then once image has been fetched, then again Docker client says run it. Then it will run it. Again the Docker daemon. But who is working? Who is doing all these things? Docker daemon. And who is ordering to do? Docker client. And who is helping Docker daemon to do all those things? Private registry or Docker registries. It could be private or public. Okay, so the private Docker registry is a service that stores Docker images. These can be requested from any Docker daemon that has the relevant access. This registry is on an internal network and isn't publicly accessible, so it's considered private. And your host machine will typically sit on a private network, so the Docker daemon will call out to the internet to retrieve images if requested from the Docker Hub. So the Docker Hub is a public registry run by Docker Incorporation. Other public registries can also exist on the internet, and your Docker daemon can interact with them if it is provided a proper connection. So now let's demonstrate this thing one more time before we uh, go to the next slide. So what we're going to do here is, I'll show you. I will use Docker client, and using the Docker client I'll say Docker pull some image name. Then that will Docker daemon comes into the action and it's gonna fetch that Docker image or pull the Docker image from either Docker Hub or private Docker registry. So here we have only public Docker registry, so then I'll go for the Docker Hub. So from here to here to here, and it gives back, and then it will comes to the Docker daemon. We'll do this now. Let's get into the server. So I'll keep it like this. Okay, we will keep it this much only. I just want to show that that's the reason. So now let me say Docker images. You have one image that is MySQL. So now what I'm gonna do is I will use Docker client first. So Docker client, and using Docker client I'll say Docker pull okay. So I gave this command. Once I give this command, so this command will be transferred through RESTful API using as a HTTP request to the Docker daemon. Docker daemon is our server. So now this Docker daemon is going to serve the request that has been made by the Docker client, but it does not have. So I'll show that. Wait. I'll move this a little bit. Let me go up. Up, more up. Yeah. So here if you see, we are pulling it, so it is directly pulled from a remote repository, not from a local. We do not have that image on local. So then immediately what it has done, the Docker daemon has searched for the image. Anyway, we have given the repository name and after that the image name. So then it will directly go to that Docker Hub and it will ask a Docker Hub, it will request the Docker Hub to to send that image to that. Then again they use a RESTful API and HTTP request response. So it has sent that image. Now we can see that image. So all actions are done by Docker daemon. So now let me check Docker images. You see that? Here is that. Now again if you go to the cd var lib docker ls cd image overlay and image db content cd and cd sha256 and let me do ls, and this is the second image, the name, this is the second image. You see that cd yes, this is the old image and this is the new image. I will copy this. No, we will do it here only, no? Docker images. You see that db564 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 and db564. So once it pulls that image from the Docker hub, it will store it in this there in their directory, that is a Docker daemon directory, Docker daemon data directory. In that it will store. It's about image. So now we got the image, right? Now what I'm gonna do is, so at this moment we do not have even a single container. So now let me get into the containers first. ls, nothing is done. Okay, so let's spin a container from WordPress. So docker run, this will directly give without, okay, name is not required, and detached mode dp 808080, then I will give the name and it is WordPress v1 tag. So it's been created. Now let me say docker ps and you can see the container id. Here now I am inside the containers directory. Now you see the same number 751a72c and 751a72c. Okay, so that's the Docker daemon is the powerhouse. Overall in Docker ecosystem, Docker daemon is the powerhouse. Everything works from there, but all will be connected and communicated through RESTful API using HTTP request and response method. So I hope you got the clear understanding, and before we close this, let's explore the Docker engine room. So what all components are there in Docker engine room? A build kit, containers, we have seen containers, image, we have seen image, here network related overlays, plugins here, runtimes, swarm, Docker swarm related, TMP to REST volumes. So for us, the volumes is very important, cd volumes. So at this moment, okay, few amount of volumes are present because metadata metadata db is specific to Docker, so that anyway will be there, and this is backing fs block dev, and because we have spun two containers. One is MySQL, that's a database one. Second one is a WordPress. So because of that, it is there. So in addition to that, other than this, we have one more way. Main purpose of volume is, as we have discussed, if you want to have a persistent data. What is persistent data? We will come into that in a few slides. Don't worry. But for now, to have a persistent data, either you can use volume mount or bind mount. So if you go with the volume mount, so this is where the volume mounts will be placed. So let me clear the screen. So this is the architecture of Docker. So in this so the key point to take from this Docker architecture is that when you run a Docker on your machine, you may be interacting with other processes on your machine, or even services running on your network, or the internet. So now that you have a picture, you have a clear picture of how Docker is laid out. And now we will introduce various techniques relating to the different parts of uh, this slide, or different components of the Docker ecosystem. Now let's deep dive into the Docker engine room more. So let's look into some of the pipelines that connect each other and how that pipelines work. Okay, so the Docker daemon is the hub of your interactions with Docker, and as such is the best place to start gaining an understanding of all the relevant pieces. It controls access to Docker on your machine, manages the state of your containers and images, and brokers interactions with the outside world. So that's what the Docker. So now we'll look into the exactly how this Docker daemon does all these things. So that is a daemon. Basically, in this case, a daemon, the Docker daemon, a daemon is a process that runs in the background rather than under the direct control of the user. A server is a process that takes requests from a client and performs the actions required to fulfill the requests. So daemons are frequently also servers that accept requests from clients to perform actions for them. So the Docker command is a client. So the Docker command itself is a client, and the Docker daemon acts as the server doing the processing on your Docker containers and images. So let's look at the couple of techniques that illustrates the Docker effectively runs as a daemon. So the daemon, so and that your interaction with it using Docker command are limited to simple requests to perform actions, much like interactions with a web server. So the first technique allows others to connect to your Docker daemon and perform the same actions you might on your host machine. And the second illustrates the Docker containers are managed by the daemon, not your shell session. So although by default your Docker daemon is accessible only on your host, there can be a good reason to allow others to access it. So you might have a problem that you want someone to debug remotely, or you want to allow another part of your DevOps workflow to kick off a process on a host machine. So a Jenkins server or a colleague's host, or somebody, you want somebody to access your Docker, and you want your Docker to be accessed by the somebody's user, some other user. It could be a Jenkins server to automate the process, or it could be a colleague's host to do the debugging, whatever it may be. But that's the second way of doing. But first, let us look into the first part, the first technique. So how they communicate, then we will get into the second technique. So in first technique, it is pretty simple. A Docker client, that's your Docker commands, and a Docker daemon that we have seen, the Docker directory, and it's a process which is running. When I say Docker systemctl status Docker, we're going to see Docker daemon. I'll show you So then how these two are connected? Yeah, we know that a RESTful API, HTTP request, that is fine. That is fine, bro. That is not the issue here. I'm asking what utility, what is making them to connect? There should be some utility, yeah, some tool, na. What is that? That's what I'm asking. I'll show you now. Okay. Yeah, I'll make it. No, it becomes smaller, dude. Yeah. Mm, much smaller. Mm, yeah, this is fine. Okay. So sudo I clear the screen. So now let's see what is Docker client. So Docker client are our commands. So Docker, it's done. So you've seen the Docker client. Now let me show you Docker daemon. System ctl status Docker, because Docker is a process. Docker daemon is a process. You see that? Docker dot service, a Docker application container engine. You see, Docker engine. And it's loaded from where? It's loaded from lib systemmd system docker dot service. It's been enabled, and so here you will find your bin file, a binary file. That's where you will find the docker dot service. And main process id is this, and the process id name also dockered. Okay, so this is the service, and here you see the Docker socket triggered by, this is what I want to show you. Triggered by whom? This will be triggered by whom? Through Docker socket. Okay, and docs, here you will find docs and task memory total 1.2 GB, and C group. So it is used by whom? One is 2755 process id user bin dockered. Okay, this is dockered. That's absolutely fine. Container.sock. And second one is host port 800.172. Okay, this one is Docker proxy proto. This is our client. This is our client. You see that? Because 172 is our private IP of this machine, so it has become a client. And user bin docker proxy 10383, and this is container IP. It's also same. Okay, so here this is how. So who are all part of this group? 2755 container.sock, and then client, Docker client, and then main process id is this, because this is a process. It's a process which is running, and it's been loaded here. It's loaded from this directory, and it is triggered. This will be activated. This will be triggered by what? Triggered by docker.socket. Now I'm going to show you that. So now you have seen what is Docker client, and Docker client is in the same group of Docker process, the Docker daemon process, and then it's clearly mentioned the Docker daemon will be triggered by docker.socket. So now where is that docker.socket? That I'm going to show you now. So let's enter into cd /var and then run. Let me say ls. Now you should find docker.socket. Here it is. You see that? So let's do ls l pipe grep docker. You see, docker.sock. This one is s. Okay, this is neither directory nor this. It is a soft. Okay, this is a different type of file altogether. It's a socket type of file. It's a socket type of file. Other one is directory, other one is a file, whereas these are different. This is PID, process ID, and this is a socket type of file. Now a Docker client and then Docker sock and then Docker daemon. We have seen everything and their connection also we have seen. And the second part, so Docker client remains same in our host machine. Docker daemon remains same in our host machine, but the Docker daemon will get requests and will get requests from Jenkins server this time. It's not from Docker client. Of course, Docker client can also give, but even Jenkins server can also give. How? Through TCP and then public IP and then port number. So with this connection, Jenkins server can also access and operate your Docker daemon, and colleagues host also can also operate your Docker daemon. It's like you have a car and that car has a remote key, and then if you have your remote key you can operate. If somebody has that remote key, they can also operate. So that's it. The car is our Docker daemon, and then a remote key is our docker.sock, or it's basically way of connecting to the Docker daemon, and then the entity who is operating is our Docker client here. So in second case, Docker client can be from your local machine, or could be Jenkins server, or could be colleagues host. Basically, that's what third parties can access the Docker daemon, the Jenkins server, and colleagues host connect to the host's IP address on port 2375 and can read and write requests and responses using that channel. So now, so before you open up the Docker daemon, you must first shut the running one down. So how do you do this will vary depending on your operating system. If you are not sure how to do this, you can use the following commands. So this is how: sudo service docker stop or systemctl docker stop, systemctl either one, systemctl stop docker. So warning, stopping docker.service because it's a process. See, Docker daemon is a process, and it also has a engine room. In that engine room, all the components will be stored. We have seen that where lib docker, but it can still be activated by docker.socket. Okay, it is stopped. The service is stopped, but through docker.socket it's still activated. Okay, that is one. And then if you have a systemctl based startup system, then you can use systemctl stop docker. If you do not have this, then you have to use sudo service docker stop, whatever, but it's okay, whatever the way you can stop it. And if this works, you should not see any output from this command. So pscf, that effectives. And then once the Docker daemon has been stopped, you can restart it manually and open it up to the outside users, because here I am showing the way to uh, open this Docker daemon to the outside users. Okay, so you say Docker and then daemon, give capital H option, and you give the TCP and public IP and then port. So it will be open up to the external users. So this command starts Docker as a daemon, defines the host server with the H flag. So obviously H flag is for the host server, and uses the TCP protocol, opens up to all IP addresses with the that specific pattern, and opens on the standard Docker service port. So standard Docker service port is 2375. If Docker complains about daemon but not being a valid subcommand, try using the D argument instead. Okay, so you can connect from outside with the following command. Once the Docker daemon has been opened to the external world, so then it's time to connect to the this Docker daemon using this command: Docker H option TCP, and here you have to give your host IP. Okay, this is the Docker daemon's host IP, and this is your host IP, the external user's host IP, and 2375. Basically, at from your host IP at this port 2375 you can connect. That you will need to do this from inside your local machine because Docker is no longer listening in the default location. Okay, one example. So once it is done, once you if you are able to connect with that, so it's time for you to do some examples on that. In this we are running docker run detached mode enter I and port mapping 12344 to this, and name of the container is daemon, and then image is ubuntu, and we with the closed one, one more port with closed one. So the d flag here when used with docker run runs the container as a daemon here. Okay, then I flag gives the container the ability to interact with your telnet session. With p option you publish 1234 port from the container to the host, that's the mapping, and the name flag lets you give the container a name so you can refer to it later. And finally you run a simple listening echo server on 1234 with netcat, that is nc netcat server. So now let's specifically look into Docker client. So we have seen the complete whole architecture and we have seen the demonstration of that also. But now let's look into the only Docker client. Some of the facts about the Docker client. The Docker client is the simplest component in the Docker architecture. So it's what you run when you type commands like docker run or docker pull or docker push or docker build or docker tag or docker stop, docker start, docker rm, docker rmi. So on your machine its job is to communicate with the docker daemon via http requests. So in this slide we are going to see how you can snoop on messages between the docker client and the server. You will also see a couple of basic techniques to do with port mapping uh, uh, that represent baby steps towards the orchestration section later in this course. So, and a way of using your browser as a docker client. So this is your host machine. And as usual, we have seen this diagram. In your host machine, it will be split into two components, Docker client and Docker daemon, and both will be communicating using request and response architecture of HTTP and RESTful API. So this is your Docker client. When you issue a Docker commands on the command line, an HTTP request is made to the Docker server on your local machine. The Docker server carries out the command and returns an HTTP response, so which is interpreted by your Docker command. So how that will be interpreted? Who interprets it? See, whatever we have seen in our previous slide, now that we are digging deep. Previous slide we have seen about one tool called docker.socket, doc.socket. We have said it's going to do something. Okay, it's going to transfer the message, it's going to connect, it's going to trigger, but how? That I am going to show here. It's like dwelling in depth. Dig more, dig it like dig it like that. Okay, so here is a Docker client. Let's take one example. HTTP request and a response is made, then the domain Unix domain socket that I have shown you. Okay, just a minute. This is comes into the picture. So what it does is, okay, before that, so what it does is it makes communication happen via a Unix domain socket. It functions here as a file, as a tool, as a GNU utility. You can write to and read from as you could do with a TCP socket. Okay, you can use HTTP to communicate with another process without assigning a port and use the file system directory structure. That's the power of it. So this is the one is making all these things possible, because when you use HTTP protocols, HTTP request response, you require a port mapping, you require a ports to exchange the data to make all this possible. Without assigning port, your domain socket helps us to make this communication possible. I have shown it to you earlier, and if you want, I would like to show it one more time. No, this is here, sorry. You could see that docker.sock, that's a domain socket like TCP socket. Then on other side you have a Docker server. So Docker server is a standard application server written in Go that returns an HTTP response. So Docker daemon, anyway, we have seen. So that's how it works. So that's how a Docker a .sock makes these things possible. So now let's look into linking containers for port isolation. How to open up your containers to the host network by exposing ports. You won't always want to expose your services to the host machine or the outside world, but you will want to connect containers to one another. That's very much required when you're running a very big applications. So in this case, our problem statement is to allow communication between containers for internal purposes, and I'm going to use a Docker linking functionality to solve that issue. So to make that communication possible between two containers, I'm going to use Docker's linking functionality to allow containers to communicate with each other. And here what we're going to do is, this is our host machine. So in this host machine, so this is my MySQL container, and so MySQL container will be connected with the WordPress. So whatever you write as a blocks inside the WordPress, that will be stored in your MySQL database. So let's demonstrate the same. So let's run our containers in the following order. So we will start with MySQL. Okay. So we'll get into our Docker host or Docker server, and we will run our MySQL. Okay, every time same issue. EC2 management console, edit inbound rules, custom. Whenever we lose network, my IP, save rules. Yeah, rules have been saved. Now let us do that. Yeah, sudo I clear screen docker images. So docker psa, there are a lot of, yeah, one container and two images are there. Let me remove all this. Docker stop. Okay, it's an exit state. So rm wizardly gets and docker rmi, and it is cube MySQL cube WordPress. So now let's cross check. Docker images, yes, it's gone, it's cleaned up, it's wiped off completely. So now let's run our first container directly. So docker run, name I'm gonna give as database MySQL DB and option E, and environmental variable MySQL root password. I will give passwd as a password, and option D, and MySQL, sorry, image name would be cube charan MySQL version 1. Okay, let me execute this. Unable to find image locally, so that's what I was saying in that so Docker daemon will look for image locally. If it doesn't find locally, then only it will go for repository or registry, the either private registry or public registry. Okay, so Docker ps, you see, or container MySQL DB is up and running. So let me do Docker images, and you see that kubectl and MySQL version 1. So first we have given the MySQL container. So, and the name of the container that we gave is MySQL database. So that we need to copy that name, so that we can refer that name later. So I will copy this, and sorry, okay, it's been copied. Yeah. So then you also must apply an environment variable so that MySQL container can initialize a database. So when you give option E, it says the next thing that's coming in that command is an environment variable. Okay, so environment variable, we gave a SQL root password, that's a super user root password. Then you run both containers as a daemons, that's a detached one, and use the Docker Hub reference for the official image from my Docker Hub repository. So now let's run our second container, that's WordPress container, and that will be exposed to the port 80, and then let's do that. I'll put pond symbol. Yeah, now WordPress Docker run option name WP app. Then it's time to put a link option. Then I want to link the MySQL DB with the database of WP app, and map with MySQL of WP app. So I'll just give MySQL. Then I will put option P for the port mapping. Sorry, option P for the port mapping 10003, map with 80. Then finally detached mode, and give the name of image. So it is cube charan WordPress version 1, and let us execute it. So unable to find image locally, so the Docker daemon looks for image locally. If it doesn't find, then it will go and it will find that image in the respective repositories. So done. You can see that it's been pulled and it's been run. Now the containers of WordPress is also running. So now let me do Docker ps, and you see MySQL database as well as WordPress app both are running, and this is 10,003 mapped with port 80. We are going to access that, and let me check the Docker images also. You see 2 images are there, and our container is up and running. So let me take let me copy this 1003 port. Then let me get into the browser. Before I get into the browser, let me take the public IP of that and paste it here. And what is that? 1000? No, 10003. Yes, yeah, 10003. That's it. You see that? Your WordPress is up and running. Whichever language you would like to take, you can take. So I would look for Kannada or Telugu. Tamil, yeah, Kannada is here, and Telugu would be somewhere else. So, Mundu Varisu. Malayalam. See, ya, la. Malayalam. Let me click on Malayalam. Taikarak. Kodarak. This is Kodarak. Konasaginchu. Konasaginchu. This is also Koduram. I think it is Singali. That's Singali. Okay. After that, we'll take only English. Yeah, we have to provide the database name, database username, database password, database host, and then table prefix which you want. So then your WordPress will be up and running. So here you have to provide all those details, and once you give it, so it will be up and running. So anyway, we will be doing this project again using Docker Compose. So that time we will open that, but for now this is enough to prove this point. Yeah. So in the second command we have run it. Then we have linked the this database container with the WordPress container using the link option. Then that reference to a MySQL server within the WordPress container. So whenever WordPress calls, then it goes to the MySQL database and then it will respond to that. And through HTTP request, and port number 1003 is the one which we have mapped this container with. So when I give public IP of this host machine with the port ID, so that means I'm calling this host machine with the specific port. It's like, take this example. See, you have your office. Inside the office, you will have a main telephone. Outside the at reception you will have the main telephone. So when you type some extension to that, then it will be reached to the marketing team, VP, XVP, assistant, and brand team, and communication team, design team. So all the teams, each will have a port. So here the main number is your host machine's public IP, whereas port number is the extension of your telephone number. You just take that analogy, then it would be much easier. So when I use the host machine public IP and port number, then automatically it will go to that port. And which one is running at this port? WordPress container is running. Okay, WordPress container is, so this port is mapped with port 80 of WordPress container. So then automatically it will directly go to the port 80. At port 80, what is running? Our WordPress application is running inside the container. Then from here, if you click anything, if you write a blog, if you want to save it, or if you are asking for a blog, all this WordPress will call the MySQL database and it will respond with the required data. So I want to I just want to uh, uh, I just want to repeat it one more time. So your host machine public IP, and when you call this host machine public IP with this port ID, with this port number, so at this port number this WordPress container is running. So at this port number, this WordPress at this port number is mapped with the port number 80 of the WordPress container. So that's the reason when you call up this, it automatically goes to the port 80, and at this port 80 the application is running. So obviously we can access that, similar to the phone analogy. When you call the main number, then at main number some receptionist will be sitting, so that when you tell him that I want to connect with this guy with this extension, then when you tell them that extension, he will call to that extension. Okay, let's take that analogy exactly. So here the receptionist is sitting at this one. So I have called up with the main number, then I told I want to connect with port 80, then that guy will call port 80 guy. So then automatically here our application will be ready, so that I can access that from outside using 1003, using 10,003 and port 80. This is how we access it. Then let's wrap this up with Docker architecture and Docker registry. We have seen this, but one more time I just want to reiterate the same thing. So once you have created your images, you may want to share them with others. Obviously that's what main purpose, because you are not alone you are not alone living in this world, you are not alone working in this world, so you might be working in team. So this is where the concept of the Docker registry comes in. The three registries that you can see in figure are a Docker hub, and then another public Docker registry and private Docker registry. So the three registries that you see on your screen, so it depends upon their accessibility. One is on a private network, one is open to a public network. So and another is public but accessible only to those registered with Docker. So they all perform the same function with the same API, and this is how the Docker daemon knows how to communicate with them interchangeably. A Docker registry allows multiple users to push and pull images from a central store using a RESTful API. So the registry code is like Docker itself, of open source. Many companies, such as example, if you take my company, Volvo, is set up our own private registries. We have our own private registries in Microsoft Azure. Okay, to store and share our proprietary images internally. So this is what we're gonna discuss in this slide before we look more closely at Docker incorporations registry, that is Docker hub. So to set up a registry server on your local network, what we have to do? To get the registry running, issue the following command on a machine with plenty of disk space. That virtual machine should have plenty of disk space. This is one way, or else you can get into any Amazon Web Services or Google Cloud Platform or Microsoft Azure, whatever it may be. Let me show that one more time. Okay, dashboard. Let me click on ECR, Elastic Container Registry. Elastic Container Registry. So it's pretty simple. Get started. Give the name. Make it private if you want private, or public. Give the name M like learning. Done. And rest all fine. Click OK. That's it. Click create a repository. It will be done. Anyway, we will be doing this in our iDevOps for use mega course module. It is 8th module. There we will be doing this. Don't worry. We're going to do that. or else if you want to do that, if you want to directly, you have a virtual machine or you have a instance or on-premise machine. If you want to do inside that machine, you use a Docker CLI, Docker client, Docker run option D option P 5000 mapped with 5000, and here this is what the volume is. The volume mount is very important. Okay, then you volume mount it using environment variables. Okay, this forward slash symbol and home registry var lib registry. So this command makes the registry available on port 5000 of the Docker host and uses the registry folder in your home directory at var lib registry in the container, so which is where the registry in the container will store files by default. So it also specifies that the registry in the container will store files at forward slash registry. Then one on all of the machines that you want to access this registry, you have to add the uh, this uh, add this host name. You have to add the following to your daemon options. You have to attach this host name and then IP address of that, so that you can other machines can access the images that are stored inside this. Other machines can pull and push the images from this registry that you have created, the private registry. And finally, how do you push it? You say simple docker push and host name and mapped with port ID and forward slash image name and tag. That's it. This is very important. So if it is in Docker Hub, you have to use the repository name. That's why everywhere for all image I put kubecharan, kubecharan, kubecharan. If it is a private repository inside a virtual machine, then you have to put the host name mapped with the port, because that's where your registry can be accessed. Okay. So now let's look into the Docker Hub, the public repository which is available and it can be accessed by everybody. Okay, the Docker Hub is a registry maintained by Docker Incorporation. It has tens of thousands of images on it ready to download and run. So any Docker user can set up a free account and public Docker images are there and you can download it. In addition to user supplied images, there are official images maintained for reference purposes. So your images can be basically which are inside the Docker Hub uh, are protected by user authentication, and there is a starring system for popularity similar to GitHub's. So these official images can be representations of Linux distributions like Ubuntu or CentOS, or pre-installed software packages like Node.js, or whole software stacks like WordPress. WordPress is whole software stack that we have seen just now. So Docker registries enable social coding culture similar to GitHub. If you are interested in trying out a new software application or looking for a new one that serves a particular purpose, then Docker images can be an easy way to experiment without interfering with your host machine. So provisioning a VM or having to worry about installation steps. So then you can run it interactively using T option and I flags. The T flag creates a TTY device. When you mention a T option, see, it creates a TTY device, the terminal device for you, and the I flag specifies that this Docker session is interactive. So example, let's do one demonstration for that. First, let's see this. How do you pull it? We have been pulling it, but still I just want to show it. So Docker and pull image name. That's it. So the first line that shows is pull the image named node from the Docker Hub. That's what the first action. So the last step, once the pull has been completed, you can see the status, that is downloaded newer image for you, the image name and then tag. So this message, the last, you will find a message that tells you if Docker has pulled a new image. Your output may be different, depends upon the image type. Clear. Sudo I, and let's check Docker images. So we have only, okay, we have two images, that's MySQL and WordPress. So now I'm gonna pull, let me get into the my repository inside the Docker Hub. So where is that? This is, yeah, here it is. So click on repositories, this is mine. Yeah, so I have few images, Docker, MySQL, WordPress, scheduler. I'm gonna pull scheduler now, because this is also public. It doesn't make much difference whether it is my whether it is the images that I have created or an official images. It doesn't matter. So the process remains same. I'll just copy the Docker. I'll just copy the tag name so that after that it will be easy. See all. Click on see all, and you will find the, okay. So I'll say I'll do hash or the pound and paste it. Yes, now let's write, let's pull image from Docker Hub, a public repository or public registry. So Docker pull and name of the image, cube churn scheduler and version 1. So it will start pulling that. You can see that version 1, the first one, name of the image, pulling from cube churn scheduler. Then last you can see the status, downloaded newer image for cube churn scheduler version 1, and it's been placed in docker.io cube churn scheduler 1. Done. So now let's do the same. Okay, first let us check ls, sorry, clear the screen, Docker images first. You see that scheduler, we can run this interactively. We have pulled the image, now it's time to run that interactively. Docker run option it, and image name is cube churn and scheduler version 1 and bin bash. You see that? Now we are, of course there is an error, but still it can't find bin bash in this. So if you use, we'll use the same one then. Docker run option it node bin bash. So it's pulling the image and then it will run it interactively. We're gonna see that. So that's it. Downloaded image, downloaded newer image for node and tag latest, and let's run. Okay, we are inside that. You see that? We are inside. It's not a same. We are root, and this is the container ID 27. You see that this is container ID. We are inside the terminal. So this is how we use IT interactive and bin bash to enter inside the terminal of the container. So that's what we have said here. Process version, and once you enter inside that, you can give some commands. Let us give some commands. That is process dot version. Okay, this is not there. Process dot version. That's okay. Your ultimately we want to prove we are inside. Okay, let me give more commands. pwd This is root directory. Let me say ls. You see all the directories you can find inside that. Then you have time, uptime, date. You can do whatever you want once you enter inside the terminal. Now let's look into data persistence or persistent data, which is a day-to-day challenge in dealing with. So, so the aim here is to keep the data with the container in spite of containers in spite of the container was killed and removed. So containers are generally known